everyone and welcome to this comprehensive full course on automation testing. As software applications grow in complexity, ensuring their quality becomes crucial. So this is where the test automation engineers play a vital role. They design automated testing frameworks, write efficient test scripts, and ensure that the software meets the highest standards of performance and functionality. So in this course, we will walk you through the essential concepts, skills, and tools required to become a proficient test automation engineer. Whether you are a beginner or looking to enhance your testing skills, this course will provide you with the knowledge you need. Now let's outline the agenda for this automation testing full course. We will start by exploring how to become a test automation engineer, where we will understand the key skills, qualifications, and career path to excel as a test automation engineer. Next, we will cover what software testing is, where we will learn the fundamentals of software testing, its purpose, and its role in ensuring product quality. Then we will move on to the types of software testing, where we will explore different types of testing, including manual and automated approaches, followed by software testing methodologies, where we will understand methodologies like Agile, Waterfall, and DevOps for efficient testing strategies. After that, we will discuss software testing tools. In this, we will discover popular testing tools like Selenium, JUnit, and JMeter along with their use cases. Moving forward, we will discuss how to write a test case, where we will learn the structure of effective test cases to ensure comprehensive coverage. Then, we will cover what is a test plan, where we will understand the purpose of a test plan, its components, and how to create one effectively. Next, we will explore functional testing. Here, we will explore functional testing principles to verify that the software behaves as expected, followed by functional testing versus non-functional testing. Here, we will understand the differences and when to apply each type of testing. Next, we will dive into advanced testing concepts like what is API testing, where we will learn how to validate APIs using tools like Postman and Rest Assured. After that, we will discuss what Agile testing is, discover how Agile testing fits within Agile development methodologies. Next, we will explore what is unit testing, where we will learn the importance of unit tests and how frameworks like JUnits are used. Then, we will move on to what is regression testing, where we will explore regression testing strategies to ensure that the code changes do not break existing functionality. Next, we will discuss automation testing. Here, we will understand the principles of automation testing and how it enhances the testing process. Next, the test automation framework using Selenium, where we will build a structured framework using Selenium to automate web applications effectively. And finally, we will wrap up this course with test automation interview questions to prepare for the frequently asked interview questions to boost your confidence in your job interviews. But before we jump into the course content, please like, share, and subscribe to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Edureka's automation testing course is designed to help you improve and streamline your test automation strategies. With a strong focus on real-world applications, this program ensures comprehensive automation for web-based applications using Selenium and DevOps practices. The curriculum includes hands-on training in software testing, Selenium, API automation with Rest Assured, DevOps integration, Java, and performance testing with JMeter. Also, Edureka's Selenium certification training is designed to help you become a certified automation tester. This program covers working with various web element locating strategies and managing your automation environment using supported plugins. So enroll in this Selenium course to gain hands-on experience with widely used automation frameworks like data-driven, keyword-driven, hybrid, and BDD. So check out the course link in the description box below. With that said, let's get started with our first topic, which is how to become a test automation engineer.
What is software testing? So software testing is basically a process of evaluating the functionality of a software application to find any software bugs. So it checks whether the developed software met the specified requirements and identifies any defect in the software in order to produce a quality product. It is also stated as the process of verifying and validating a software product. So it checks whether the software product meets the business and technical requirements that guided its design and development. It works as per the requirement and can be implemented with the same characteristics. So now that you know what is software testing, let's see who is a testing automation engineer. So the role of the test automation engineer is to design, build, test and deploy effective test automation solutions. Now to fulfill this role, the automation engineer applies appropriate automation technologies to meet the short and long-term goals of the testing organization. So now what does automation engineer actually do? An automation engineer basically utilizes technology to improve, streamline and automate a manufacturing process. They are responsible for planning, implementation and monitoring of such technology. So now let's move ahead and have a look at the roadmap that will lead you to become a successful test automation engineer. So first of all, in order to become an automation engineer, you need to have a bachelor's degree. You will likely need to earn a bachelor's of engineering degree related to the field in which you want to work. For example, if you want to become a software testing engineer, you will need a bachelor's degree in software engineering. Now, to work in this field, you must be comfortable working closely with other professionals. You also need mathematics and science and also a little bit of computers and electronics. Now, next up, we will need to know about the basic principles of software testing, such as finding the presence of any sort of defects, how to determine the risk without exhaustive testing, early testing, defect clustering, and how to make a product fulfill business requirements without any error. Now, if you are new to the testing industry, one needs to have knowledge of programming languages such as C, C++, Java, SQL, Python, HTML. Now, along with this, if you also have a master's degree in computer science, machine learning, statistics, or any such certifications related to automation testing, it is just an added advantage. Now, some of the best certifications for a test automation engineer are CAST, that is the Certified Associate in Software Testing, CSTE, that is the Certified Software Test Engineer, and there are many more such certifications. So now let's move ahead and have a look at the job roles for a test automation engineer. Now, some of the most common job profiles include test automation, performance tester, test analyst, and QA engineer. So let's have a look at some of the statistics provided by LinkedIn on these top profiles. So here you can see the graph for the top companies in test automation, and some of the big names are Accenture, Cognizant, IBM, TCS, and Infosys. Now, the top skills that are required to become a test automation engineer include the knowledge of testing, Agile methodologies, SQL, test planning, and also you need to be well acquainted with manual testing. Now, apart from these, you need to be well acquainted with programming languages like Python, Golang, and JavaScript. You also need to be well versed with AWS, microservices, Docker, and Selenium. Now, these skills will basically help you move to a higher position as a test automation engineer and also add up to your appraisal. Okay, now talking about appraisals and hike, Edureka has released a small video just a few hours back on hike and appraisal during this season of the year, which is essentially the appraisal season. So do check out our latest video named Apna Hike Aayega. I'll leave the link in the live chat and also in the description box. Hope you guys will enjoy it. Now moving on, next up is the performance tester profile. So some of the top companies for this job role are IBM, Accenture, TCS, Cognizant, and Capgemini. Now, some of the top industries for performance tester are the IT services, computer software, telecommunications, financial services, as well as banking. Now, United States is considered to be the best preferred location for a performance tester, followed by India, UK, Canada, and Australia. Now, some of the must-have skills to become a performance tester include the knowledge of Selenium, Cucumber, Java API, Appium, Jira, Python, and also you must be profound with automation tools. So next we will talk about the test analyst job profile. Now, for this particular role, Bangalore is one of the top most preferred locations after US, UK, and Australia. And similarly, companies like Accenture, Cognizant, TCS are one of the top recruiters. Now, talking about some of these skills, you must be well versed with SQL, Jira, UAT, TDD, Confluence, and some of the scripting languages like Python, JavaScript. Also, you would need some of the automation tools. So now that you know about the different job profiles, let's have a look at the roles and responsibilities of a testing automation engineer. Now, in case of software testing, every company defines its own level of hierarchy, roles, and responsibilities. But on a broader level, if you take a look, you'll always find two levels in a software testing team. The first one is the test lead or manager. Now, a test lead is responsible for defining the testing activities for subordinates, testers, or test engineers, or responsibilities of test planning, to check if the team has all the necessary resources to execute the testing activities, to check if testing is going hand in hand with the software development in all phases, and also prepare the status report of testing activities. He is also responsible for required interactions with customers and updating project manager regularly about the progress of testing activities. Next up, we have the test engineers or the QA testers. Now, they are responsible to read all the documents and understand what needs to be tested. Now, based on the information procured in the above step, decide how it is to be tested, and inform the test lead about what all resources will be required for software testing, then develop test cases and prioritize testing activities. Then we finally execute all the test case and report defects, define severity and priority for each defect, and carry out regression testing every time when changes are made to the code to fix defects. Now, how a software application shapes up during the development process entirely depends on how the software engineering team organizes work and implements various methodologies. Now, test automation engineers can save you from the world full of codes. Enterprises completely agree with this statement, and this is the reason why you see a lot of job opportunities in automation testing industry. So here I am going to explain in detail the 7 most important steps to becoming a test automation engineer. It will also help you if you are planning to switch your career to automated testing. Now, the first one is manual testing. Now, while I understand that companies are moving towards codeless automated testing tools to reach an expert level and to keep up with the competition of automation test engineers in the industry, it is highly important to focus on manual testing concepts initially. Now, manual testing is basically a process of finding out the defects or bugs in a software program. In this method, the tester plays an important role of end user and verifies that all the features of the application are working correctly. Now, this makes a point very clear that automation testing is for experienced manual testers. The next skill is the programming skills. Now, it is very important to possess excellent technical programming skills. Now, most newcomers ask that if they need programming skills for automated testing. Now, most of the people who come up with the idea of shifting to automated testing wish to skip the coding part. Either they don't have programming knowledge or they hate coding. However, that one needs to be very proficient with manual testing skills to become a great automation testing engineer for a long-lasting career in the software testing industry. And if you are new to the testing industry, you need the following programming languages such as C, C++, Java, SQL, Python, Perl, XML, HTML, and CSS. Now, there are also a few technical skills a manual tester should master to become a brilliant automation testing engineer, such as the test architecture, test design, performance testing, configuration management, manual testing agility and interaction, communication between the teams, troubleshooting, agile, DevOps, and continuous delivery. Now, the combination of all the above mentioned skills can help you transit to automated testing easily and smoothly. Now, next up is understand the application. Now, the common application details that every automation tester needs to take care of are which programming languages have been used while developing the application, on what platform is the application built, which databases are involved, are there any web services or APIs connected to different parts of the system and how, and many more such questions. Now, these are just few points and it may vary based on the complexity of the applications. So make sure you're completely thorough with the application that you are going to test via automation testing. Now next up we have the automation testing tools. Now when learning to become a smart automation testing engineer, if we don't talk about the test automation tools, then we are doing an injustice to the industry. A major part of the companies have already started using automation testing tools. Now the main reason behind using them is their benefits to the enterprises. Some of the famous testing tools are Selenium, Testing Wiz, Ranorex, Sahi, Water, and Test Complete. Now next up is the ATLC methodology. Now ATLC stands for Automation Testing Lifecycle. Now the way we follow the life cycle of software development and testing, same is the way for automation testing as well. To understand and follow the ATLC, one needs to have experience of the following, such as the decision making in automated testing, then the test automation tools, automation testing process, then test planning, design and development, test script execution and management, and finally review and assessment of test programs. Now for each test automation requirements, a test automation engineer follows the life cycle. And to be a successful automation test engineer, you need to understand the ATLC methodology and execute it in your each test automation project. Now moving on, the next one is the test automation strategy. So once you are through with the ATLC methodology and the automated testing tools, you are well prepared to create your test automation strategy for your clients or employer. Now to become a great automation test engineer, you would be the right person to initiate with preparing the test automation strategy, finalizing the tools, overall cost and ROI calculation. Now, automation strategy creation is considered to be a very crucial part, as you would need to define and develop the path that will help you to reduce the manual testing hours and offer justice on the ROI of the clients. Now, let's move on to the final skill, which is the testing trends. Now for this, you have to stay updated with the testing trends, and this is the most important part of this industry. The most trending best practices, tools, techniques, tips and tricks will help you and your team to achieve the success in optimizing your test automation strategies and methodology. Now this generation is moving towards automation everywhere. However, there has been a lot of debate around test automation tools replacing the manual testers. But remember, the creators of test automation tools are the testers like you. So, to become a smart automation testing engineer and to be successful in this industry, you would need to really work hard with passion and dedication. So once you have mastered these skills, you are now on your way to become a successful software test automation engineer. Now, let's see some of the topmost companies that are hiring for a test automation engineer. Now, these companies are Accenture, IBM, Cognizant, Infosys, TCS, and Capgemini. So do keep an eye for an opportunity and utilize your skills to grab the offer.
Software is a highly complex thing. It depends on code that is written and maintained by others and in different locations that may be across the globe, cutting across entirely different programming languages, techniques, servers, networks, and many other things. Bugs, therefore, are an unfortunate reality for every software product. And there are a lot of risks involved in software. By risk, I just mean anything that can potentially cause a loss of something of value. This can include functional issues, or it can be scalability issues, reliability issues, security issues, or performance issues, or any other thing. Unfortunately, sometimes these issues manifest into software disasters and have caused millions of dollars in waste and sometimes even led to casualties. For example, Starbucks coffee shop was forced to give away free drinks just because of a register malfunction. A F-35 military aircraft was unable to detect the targets correctly because of a radar failure. A high voltage power line in northern Ohio, it brushed against some overgrown trees and it was shut down. Normally, the problem would have tripped an alarm in control room, but due to software issues, the alarm system failed. And that day, there was like power cut for about 24 hours in the entire city. Similarly, in 1985, Canada's Therac 25 radiation therapy machine, it malfunctioned due to some software bug and it delivered lethal radiation to patients, like leaving 3 people dead and critically injuring many others. Well, I can keep going. Software failures happen every day. You've probably experienced a software failure in the past week or even days. As simple as an app glitch on your smartphone to serious ones like cancelled flights or crashing infrastructure systems and many others. Software bugs have become so common to everyone's lives that it would be easy to simply just roll our eyes and say, hey, here we go again. But what if software professionals do that? How do companies make sure that disasters won't happen? Well, software testing. Software testing helps to find bugs. Well, if I have to define software testing, it is quality analysis of software code to understand if the software performs as expected or not, and to learn about ways in which it can be improved. Suppose you entered a baking contest and you're planning to make cookies. Chances are you will first make a small batch of cookies to test how good your recipe is and if everything tastes well and fine as you expected it to be. Well, depending on the feedback you receive about the taste and other qualities of the cookie, you would then modify your recipe and proceed for further cooking. Software testing is somewhat similar in that sense. Well, after a programmer or a team of programmers write a software program, there are information technology professionals known as testers who would then test the software to see if there are any areas where the software crashes or does not yield the results as expected. That's what software testing is all about. Well, the main objective of software testing include to verify and validate the completeness of the software product, to check if the software product meets the business and technical requirements, to identify technical bugs and to ensure that the software product is glitch-free in the end or before it's released to market, and lastly, to generate high-quality test cases and issue correct problem reports. Well, I'm sure at this point you're clear of what software testing is, right? But why do you think we need software testing? What benefits does it offer to any of us? First of all, it gives confidence in the quality of the final product for the organization producing the software product. It saves a lot of time, effort, and money for the organizations that are developing and selling the product. Because once the product is tested, they can be sure that there are no faults that would prove fatal to them or the company later on. It even offers business optimization. It confirms that an application is able to operate well and fine in all required conditions and on all different kinds of operating systems or web browsers correctly and properly. Well, this enhances user experience and customer satisfaction. Lastly, obviously all these factors contribute to money, so they bring profit to organization. In simple terms, in order to make sure that the release software is safe and it's functioning as expected, the concept of software testing was introduced. It's paramount important because software bugs, errors, defects can potentially lead to expensive or dangerous consequences in the software program, like the few of them which I mentioned earlier in the session. So the software testing is an exceptionally imaginative and an intellectual task for testers to perform. Testing of software or application consists of some principles that play a significant role for a software tester while testing the project. What I mean is there are a certain set of principles that every tester should be aware of when they're performing software testing. So what are the basic principles of software testing? Let's discuss that. First of all, software testing can help in detecting bugs. That's the basic of it, right? Testing any software or an application can help in revealing a few or some defects that may or may not be detected by developers when they develop the product. However, testing of software alone cannot confirm that your developed product or software is bug-free or error-free. Hence, it's essential to devise test cases and find out as many defects and errors as possible. So the first point or the principle here is software testing can help in detecting bugs if you have proper test cases and test scenarios. The next principle is that exhaustive testing is impossible. Well, there's no way to test all combination of data inputs, scenarios, and preconditions within an application. For example, if a single application screen contains about 10 input fields with 3 possible values, this means if you have to cover all the combinations, then you would have to create about 59,049, I guess, test scenarios. Well, that doesn't look good, and it's just for one app screen. Imagine you having 50 plus such screens. Well, in order not to spend weeks creating millions of such less possible scenarios, it's better to focus on potentially more significant test cases. The third principle is you should perform testing as early as possible. The cost of an error grows exponentially throughout the stages of software testing lifecycle. Therefore, it is important to start testing the software as soon as possible so that all the detected issues are resolved and they do not affect you later on. Next up, we have defect clustering. Well, according to a certain principle, approximately 80% of all errors are usually found in only 20% of the system modules. Therefore, if a defect is found in a particular module of the software program, the chances are that there might be other defects as well. That is why it makes sense to test that area of the product more thoroughly. And testing is context dependent. Depending on the purpose or the industry, different applications should be tested differently, right? While safety could be of primary importance for a fine tech product, it is less important for a corporate website. Well, the latter, as in the corporate website, in turn puts an emphasis on usability and speed. So according to your situation and requirements, you should choose what type of testing you want to perform. And lastly, error-free or bug-free software is just a myth. The complete absence of errors in your product does not necessarily mean that your testing was successful. No matter how much time you have spent polishing your code or improving the functionality of your product, if it's not useful or it does not meet the user expectations, it won't be adapted by the target audience or it can't be released to market. It's as simple as that. So these are certain basic principles of software testing. Well, along with the principles we discussed just now, you might have to consider some additional sources to note other principles in addition to the basic ones. With that said, the next topic that we're going to discuss here is very important concept in software testing, which is software testing lifecycle. So what exactly is software testing lifecycle? Organizing a software testing process can be quite challenging. Just like how developing a software involves a sequence of steps, testing also involves steps that can be executed in a definite sequence. This manner of executing testing in a systematic and planned way is what we call a software testing lifecycle, or STLC. Basically, it comprises of 6 phases, which include requirement analysis, test planning, test case development, environment setup, test execution, and test cycle closure. Well, I'm not going deep in here, but let's just discuss what each of these phases mean in software testing lifecycle. So the very first step in software testing lifecycle is requirement analysis. In this stage, the testing or the QA team decides what needs to be tested. There are 2 kinds of testing mainly, functional and non-functional. We'll talk more about that later on. Functional testing includes tests to evaluate how the software is functioning. And non-functional testing includes features that are behind the scenes such as performance, security, and all that concepts. So the team here considered both functional as well as non-functional requirements into consideration. Well, after a decision is made as to what aspects of testing need to be completed, the next stage is planning how the test will actually be conducted. This includes deciding the resources in terms of cost, the number of personnel that should be assigned to the testing phase, the number of hours it should take, the deadlines by which the result should be delivered, and many other things. Basically, you're planning the entire test process in this step, and there's something called a test plan document, which involves your entire plan from the first step to the last step. If you want to know more about what test plan is and how do you write a test plan, its pattern and parameters involved in that, well, there is a video called How to Generate or Create a Test Plan in Edureka software testing playlist. So please do refer to that. So the second step is basically planning everything as to how to perform, when to perform, and all that. Next up, we have test case development. One of the important stages of software testing lifecycle is developing the test cases. This includes writing out a step-by-step procedure on how tests should be executed, the expected results, the actual results, and if the test was a pass or a fail. And again, If you want to know more about test cases and how to write a best test case, well, you could refer to how to write a test case video in Edureka YouTube playlist. So coming back, test case development is a really important concept, and you have to consider many different things here when you're actually generating a test case. The fourth step is environment setup. So before the actual testing can be started, the test environment has to be set up. A testing environment is a setup of software and hardware for testing teams to execute test cases in a comfortable manner. It supports test execution with hardware, software, and network configurations. Next is nothing but test execution. The next phase is the process of executing the code and comparing the expected and the actual results. When test execution begins, the test analysis starts executing the test scripts based on the strategy which you have selected for your project. Lastly, it's test cycle closure. It involves calling out the testing team members for meeting and evaluating complete cycle criteria based on test coverage, quality, cost, time, and many other concepts. So basically here you're analyzing the test result reports and seeing how you can make them better or how you can improve them, or discussing the results, organizing, and basically discussing the entire testing lifecycle is the last step, which is test cycle closure. So these are the 6 most important phases of a software testing lifecycle. Well, when you are setting up testing environment, there are certain things that you should be aware of. First thing is that software testing is broadly classified into 2 categories, static testing and dynamic testing. Static testing initially checks the source code and software project documents to catch and prevent defects early in the software testing lifecycle. It's also called non-exhaustive technique and verification testing. It could be performed as inspections, informal and technical reviews, or it could be reviews during walkthrough meetings that you organize with team members and all that. So basically, it's an informal form of testing. But as soon as the primary preparations are finished, the team proceeds with dynamic testing, where software is tested during execution. Dynamic testing can be described by different methods, levels, and types of underlying quality analyst activities. Let's have a closer look at this segment of dynamic testing process. So first up, we have something called software testing methods. Software testing methods are nothing but the ways the tests are conducted in real. They include black box testing, white box testing, gray box testing, and ad hoc testing. So black box testing, I'm sure you might have heard of it before. It gets its name because a QA engineer here focuses on the inputs and the expected outputs without knowing how the application actually works internally and how these inputs are being processed. The purpose of this black box testing is to check the functionality of the software and making sure that it works correctly and it's meeting user demands. Next up, white box testing. Unlike black box testing, this method requires profound knowledge of the code as it involves testing of some of the structural part of the application. Therefore, generally, the developers here are directly involved in writing code, are responsible for this type of testing. The main purpose here is to enhance security, the basic flow of input-output throughout the application, and to improve the design and the usability of the product. Well, obviously, there's a combination of both black box and white box testing. That's what we call a gray box testing. It involves testing of both functional and structural part of application. So using this method, an experienced tester has partial knowledge of internal application structure, and based on this knowledge, he can design test cases while still pursuing the black box perspective. Apart from these, we also have something called ad hoc testing. This is an informal testing method as it's performed without any planning or documentation. Conducting tests informally and randomly without any formal expected results, the tester improves the steps and without even knowing executes them here. So basically in ad hoc testing, there's no documentation, no test design, no test case, no planning. So each of these methods that we discussed just now, I mean the white box, black box, and ad hoc testing, we have multiple techniques coming under these categories. For example, under white box, you have statement coverage, decision coverage, condition coverage, and multiple condition coverage. For black box testing, you have decision tables, use case testing, state transition diagram, BVA, which is nothing but boundary value analysis, equivalence partition, and under ad hoc testing, we have pair testing, monkey testing, buddy testing, and much more. If you want to know more about any of these techniques, you can refer to the software testing methodologies and techniques video or blog in Edureka playlist. So next up, we have software testing levels. A piece of software is more than a several lines of code. It is usually a multi-layer, complex system incorporating dozens of separate functional components and third-party integrations. Therefore, efficient software testing should go far beyond just finding errors in the source code. There are 4 main levels of software testing: unit testing, integration testing, system testing, and acceptance testing. Let's briefly check out what each of these levels are. So the first level of unit testing is the micro level of testing. It involves testing individual modules or a piece of code to make sure each part, or I can say unit, is working properly. Here, when I say unit, it can be a specific piece of functionality or a program or a particular procedure within an application, or it can be anything. It depends on what the tester considers a unit is. Unit testing helps verify internal design, internal logic, internal parts, as well as error handling. So after unit testing, integration testing is performed. This level tests how the units work together. Individual modules are combined and tested as a group. It's one thing if every unit of your software project is working well on their own, but how do you think they'll perform together? Well, integration testing helps you determine that and ensures that your application runs very efficiently. It identifies interface issues between modules. Well, there are a few techniques that can be used here. We have Big Bang technique, top-down approach, bottom-up approach, and many other things. To know more, you can refer to the integration testing video on the software testing Edureka playlist. The next level of testing is system testing. As name implies, all the components of software are tested as a whole in order to ensure that the overall product meets the requirements specified. System testing is particularly important because it verifies the technical, functional, and the business requirements of the software. Final level of testing is acceptance testing, or sometimes it's referred to as user acceptance testing or UAT. It determines whether or not the software is ready to be released to the market. Let's face it, guys, requirement keeps changing throughout the development process, right? And it's important that user verifies the business needs are met before the software is released into market for commercial use. So that's what UAT or user acceptance testing, the fourth one, is all about. So each level of testing has a particular purpose and it provides value to the software testing lifecycle. Some levels are on their own type of testing, for example, unit testing, but some have certain categories under them, like integration testing, like we discussed, has Big Bang approach, top-down approach, bottom-up approach, and like that. Lastly, we have software testing types. So basically, these types are approaches and the techniques that are applied at given level, like we discussed the different level, using an appropriate method to address the requirements in most sufficient manner. Well, like I said earlier, the purpose of testing and the testing tool or the strategy that you use every time keeps changing depending on the requirements, right? And that we call different types of software testing. There are a variety of software testing types and each of them serve different purpose. So broadly, it's divided into functional testing and non-functional testing. Under functional, we have unit testing, integration testing, system testing, interface testing, smoke, sanity testing, and many others. Coming to non-functional testing, we have performance testing, security, reliability, and many other things. So each of these testing types that you can see on the screen have their own purpose and the importance. Based on the requirements of your testing, you should choose the one which suits your category.
Today's world of technology is completely dominated by machines and their behavior is controlled by the software powering it. So how do we know that the machines will behave exactly the way we want them to every time? Now the answer to all these questions lie in software testing. So now let's see the different types of testing. So quality assurance or software testing is crucial because it identifies errors, bugs from a system at the beginning. By considering the problems in the base, helps return improvement in the quality of product and brings confidence in it. Now, by beginning means where it comes feasible and able to resolve the existing bugs. Now, functional testing and non-functional testing are the two kinds of testing that are performed by the QA or the software tester. So, the types of software testing are basically the key role where the tester determines the right testing for the apps. So here we have two main types of software testing, such as the functional testing and non-functional testing. Now under functional testing, we have unit testing, integration testing, system, interface, regression, and user acceptance testing. And under non-functional testing, we have documentation, installation, performance, reliability, and security testing. Also, performance testing can be divided into load, stress, endurance, and spike testing. So now let's move ahead and have a look at all of these types of testing in details. So the functional testing focuses on manual as well as automation testing. A functional testing is a bunch of various types to execute the perfect product. Now the first one is the unit testing under functional testing. So unit testing is basically a level of software testing where individual units or components of a software are tested. Now the purpose is to validate each unit of the software performs as designed. Now a unit is the smallest testable part of any software. It usually has one or a few inputs and usually just a single output. Now who performs this unit testing? It is normally performed by the software developers themselves or their peers. Now in rare cases, it may also be performed by independent software testers. Now let's have a look at the unit testing tasks. So first we have the unit test plan, under which we prepare, review, rework, and form the baseline. Next up, we have the unit test cases or scripts, where again we prepare, review, rework, and check the baseline of the scripts. And finally, we have the unit test step, where we perform our final task. Now let's have a look at some of the benefits of unit testing. Now unit testing increases confidence in changing or maintaining code. So if good unit tests are written and if they are run every time any code is changed, we will be able to promptly catch any defects introduced due to the change. Next up, codes are more reusable. In order to make unit testing possible, codes need to be modular. Now this means that codes are easier to reuse. Also, the development is faster. Now, if you do not have unit testing in place, you write your code and perform that fuzzy developer test. But if you have unit testing in place, you write the test, write the code, and run the test. Now, writing tests takes time, but the time is compensated by the less amount of time it takes to run the tests. You need not fire up the GUI and provide all those inputs. Now, the cost of fixing a defect detected during unit testing is lesser in comparison to that of defects detected at higher levels. So compare the cost of a defect detected during acceptance testing or when the software is live. Next up, debugging is very easy. So when a test fails, only the latest changes need to be debugged. So with testing at higher levels, changes made over the span of several days or weeks or months need to be scanned. Also, codes are more reliable here. Now moving on, the next type is the integration testing. So integration testing is a level of software testing where individual units are combined and tested as a group. So the purpose of this level of testing is to expose faults in the interaction between integrated units. Test drivers and test stubs are used to assist in integration testing. So who performs integration testing? For this, the developers themselves or some independent testers perform this sort of testing. Integration testing also involves a task plan such as the integration test plan, where we prepare, review, rework, and form the baseline. Also, we have integration tests, cases, or scripts under which we prepare, review, rework, and form the baseline. And finally, again, we perform the integration test. Now, let's have a look at some of the approaches of integration testing. The first one is the Big Bang. Now, Big Bang is an approach to integration testing where all or most of the units are combined together and tested at one go. Now, this approach is taken when the testing team receives the entire software in a bundle. So, what is the difference between Big Bang integration testing and system testing? Well, the former tests only the interactions between the units, while the latter tests the entire system. Next up, we have the top-down. Now, this is an approach to integration testing where top-level units are tested first and lower-level units are tested step by step after that. This approach is taken when top-down development approach is followed. The test stubs are needed to simulate lower-level units which may not be available during the initial phases. Next up, we have the bottom-up. Now, this is an approach to integration testing where bottom-level units are tested first and upper level units step by step after that. Now this approach is taken when bottom-up development approach is followed. The final one is the sandwich or the hybrid. Now this is an approach to integration testing which is a combination of top-down and bottom-up approaches. Next up, we have the system testing. System testing is a level of software testing where a complete and integrated software is tested. Now, the purpose of this test is to evaluate the system's compliance with the specified requirements. System testing is the third level of software testing performed after integration testing and before the acceptance testing. So basically, the independent testers perform the system testing. Now again, the system testing also has certain tasks such as the system test plan, where we prepare, review, rework and form the baseline. And next up, we have the system test cases, where we prepare, review, rework and form the baseline as well. And then finally perform the system test. Now let's have a look at an analogy of system testing. Now during the process of manufacturing a ballpoint pen, the cap, the body, the tail, the ink cartridge and the ballpoint are produced separately and unit tested separately. So when two or more units are ready, they are assembled and integration testing is performed. Now when the complete pen is integrated, the system testing is performed. So this was all about the system testing. Now let's move on and have a look at the interface testing. Now it basically verifies that communication between the systems are done correctly if all supported hardware or software has been tested. Now, when an application or a software or a website is developed, then there are several components of it. Those components can be server, database, etc. Now, the connection which integrates and facilitates the communication between these components is termed as an interface. So, there are three phases of interface testing in an interface lifecycle. First, we have the configuration and development. So, when the interface is configured and once the development starts, the configurations need to be verified as per the requirement. Next up is the validation. So when the development is completed, the interface needs to be validated and verified. Now this can be done as a part of unit testing also. Finally, we have the maintenance. Now once the whole software is ready, deployed and working, then the interface needs to be monitored for its performance and any new issues introduced due to the changes made or deteriorating performance. Now let's see, why do we have to perform interface testing? So it is required to check if the server execution is proper. Now error handling is done properly and appropriate error messages are shown for queries made by the application or software. It is also used to check the result when a connection to the server is reset, and also to check the security aspect when the components communicate within themselves. Interface testing is also done to check the impact of network failure on the communication between the components. Now let's have a look at few steps that ensure interface testing is successful. First one is define your requirement. Now before creating the interface tests, it is essential to understand the application. Hence, try to find answers to questions like what is the purpose of the interface or what is the workflow of the system or application. Now, defining all such answers will help you to understand the requirement. Next up is the expected output. Now, we know and understand the requirement very well. It is the time to finalize the output that we will be expecting from the tests. Not just a pass or fail. It can be some data, call to another API, etc. Third one is start small. So with interface testing, we can't directly move on with creating big test cases. Creating small test cases or calls is relatively simple. At least in small functions, create small test code and verify if the output is as expected or not. Next, try automating. Now, writing codes for testing an interface can be boring. You will not only be spending time in writing the code, but along with this, you will also have to spend time to understand the format, style, the coding language used for development, and then as an icing on the cake, you will have to make sure that your code isn't creating a problem to the app or system code. Finally, define the start and stop points. Now, before starting the execution of a test, we always decide the start and the stop point of the test, as well as decide how the entire testing process will start and end. Next up, we have the regression testing. Now, regression testing is a crucial stage for the product and very useful for the developers to identify the stability of the product with the changing requirements. Now, let's have a look at some of the techniques of regression testing. First one is retest all. Now, as the name itself suggests, the entire test cases in the test suite are re-executed to ensure that there are no bugs that have occurred because of a change in the code. Next up, we have the regression test selection. Now, in this method, test cases are selected from the test suite to be re-executed. Not the entire suite is re-executed here. Next up, we have the test case prioritization. Test cases with high priority are executed first, then the ones with medium and low priority. Finally, we have the hybrid technique. Now, this is a combination of regression test selection and test case prioritization. Now, how do we select the regression test suite? For most of the bugs found in the production environment occur because of the changes did or bugs fixed at the 11th hour, that is, the changes done at a later stage. So let's have a look at the test plan template. First, we have the document history. Now, it consists of a record of the first draft and all the updated ones. Next, we have the references column that keeps a track of all the reference documents used or required for the project while creating a test plan. Next up, we have the regression test plan that consists of all the introduction and details that are involved in the testing. Now, the final one in functional testing is the acceptance testing. Now, acceptance testing is a level of software testing where a system is tested for acceptability. The purpose of this test is to evaluate the system's compliance with the business requirements and assess whether it is acceptable for delivery. So basically, the management, sales, or the customer support performs these kind of testing. Also, the customers and the end users of the software can do the following. Acceptance testing also has a task plan such as the acceptance test plan where we prepare, review, rework and form the baseline. And then we have the acceptance test cases or checklist where we again prepare, review, rework and form the baseline and finally perform the acceptance testing. Now let's have a look at some of the types of acceptance testing. First one is the user acceptance testing. Now this is used to assess whether the product is working for the user correctly for the usage. Next up, we have the business acceptance testing. Now, this is required to assess whether the product meets the business goals and purposes or not. Next, we have the contract acceptance testing. Now, this is a contract which specifies that once the product goes live, within a predetermined period, the acceptance test must be performed and it should pass all the acceptance use cases. Then we have the operational acceptance testing. Now, this is to assess the operational readiness of the product and is a non-functional testing. It mainly includes testing of recovery, compatibility, maintainability, technical support availability, reliability, failover, localization, etc. Then we have the alpha testing. Now, this is to assess the product in the development or testing environment by a specialized testers team, usually called the alpha testers. And finally, we have the beta testing. Now, this is to assess the product by exposing it to the real end users, usually called the beta testers or beta users in their environment. Now, these were some of the functional testing. Now, let's move on and have a look at some of the non-functional testing types. Now, there are a bunch of software testing types which differentiate the job work for the QA while testing the apps. It is a testing to determine the performance of the system to measure, validate, or verify quality attribute of the system. The first one is the documentation testing. Now, documentation testing helps to estimate testing efforts required and test coverage. Now, software documentation includes test plan, test cases, and requirements section. So, there are four main focus areas when testing documentation. That is, instructions, examples, messages, and samples. So, if specific instructions are provided for certain activities, it's likely we will have test scenarios defined for those same activities. Similarly, step-by-step examples may be provided to explain GUI screen inputs, clarify syntax for commands or other interfaces, show expected outputs, or illustrate other important points. Now, when we hit a problem, for example, an error message, we should verify that the documentation for the message is correct. Now, finally, samples are sometimes documented for such things as initialization or tuning parameter input files. Now, next up, we have the installation testing. So, installation testing is a type of quality assurance work in the software industry that converges on what customers will need to do to install and set up the new software successfully. Now, the testing process may involve full, partial, or upgrades install or uninstall processes. Now, let's have a look at some of the installation testing tips. First, we need to install the full version of application. Now, in case if you are upgrading the application or previously installed a basic version, now installing the full version on same path, then system should allow you to install full version application without any error. Next, we have the automate testing efforts. Now, the flow chart will help you to create the automated scripts. Using the flow chart, you can easily make out the automated script for installation testing. Now, after execution, every test case use of the disk image to be installing on dedicated machine, which will save some time. Next up, we have the required disk space check in installation. Now, this is the most critical scenario in the installation testing. Now, the disk space checking is done using automated and manual testing method. So you can verify calculated disk space by installer is correct or not by using manually or automated tools. Now, on different file system format, the disk space may vary, like on NTFS, FAT32, and FAT16, etc. Next, we have the use of distributed testing environment. Now, to executing test cases effectively, you can use distributed testing environment, which will save your cost and time. Next, we have the automate the check of files installed after installation. So you can use the automated script to check that all the required files are installed successfully or not. Then we have the confirm for registry changes after installation. So here you have to check for registry changes after the installation of your software. Then we have the negative testing in installation testing. Now this intensely tried to break the installation process to check the behavior of application under such conditions. Finally, we have the uninstallation testing. Now you should also check for the uninstall testing to check whether the user is able to uninstall the application without any error and removing all folders and files related to installation. Next up, we have the performance testing. Now the performance testing includes load testing, stress, endurance, and spike testing. Now here, the software tester team provides performance testing on amazing projects. Now let's have a look at the types of performance testing. So we have load testing, which is a type of performance testing conducted to evaluate the behavior of a system at increasing workload. Then we have the stress testing, which is a type of performance testing conducted to evaluate the behavior of a system at or beyond the limits of its anticipated workload. Then we have the endurance testing, which is a type of performance testing conducted to evaluate the behavior of a system when a significant workload is given continuously. Finally, we have the spike testing, which is a type of performance testing conducted to evaluate the behavior of a system when the load is suddenly and substantially increased. Now let's have a look at some of the tips for performance testing. So first, we have to establish a test environment as close to the production environment as possible. Then we have to isolate the test environment even from the QA or UAT environment. Though there is no perfect tool for performance testing, research and decide on the tool that best fits your purpose. Also, do not rely on the results of just one test. You should conduct multiple tests to arrive at an average number. Be wary of any changes to the test environment from one test to the other. Next up, we have the reliability testing. Now, reliability testing assures that the product is fault-free and is reliable for its intended purpose. It is about exercising an application so that failures are discovered before the system deployed. Now, let's have a look at some of the types of reliability testing. First, we have the feature test. Now, in this, each function in the software should be executed at least once, and the interaction between two or more functions should be reduced. Also, each function should undergo proper execution or functional test. Next, we have the regression test. So whenever any new functionality is added or old functionalities are removed in an application, it undergoes a regression test to make sure with introduction of new functionality, no new bugs are introduced. Then we have the load test. Now, load test is done to test whether the application is supporting the required load without getting breakdown. Now, in order to find the breakpoint of an application, the load is gradually increased until the application gets hung. Now, let's have a look at some of the importance of reliability testing. As we know, software applications are in use in almost every sector of manufacturing, healthcare, defense, government, telecommunication, etc. Therefore, the question is that how reliable the software application is. This question is very important because the reliable software is of great use and the organization working on it can feel the confidence in their business systems. Now, the test cases should be designed covering all the required functionality of the software application, and these test cases should be executed for sufficient amount of time to get a rough estimate of how long the software can execute fine without failure. Now, the test case execution sequence to run the overall functionality of the software application should match the real production operational plan of the application. Now, moving on, let's have a look at the final type of non-functional testing. The next type is the security testing. Now, the security word itself defines that something has to relate with technique to strengthen the security. It's not about securing data and information. It can affect the whole functionality of the system. So, there are basically four main focus areas that are to be considered in security testing. That is the network security, which involves looking for vulnerabilities in the network infrastructure. Then we have client security, which ensures that the client cannot be manipulated and the server code and its technologies are robust enough to fend off any intrusion. Now let's have a look at some of the security testing techniques. The first one is access to application. So whether it is a desktop application or a website, access security is implemented by roles and rights management. It is often done implicitly while covering functionality. Then we have the data protection. Now there are three aspects of data security. First one is that a user can view or utilize only the data which he is supposed to use. The second aspect of data protection is related to how that data is stored in the database. And the last one is an extension of the second aspect. Proper security measures must be adopted when the flow of sensitive or business critical data occurs. Next up, we have the brute force attack. Now, the brute force attack is mostly done by some software tools. The concept is that by using a valid user ID, the software attempts to guess the associated password by trying to log in again and again. Then we have the SQL injection and XSS. So conceptually speaking, the theme of both these hacking attempts is similar. So for all input fields of the website, field length should be defined small enough to restrict input of any script. Then we have the service access points. So when there is a large number of the target audience, the access points should be open enough to facilitate all users, accommodating enough to fulfill all users' requests, and secure enough to cope with any security trial. Next up, we have the session management. So you can test for session expiry after particular idle time, session termination after maximum lifetime, session termination after logout, check for session cookie scope, etc. Then we have the error handling. So the error codes are returned with a detailed message. These messages should not contain any critical information that can be used for hacking purpose. Finally, we have the specific risky functionalities. Now mainly the two risky functionalities are payments and file uploads. These functionalities should be tested very well. So these were the different types of software testing that are involved in our everyday life.
So when I say testing methodology, I mean combinations of principles, ideas, methods, and concepts that help you during the testing process. Testing methodologies are simply strategies and approaches used to test a particular product to make sure that it fits the purpose. So as software applications get more and more complex and get intertwined with many different platforms and devices, it's more important than ever to have a robust testing methodology. Because a methodology, it manages user requirements, test cases, bugs, all in single integrated test environment. It offers full traceability throughout the testing lifecycle. It acts as a complete testing solution that includes management requirements, test case designs, release management, and many other things. It provides a complete picture of software product and its health issues, or you can say status. It leverages current technology investments and many other automated testing solutions and offers best testing experience. That is why when you start with testing, you need to have a proper suitable testing methodology. Guys, nowadays there are dozens of software testing methodologies, each with their own starting points, duration of execution, and methods that are used in each step. The more well-known among those are we have waterfall model, we have V model, Agile model, spiral model. You have something called RUP, that's Rational Unified Process, and RAD model, that's nothing but Rapid Application Development Model, Extreme Programming, and many others. Choosing the proper one can be a harsh experience. That's why you should know what each model means, what they has to offer, what are the disadvantages, where they're applicable, where they're not applicable, and their advantages. So in this session, we're going to discuss each of these models in brief. But before we proceed any further, I want to let you know guys one thing. People often combine software development models with software testing models because the development of the software and the testing most of the time are done in parallel. Not exactly parallel, but as soon as the software is developed, it's sent to testing. So when they mean software testing methodologies, they're almost same as software development models itself. Don't confuse. Anyway, let's get started with our first model, which is waterfall model. I'm sure you've heard of waterfall model, right? It's one of the most popular model in software engineering. Well, the waterfall model is one of the oldest models developed by Winston Royce in 1970. It's also known as linear sequential lifecycle model. The traditional waterfall testing approach, it represents multiple stages in a sequential manner that flows progressively downward, just like a waterfall. Hence the name waterfall model. It means that you can move to the next phase of the development or testing only after you have completed the previous phase successfully. So once a phase of development is completed, you can proceed to next phase and there's no turning back. As in, once you start with the design phase, you cannot go back to the requirement phase. This approach is useful when requirements are well known, you're sure about the technology and you have understood the technology, and all the resources with required expertise are available and they are at hand. In such cases, this model is highly useful. As you can see, it has like 5 phases. First, you begin with requirement phase. That's nothing but capture and analyze all the requirements and make sure whether they are testable or not. Then you have system design. You create and document designs based on the requirements which you collected in the previous phase. You define the hardware and the software requirements as well. Next up, we have implementation. You create robust code for components as per design and then integrate them. And obviously, next we have verification. That's nothing but testing. Integrated components, they form a whole system. Here you make sure if the system is working as per the requirements. You also keep track and report the testing process. You also make sure that the system is stable with 0 bugs and it passes all the test criteria and environment setup is perfect. So basically, in this step, you're making sure that your product is perfect. And lastly, you have system maintenance. You make sure if the application is working efficiently as per the requirement within the suitable environment. In a case a defect is found, then that should be fixed and deployed or updated and later on. So that's all about waterfall model. Talking about advantages and disadvantages, the main advantage of waterfall model is that it allows for departmentalization and managerial control. Apart from that, it's very easy to understand and easy to manage. Because it's easy to understand, it allows for easy testing and analysis. It saves significant amount of time. Talking about disadvantages, the disadvantage of waterfall model is that it does not allow for much revision. So once an application is in the testing phase, it's very difficult to go back and change something, like I said earlier. Because of that, it's short on flexibility. It lacks the visibility of the current progress, as in you cannot see what's happening right away. And the most important thing is changes in the business requirements or new additions in functionality require changing all the previous steps. Lastly, the end product is available only at the end of the cycle. So these are some disadvantages. Next up, we have V model. So V model is basically an extension of waterfall model where the process execution takes place in a sequential manner but in V shape, which is clearly visible on the screen. As you can see, there's an image. So as you can see in the image below, there exists a directly associated testing phase in each phase of development cycle. As you can see, the requirement analysis is associated with operational testing and acceptance testing. Then you have high-level design, which is associated with integration testing. Similarly, detailed specification is associated with unit testing. So basically, using this V model, you can perform static testing, verification, and review that helps to prevent possible defects in the later stages. Well, you can say that this model is basically divided into 3 phases. We have verification phase, next up is the coding phase, and validation phase. And verification phase and validation phase are done in parallel, or you can say each testing phase is associated with a phase of development cycle. So guys, the phases of V model are changeable, but usually they include the following phases. As you can see, requirement phase is associated with acceptance testing. Its main purpose is to evaluate if the system is ready for the final usage. Then you have high-level design phase, which relates to system testing and includes evaluation of compliance of specified requirements to the integrated system. And next up, we have detailed design phase, which is in parallel to integration testing that checks the interactions between different system components. After that, the coding stage begins, where you have another necessary phase that's nothing but unit testing. It's important to make sure that the behavior of individual parts and the components of your software is correct and it meets the requirement. So basically in coding, this phase, it contains actual coding in the development lifecycle. So programming languages should be chosen based on your requirements. Talking about advantages and disadvantages of this model, like I said, it's just an extension of waterfall model. So the advantages and disadvantages are almost similar. Apart from that, it's simple to use, easy to understand, it's good for small projects, and it's highly cost effective when compared to waterfall model. And there's no overlapping between the phases because as you can see, the entire process is sequential. Talking about disadvantages, just like waterfall model, no inherent ability to respond to changes. You have to change all the steps. And testing is usually squeezed in the end. And the absence of clear solutions that eliminate the software defects, that's one of the most important disadvantages of V model. And it's not suitable for large and complex projects. That's it about the V model. Let's move on to next model, which is incremental model. Well, everything is said in the name itself. You can consider the incremental model as a multi-waterfall model of software testing. The whole incremental process here is divided into various numbers of cycles. Each of them is further divided into smaller modules. Each iterations add a specific functionality to the software. So an increment here actually includes 3 cycles: software designing and development, testing, and implementation. As you can see in the diagram, I have build 1, which includes all the 3 phases. Then I have build 2. A functionality has been added in the build 1. And then we move on to the build 2 and add another functionality. That way, you develop a product in incremental process. Another good thing with this model is that simultaneous development of different product versions is possible. For example, the first version can pass the testing phase, while the second one passes the development phase. The third version in turn can pass the designing phase at the same time. So simultaneously, you can develop different product versions. Well, you can continue this until your product is perfectly developed. Well, it all says in the name itself, right? Incremental model. As you go on in every build, you add a new functionality. And at a single point of time, you can have multiple builds or multiple versions being developed. The advantage is that it's more flexible and it's cheaper when you have change of requirements. Also, the software testing process here is more effective since it's easier to test and debug if you are using smaller iterations. But the disadvantage is that it's costlier when compared to waterfall model. That's all about the incremental model. It's simple. Next up, we have Agile model. Agile, as you guys know, has become one of the most popular software development methodology in recent years. In parallel, it's also known as software testing methodology. So majority of firms use Agile techniques in some capacity or other for software development and testing projects. So with Agile, developers build software incrementally. Well, you can say it's a type of incremental software testing technique. So they break the project down into small segments of user functionality, which we call stories, prioritize them, and then continuously deliver them in 2-week cycles called sprints. The testing methodology is also incremental. Each small release is thoroughly tested to ensure quality. As you can see, I have increment 1. I have request phase. After that, it's tested, it's coded and designed. So you can see that increment is a small release. It's tested perfectly for each and every defect and the quality is ensured, and then we move on to the next increment. And we have the same process being done again, but we add furthermore functionalities to the previous iteration. So basically, this entire process of iteration allows testers to work in parallel with the rest of the project team throughout the process and fix the flaws and errors immediately after they occur. So the main goal of this approach is that they have to deliver a new software feature fast and that too with the best quality. So it focuses on responding to the change rather than extensive planning like in waterfall model. Waterfall model is all about planning one phase after other and not going back again. But here, if you have a requirements change, you interact with the other team or the other increment and make the changes as soon as possible and release the product in small cycles. So that's the profit of Agile model. Next up, we have advantages. So as you can see, it has a lot of advantages to offer. It's an adaptive approach that responds easily to the changes, unlike waterfall model. Since flaws and defects are easily found and corrected, the quality of the product will also be improved and it will be best. It allows for the direct communication between the testers and other people involved in the testing process or the software development process. It's highly suitable for the large and long-term projects because you can release the product in small iterations. So that's what makes it more suitable for large and long-term projects. It promotes teamwork because it allows for direct communication, which directly affects the teamwork. It's easy to manage because we are handling the small release cycles in every iteration. And lastly, it requires minimum requirements or resources, you can say. Talking about disadvantages, it's highly dependent on customer feedback. So every small iteration you release it to market, you wait for the customer feedback, and based on that, you develop the next iteration. Obviously, there are bugs. In addition to that, you also take the customer feedback as well. So it's highly dependent on clear customer requirements upfront. And there's this maintainability risk involved. It's difficult to predict time and effort for large projects. It lacks documentation efficiency. It's not suitable for complex project, and there are chances of getting off track as the outcome of each stage is not that clear. Next, we have spiral model. Spiral model is similar to incremental model with more emphasis placed on risk analysis. So basically, here the importance is given to risk analysis. The spiral model has 4 phases. You have planning, risk analysis, engineering and execution, and evaluation. A software project repeatedly passes through these phases in iterations, which we call spirals here. So once the first cycle is completed, the second cycle starts. Software testing starts from planning and it lasts until the evaluation phase. So the main advantages of this spiral methodology is that immediate test feedback that's ready at the third stage of each cycle. Since the feedback is available in every sprint or spiral in this model, it helps to guarantee the quality of the product, just like your agile model. However, it's important to keep in mind that this model can be pretty costly one and it's not suitable for small projects. So the thing that you have to remember is that the main emphasis here is on risk analysis. And since you get the customer feedback in the third phase, the quality of the product is really high. So we already discussed the advantages. The first one is the lower amount of risk due to high risk analysis. And obviously, it ensures rapid development of the product. The quality of the product is really high because every time in every spiral at the third phase, you get a feedback. It offers strong documentation control. Requirement changes can be easily accommodated at a later date. Because this is an incremental model, just like Agile model, requirement changes can be easily accommodated. Talking about disadvantages, it can be costly to use when compared to other models. It's not suitable for small projects. You have large number of intermediate stages because you have different multiple spirals, right? It requires a lot of technical expertise. It's highly dependent on risk analysis phase. I think I just said that. So that's all about spiral model. So the last model that we'll be discussing in this session is a RAD model, or you can say rapid application development. This rapid application development model is also a form of incremental model where components are developed in parallel. So with RAD, the focus is mainly on building a prototype that looks and acts like a final product. In this approach, a prototype is created by assembling the different components of the software product that have been developed in parallel. So once you create the prototype, which is nothing but the components assembled, it is used to gather feedback from the customer. So this RAD model, spiral model, and agile model are different forms of incremental model. And as you can see in RAD model, it's divided into 5 phases, or it includes 5 phases. We have business modeling. The first phase, it identifies vital information flow between various business channels. Then we have data modeling. Information gathered from previous phase is used to define data objects. Then you have process modeling. Data objects which you got in the data modeling step are then converted to get business objective in the third phase. Then you have application generation. Various automation tools are used in this step to process the models to actual source code. And lastly, we have testing and turnover. New components and all the connecting interfaces are tested and the object or the cycle or the product is released to market. So as you can see, the entire process goes on for about 60 to 90 days. This RAD model is recommended when the product is required to be delivered within a short period of 2 to 3 months and there's a high availability of skilled resources. Talking about advantages, it reduces development and testing cycle time. It's not that expensive. And obviously, since it's an incremental model, it enhances the customer feedback due to customer involvement throughout the cycle. Talking about disadvantages, it requires highly skilled resources. If you have highly skilled resources and if you have 2 to 3 months of time and you have a product to develop, then RAD model is highly suitable. And what are the other disadvantages? Well, it requires a system that can be modularized as in divide, and it's hard to use with legacy systems. So this brings us to the end of software testing methodologies discussion. Each of these models employ a different testing methodology to test the quality and the security of software in different ways and different stages. So choosing one among them can be quite complex, and I hope that what you've learned today will help you choose a proper methodology according to your requirements. So guys, that's all about software testing methodologies. Let's get started with our next topic. As you guys already know, the main purpose of software testing is to deliver an optimum quality product at faster pace. To help tester achieve that, there are multitude of software testing techniques, each with its own strengths and weakness. But what exactly is a software technique? What do I mean when I say a technique? Software testing technique refers to the procedure or a way to test the software under test by comparing the actual and the expected results. A good software testing technique helps tester to design test case in such a way that minimal steps of test cases are involved. So the two key points with software testing techniques is that you need to have minimal test cases, but they should be able to capture maximum functionalities of the software. So with testing techniques, you can develop smarter test cases, reduce the number of steps required in test cases. So guys, in this session, we will be discussing some of the popular techniques, and I've divided these techniques into different categories. So basically, when it comes to software testing techniques, they're divided into three main categories. That would be white box testing, black box testing, and experience-based testing. So we're gonna discuss each of these techniques which come under different categories in brief. Let's begin with black box testing. So what is black box testing? Black box testing is also known as specification-based testing. Here, the testers analyze the functionality of the software or the application without knowing much about the internal structure or the design of the product. So the main purpose of this method is to check the functionality of system as a whole to make sure that it works properly and it meets user demands. Well, the key point that you have to remember is that the testers perform testing without knowing much about the product. There are a lot of testing techniques that come under black box testing. Let's discuss each of them in brief. So guys, first in the list, we have equivalence partitioning. In equivalence partitioning, input values to the system or the application which is under test are divided into different partitions or groups or classes based on its similarity in their outcome. So instead of using each and every input value, you can use a value from each class or partition which covers all the possible scenarios to execute the test cases. So that way you can easily identify valid as well as invalid equivalence classes. You don't have to perform testing for each and every possible input value. That would be really hectic. So this equivalence partitioning makes testing a lot easier and it saves a lot of time and effort on your part. Well, let's try to understand what equivalence testing is with a simple example. Let's say I have a test scenario where I have to test input conditions accepting numbers from 1 to 10 and 20 to 30. So how do I write test cases? How many test cases should I involve? Should I check every number from 0 to 10 and then 20 to 30 and then in between and all that? That would be really hectic. So what do? I have divided the number of input values into 5 possible test cases. I have taken values before 1, that's from any number of values to 0, that's just before 1, which should obviously come under invalid class because we want to test the values which come under 1 to 10 and 20 to 30. And next up we have valid values, that's the values which come under 1 to 10. Then obviously the values between 10 to 20, those are also invalid because we don't want to test those values, as in we don't want those values. After that we have values from 20 to 30 which come under valid class. Lastly, the values from 31 to beyond. Instead of picking each and every input value, From these 5 divided classes, you pick up a value and perform a test case or execute the test case. Since rest of the values come under the same category, whatever the result you get for the particular value which you take can be applied to that other values as well. For example, for a range between 11 to 19, I'm taking a value 15. So I apply 15, I get a results. Now I don't have to apply the same thing for 16, 18, 19 and on, because I'm sure they all belong under the same category, which is 11 to 19. So the result would be same as 15. That way we can reduce the number of input values that we have to test and save a lot of time and effort. I hope you have understood it, right? Let's move on to next type then. That's nothing but boundary value analysis. Well, you can say boundary value analysis is next part of equivalence partitioning. It's a well-observed truth that greater number of errors usually occur at the boundaries rather than in the center of the input domain for a test. It seems logical, right? You can find more errors at the boundary rather than the values which are at the center. So when I say boundary, it means the value near the limit where the behavior of the system usually changes. So in this boundary value analysis technique, test cases are designed to include values at the boundaries. If the input is within the boundary value, it's considered positive testing. If the input is outside the boundary value, it's considered negative testing. So it includes maximum, minimum, inside or outside edge, typical values, as in the values which come in the center, and error values. So here's a simple example to understand. Let's consider a testing scenario. Here you have to test input conditions, accepting numbers from 1 to 10. So using boundary value analysis, we can define 3 classes of test cases here. That would be input boundary values as an exact boundary values, which is nothing but 1 and 10. We want to test all the conditions accepting numbers from 1 to 10. So what are our boundaries? Exact out boundaries 1 and 10. Then you have values just below the extreme edges of input domain. That's before 1, which is nothing but 0, and before 10, which is nothing but 9. Then you have values just above the extreme edge of input domain. That's the value after 1, which is nothing but 2, and the value after 10, that's nothing but 11. So what are the boundary values that you can consider to test here? 0, 1 and 2, and 9, 10 and 11. So instead of considering all the input values, you can consider this boundary values because it's at the boundaries where the behavior of the system usually changes, and then perform testing. So that's nothing but boundary value analysis. Next up, we have decision table based technique. A decision table basically is a tabular representation of different possible conditions versus test actions. You can think of conditions as inputs while actions can be considered as outputs. So in this technique, we deal with different combinations of input values. This helps tester identify all the input values if he or she has overlooked any. Because of that very reason, it's also known as cause-effect table technique as well. So the first task here is to identify functionalities where the output depends on a combination of inputs. If there are large input set of combinations, then you can divide them into smaller subsets, which are helpful for managing a decision table. And for every function, you need to create a table, list down all type of combination of inputs and respective outputs. Let's consider a simple example. Suppose a submit button should be enabled if the user has entered all the required fields. So the test scenario here is that a submit button must and should be enabled only if the user has entered all the required fields. And when I say required fields, that would be name, email, and message. As you can see, I have 8 rules here, or 8 possible combination of inputs. The user has given name and email, but he has not given message. That would be a rule 4. Then the output would definitely come under negative case, right? Submit button will not be enabled. Suppose if the user has not given anything, that's name, email, message, he hasn't given anything. So obviously the submit button can't be enabled. Nothing happens when you click on the submit button. But suppose, let's say, the user has given a valid name, valid email, and a valid message. Then when you click on the submit button, something happens. That's nothing but action. So that way we consider different possible combination of inputs. We draw a table and we point out what's the possible output for that particular combination of input. Next up, we have state transition diagram. Well, in this approach, the tester analyzes the behavior of an application under test for different input conditions in a sequence. So you can provide positive as well as negative values to check how the application responds here. You can apply this technique when an application or the system gives a different output for same input, depending on what has happened in the earlier state. So the concept here is You can use this technique when your system is giving out different input but for the same input. And what do you call such a system? You call that system as a finite state system. You can follow 3 simple steps to perform this testing. First of all, you go ahead and create a state transition diagram, which as you can see is there on the screen. Then you build the state table to review the state transition diagram that can cause errors. Lastly, you design test cases from the state table which you have created in the step 2 and the state transition diagram which you have created in the step 1. If you guys are not familiar with what a state transition diagram is, let's go ahead and check out an example. Let's say you have to book a room. You have initiated a booking, but right now if the room is available, the room count will be decremented by 1 and the room is assigned to you. User moves in. But let's say the room is not available. Your name will be added to the waiting list. And from the waiting list, once the rooms become empty, you will be assigned a room if there's a room which is available. If not, if you or a user gives up, then he'll be removed from the waiting list. That's it. The process ends there. When you request a room for the same input, the input is what you're requesting for a room. We have 2 different outputs. 1, the room is available, you're getting a room and the room count is decremented. 2, room is not available and you're put on the waiting list. So for the same input, we have multiple output. That's what we call a finite state system. Now, once after confirming the room, the customer wants to cancel the room booking. So what he does, he cancels. And after that, the room count is incremented. If there are anyone who is in the waiting list, they're assigned with this cancelled room. And suppose if the user has moved in and he's done with it and he's reached the agreement date and he vacates the room count will be incremented and it will be archived and added to the available room list. That's how everything happens in a sequence. So guys, this state transition technique is really unique approach for testing highly complex applications which would increase test execution productivity without compromising on the test coverage. The last type under black box technique is use case testing. So first of all, a use case is basically a tool for defining the required user interaction. It depends on user actions and the response of the system to those user actions. This technique is completely functional testing approach, as in there's no programming skill required here unlike other techniques. You can follow simple 3 steps to perform use case testing. First of all, you need to identify all the possible scenarios from a use case. For each scenario, you define a test case and a condition for that test case to be executed. And lastly, for each scenario, you need to determine the test data for the test. For example, you can see a ATM system here. So that's an use case diagram which is representing a typical ATM system functionality and use cases that you can consider. The first thing is you have operator who is responsible for starting the system and shutting down the system on responsible time. Then you have a customer. So when a customer comes to ATM and he starts with whatever he's doing in the ATM, that's when a session begins. He's either withdrawing the money, depositing the money, transferring the money, or inquiring about the balance. And sometimes it's quite possible that when he's performing all that, he might enter an invalid PIN. That is also an use case which you can add to your use case diagram. And the transaction obviously has to happen from the bank, so that is also a part of use case diagram. As you can see, there's no programming here involved. You just imagine the scenario and you create a use case diagram. So this use case diagram is also one of the most popular black box testing techniques. Next up, we have white box testing techniques. So white box testing is also known as structure-based testing. Unlike black box testing, this method requires a profound knowledge of code as it includes testing of some structural part of the application. So the main purpose of this white box technique is to enhance security, check the flow of input and output through the application to improve design and usability. Just like black box, we have a lot of techniques that come under white box testing. Let's discuss each of them in detail. So you have something called statement coverage or line coverage. In this technique, every statement in the source code is executed at least once. So each line of the code is tested, which helps in pointing faulty code. In case of a flowchart, every node is to be traversed and tested at least once. So basically, this entire statement coverage or line coverage is based on the assumption that the more the code covered, the better is the testing of functionality. However, the problem here is that with these techniques, we cannot actually find the false condition in the source code. So for example, you have a certain set of code where it takes the value A and B and they're added and the value is put to C. If the C is greater than 100, then print it's done. So in statement or line coverage, what are you doing? You're checking exactly that. you're not going to check what happens if C is less than 100. So what do you do if you have a case where A and B are in such a way that when added, the value is less than 100? So this is where the next type of testing technique comes in. That's nothing but decision coverage or branch coverage. In this technique, test cases are designed so that each branch from all decision points are traversed at least once. So if you consider the previous example which we did earlier, if C is greater than 100 as the decision point, if C is greater than 100, print it's done. That's what we checked in the statement coverage or line coverage. But we didn't check what happens if C is less than 100. So at that particular decision point, you have two ways that are being traversed. So in decision coverage or branch coverage, you check both the possibilities. If C is greater than 100, print it's done, else print it's pending. So basically, this method is helpful to invalidate all the branches in the code to make sure that no branch leads to any abnormal behavior. And obviously, decision coverage includes much more than line coverage. So it's highly powerful than statement coverage, or you can say a line coverage. And next up, we have something called condition coverage or predicate coverage. Condition coverage is basically for Boolean expressions. It ensures whether all individual Boolean expressions have been covered and evaluated to both true and false. So I have a simple code here which reads X and Y value, compares them, checks if the value is 0, and if either one of them is 0, it prints 0. So basically we have two conditions here, X is equal to 0 and Y is equal to 0. Now these test conditions get true or false as their values. So one possible test case or one possible example that we can consider here is it should have two test cases. In test case 1, let's consider X 0, Y is some random value but not 0. In that case it will print 0, right, the program, because X is 0. Similarly in test case 2, you put some value to X but consider Y as 0. So again it prints 0. So in first test condition, X is evaluated to true, Y is evaluated to false. In the second condition, X is evaluated to false and Y is evaluated to true. So basically you're checking every individual Boolean expression as covered and evaluated to both true or false. Now a little bit extension of condition coverage is that multiple condition coverage. Unlike condition coverage, in multiple condition coverage, every possible combination of true or false for the conditions related to a decision has to be tested. If we consider the same example which we did for the condition coverage, I will have 4 test cases here. In first test case, I have both X and Y as 0. In the second test case, I have X is equal to 0. In the third test case, I have Y is equal to 0. And in the fourth test case, I have both of them evaluating to false, that both of them are not 0. So these are the 4 possible test cases that I can write, right? So all possible test cases I'll consider in multiple condition coverage. Hence, 4 test cases required for 2 individual conditions. Similarly, if there are n conditions, then 2 to the power n test cases would be required, just for your information. So that's all about white box techniques. Next up, we have experience-based testing. As the name indicates, these techniques are logically drawn from experience in designing test cases and test conditions. They are based on the experience, background, and skills of a person in the field of testing. So basically here the tester makes use of proper strategy and documentation plan along with the gained experience. Now let's discuss some techniques that come under experience-based technique. Well, there are about 4 to 5, but in this session we'll discuss the most important ones, which is nothing but exploratory testing and error guessing. So first up, we have exploratory testing. This technique is all about discovery, investigation, and learning. Here the tester constantly studies, analyzes the product, and accordingly applies the skills, traits, and experience to develop test strategy and test cases to perform necessary testing. So the keywords that you remember here are, he studies, analyzes the product, and according to his skills, traits, and experience, he performs the testing. It's a very suitable technique when testing team has inadequate number of specifications, requirements, and severely limited time. Error guessing. Well, it's a simple technique of guessing and detecting potential defects, bugs, and errors that are most likely to occur in software product. So in error guessing, no specific rules are applied. There are no rules and conditions as to tester should do this or that. It takes advantage of tester skills, intuition, traits, and expertise to find defects that might not be identified when other black box techniques are used. So this technique totally depends on tester's experience again. The more experienced the tester is, the more errors he can identify.
Well, another way to actually perform error guessing is that to regularly create a defect and failure list. This list can be further used to design test cases and counterattack the bugs. So guys, with error guessing, we've come to the end of the session. So that's all about software testing techniques. Each one of them serves best for the specific type of problems in the software. If we use one more than others, our test coverage will suffer, guys. So remember to choose the most suitable technique for your projects, not the most popular one. To conclude, in this session, we have learned about different testing methodologies and techniques, their disadvantages, advantages. Well, there's no such thing as one suitable methodology for all project types. The choice of testing methodology or a technique actually depends on the type of project that you're working on, customer requirements, schedule, and many other factors. So the same goes for the techniques as well. So choose wisely. So let's discuss more about the benefits of software testing tools. So first of all, tools offer higher test coverage. Using tools to perform testing offers testers achieve higher coverage with greater process consistency and relevant repetition. You can automate the repeated task with these tools and write test cases that cover maximum scenarios. So basically, software testing tools increase the test coverage. And obviously, they save time and resources used. In manual testing, you have to spend a lot of time and effort and money. The main objective of any company, as I said in the beginning, is to achieve best product with less effort, time, and money. Testing tools are very helpful in that manner. They automate the repetitive tasks, decrease the weight on humans, increase the speed and efficiency of testing. This way, they save a lot of time and other resources. Thirdly, they offer support for multiple platforms. Testing often involves performing same kind of test on multiple applications on different platforms. And believe me when I say there are multiple platforms. And doing that without help of any tools is too much work and just waste of time. Software testing tools are made in such a way that using a single tool, you can check the functionality of your software or application on multiple platforms in reasonable amount of time. So they support for multiple platforms. And next up, we have bug-free releases. Software testing tools relieve the stress that occur before every release, and they earn kudos for bug-free releases. And next you have easy finding and fixing defects. Tools help find defects in early stages of development and fix them very easily in the beginning itself. Not only the beginning stages, even later, tools speed up your testing process. They make it easy for testers to find defects. Find and fix defects of engineering and before they are found by end users. That's what these testing tools offer. And lastly, they help in faster release of software, patches, and new applications with fewer end user issues. So to tell in one sentence, software testing tools make testing more interesting, more fun, and less stressful for the team of software testers. Moving on to next part, let's see what are the characteristics of a good testing tool, or the features that a good testing tool must and should have. First of all, any software testing tool should be easy to use. If tool makes our life complex, then what is the point of using it, right? So it should be easy to use and maintain. Secondly, it should be compatible with multiple platforms and technology that you are using. Ideally, a tool should support all and most of the applications and platforms that you use in your organization for your project. And just because customers aren't running your product on Mac today doesn't mean they won't be in future. So a tool that supports a variety of different operating system configurations is great asset. So tools should have operating system compatibility and platform compatibility. It should include features for implementing checkpoints to verify values, databases, or key functionality of your application. A good tool should support record and playback test creation as well as manual creation for your automation tests. Well, apart from that, a good testing tool should have a good debugging facility. Additionally, the tool should provide detailed failure logs so that any script error can be easily identified and fixed without a lot of time. It should offer robust object identification, object and image testing abilities, and object identification. It should also support testing of a database. And finally, the most important thing, the cost. A tool should do everything you need it to do without being a slow drain on your testing budget. A good testing tool should always be worthy of your pay. So these are certain features that a good testing tool should always have. So before you go ahead and select any software testing tool, Make sure all these features are checklisted. So now that you know the features, the next question obviously would be, how do you select a proper tool that suits your requirement? Don't worry, I've got it covered for you guys. A testing tool helps a product to be market ready and climb up in the charts in terms of meeting user expectations. There are many criteria to consider while selecting the automation tool or software testing tool in general. Let's take a look at simple yet efficient approach to select the right automation tool or software testing tool for a testing project. So the first step is to understand your project requirements thoroughly. Next is to consider your existing tool or the current tool which you're using as benchmark. Then you evaluate the shortlisted tool based on certain key points. And finally, you use some sort of matrix to filter out a proper tool among the shortlisted tools. So now that we have listed down the steps, let's go through each step in deep. So the first step is always to understand your project requirements thoroughly. Firstly, you need to clearly understand whether your current software testing project needs manual or automated testing. While neither of these options are technically better or worse when compared to each other, the size, the budget, and the time allowance of a project will certainly be the factors that affect which method will work best for you. So get a deep understanding of your project requirements, such as project type, well, it's based on web or desktop or mobile, scope of the project, and the existing team's strength on code language before you actually start the testing process. You should know what precisely does one need to automate and what amount of test cases need automation and which does not. So basically the first step is you should have a thorough knowledge of your project requirements. Next step is to consider your existing tool as benchmark. You will never know if the tool is best or not unless you have some other tool to compare it with, right? Well, you can go ahead and experiment with all the tools, but it's really time consuming. So consider the current tool or the one which you're using right now as a benchmark to evaluate and determine the best automation tool that's suitable for your project. For example, let's say Selenium test automation tool is my current tool. I'll consider it as a benchmark. The advantages and drawbacks of this tool or Selenium WebDriver framework need to be understood before you actually go ahead and take next step. For example, like say Selenium is free open source tool which is available to test web applications and websites. It provides record playback tool to produce and record playback test scripts as well. It provides language support for a lot of languages like C#, Ruby, Java, Python, and Node.js, but it lacks proper customer support services or documentation. Browser compatibility is also another challenge with this tool. This way, you should know all about the current tool that you're using, pros as well as cons. So once you have compared all the tools with your current tool, make a list of selected tools. And then the tools in the shortlisted list need to be evaluated on other criterias, or you can say vital parameters, like is the tool easy to use and maintain? Does it support multiple application types? Well, they may be desktop, web, and mobile or web service based application to test, so the tool should support all these application types. Moving on, it should support multiple test environments and platforms. It should offer better scalability and access to other resources as well. The test automation tool should be extendable enough to meet the increasing or decreasing demands later on. And for testers, it should offer easy authoring of tests. I mean, a testing tool must let you create tests very quickly and efficiently. It should support integration with other kind of tools like continuous integration tools. It should also offer proper logging of results features. A software testing tool should keep a log of all the test activity and provide a detailed report for each activity. A testing tool should provide users the facility to export test results to share it among team members. Other features are like it should offer support for other features and functionalities. It should also provide mechanism for comparing the test results and many more. So these are few scenarios or you can say criterias or the vital parameters where you can evaluate tool on. After using your current tool as benchmark and shortlisting a list of tools, you can further shortlist or remove other kind of tools based on these vital parameters. So once you have a list of tools shortlisted using the 3 steps that we just talked about, the next step is to leverage a matrix technique for analysis and choose the best tool among the shortlisted ones. For example, you have something called PUG matrix, PUGH is how you spell it. It demonstrates the pros and cons of various tools using parameters which are vital for the project. So guys, these are 4 simple steps that you can follow to select a suitable testing tool for your project. Let me quickly summarize what we've learned. The first step is to properly understand the requirement of your testing project. The next step is to use a current tool or the one which you're using right now as the benchmark to evaluate rest of the tools. Compare all the tools that you have with your current tool. List out pros and cons as well. After that, from the list of shortlisted tools, evaluate them more on other features like we discussed. If the tool is easy to maintain or does it support different platforms, does it offer logging facility and many other features. And based on those vital parameters, you shortlist your tools again. And after these 3 steps from the remaining tools in your list, create a matrix and find out the best one which is suitable for your project. Well, this is not a fixed procedure or anything. It's one sort of procedure. There are others as well. You can Google them and learn more about it. So now that we know how to select a proper tool, let's take a look at different type of software tools which are available in market. So guys, there are many testing tools available that are useful in several places while testing software product. These tools can be categorized as static testing tools and dynamic testing tools. So static testing tools test the software without actually executing it. Rather, they're concerned with analyzing the code or documentation for syntax checking, consistency, etc. Static testing can be manual or even automated with the use of static analysis tools. Static analysis tools, they examine or they test the source code of program, highlight the statements with wrong syntax, undefined symbols or variables, or if there are any uninitialized variables, and so on. They also check for flaws in the logic flow of the program. Apart from that, they do not interfere with the execution of program. So basically, the software testing tools test the software without actually executing it. Next up, we have dynamic testing tools. So as the name indicates, these tools interact with the software while execution and help the testers by providing useful information about the program at different levels. This information may include number of times a particular statement is executed, or if or not all the branches of decision point have been exercised, the minimum and maximum values of variables, and so on. So basically, these tools interact with the software while execution. Well, that's one way of categorizing software testing tools. We also can categorize them as open source tools, vendor tools, and in-house tools. So what are these? First of all, open source tools. These are free to use frameworks and applications. Engineers build these tools and have source code available for free on the internet for other people to refer to. For example, you have Selenium, JMeter, and Appium. So basically, open source tools are nothing but free tools which are available online that you can use, and you can get source code as well. And as for the advantages of these open source tools, there's no license cost. Obviously, they're free. We can modify the source code if you want. And most of the time, all open source tools support all popular operating and browser environments. And as for the disadvantages, obviously there is no reliable technical support, as in you don't know who you can contact if there is any error or anything. New features may not work properly, and very less documentation for you to get started with the tool. These are the advantages and disadvantages of open source tools. Open source tools are nothing but free tools which are available along with their source code on internet for you to use. And next up, we have vendor tools. Vendor tools are basically developed by companies that come with license to use, and often they cost money and a lot. Because they're developed by an outside source, technical support is often available for use for customers. And the popular examples of vendor tools, we have Windrunner, Silk Test, QTP, and Rational Robot, and many other tools. As for the advantages, like I said earlier, vendor provides technical support if you raise any issue or complaint. New features will work properly because these tools are developed by some company. So vendors update test tools frequently. They provide sufficient documentation. That's help manual. As for the disadvantages, since these are licensed tools, they're costly. And these tools support some popular operating systems and browser environments, but that's it. They don't usually support all platforms. And lastly, we have something called in-house tools. An in-house tool is a tool that a company builds for their own use rather than purchasing vendor tools or using open source tools. For example, Microsoft developed so many test tools for their internal use. Then you have IBM, which has developed so many test tools for their internal use. And same goes with Oracle Corporation as well. So basically, in-house tools are something that companies develop for their own use rather than purchasing the vendor tools or using the free open source tools available on internet. So yeah, this is one way of categorizing software testing tools: open source, vendor, and in-house tools. We can also categorize tools based on their purpose. Like we have agile testing tools, automation testing tools, mobile testing tools, load testing, and test management tools. You also have something called user testing tools. But let's just discuss these 5 types today. So there are tons of software testing tools available these days under each of these categories. It's really hard to keep track of 100 plus software testing tools out there. So if you want to know more about any of the tool, you can actually refer to articles out there which actually list out the popular tools. We have one by Edureka as well, which is named as software testing tools. As for today's session, let's discuss selection of popular and well-known software testing tools in various categories. So the first type that we are discussing is Agile testing tools. Actually, the introduction of Agile tools has revolutionized the realm of software testing. The software testing tools not just simplify the process, but they also increase the testing credibility. Companies are adopting Agile software development methodologies such as Scrum, Extreme Programming, or XP for their projects. So Agile has become popular these days. But Agile testing comes with many challenges. It requires experimenting and trying new ideas. Anyway, few popular Agile testing tools include Jira. I'm sure you've heard of it. It's a popular Agile testing as well as project management tool which is developed by Atlassian, a software company that develop products for project managers, software developers, etc. This tool can be used for tracking defects, planning, creating reports, and managing all Agile software development projects. It supports an Agile methodology like Scrum, Kanban, and many others. And next is SoapUI. It is an agile testing tool and is most advanced REST and service-oriented architecture developed by SmartBear. SoapUI is basically used for functional testing of web services, which include web service development and invoking of web services and many other web service related functionalities. It's a free and open source tool. We did discuss what open source tools are, right? So the source code is available for you to edit. So using this tool, you can create and execute functional tests, regression tests, and load tests. It allows you to create test cases using drag and drop interface as well. So apart from these both, you also have other tools like TestTrail, JMeter, PractiTest, and many others. If you want to know more about them, you can refer to the blog by Edureka on list of software testing tools. So next category is automation testing tools. As I said earlier, automation testing these days is must for most software projects to ensure the functionality of key features. It also helps team efficiently run a large number of tests in short period of time. While on the screen, you can see a few tools that help software teams build and execute automated tests. We have something called HP Unified Functional Testing or UFT. It's formerly known as HP Quick Test Professional or QTP. Is an automated functional graphical user interface testing tool which allows the automation of user actions on a client-based computer application. It offers cool features like object recognition, error handling mechanism, and automated documentation as well. It also uses a scripting language to manipulate the object and controls of application which are under test. And I'm sure you've heard of Selenium, right? The moment you type software testing anywhere, the first thing that pops out is Selenium. It's a popular testing framework to perform web application testing across various browsers and platforms like Windows, Mac, and Linux. With Selenium, you can come up with very powerful browser-centered automation testing scripts. And these scripts are most of the time are scalable across different environments. It is also compatible with several programming languages like C#, Python, Ruby, .NET, and automation testing frameworks as well. You have another testing tool or automation testing tool spelled WATIR, and it is pronounced as water. It's an open source testing tool made up of Ruby libraries to automate web application testing. It's loaded with Ruby libraries. It also supports applications scripted in other languages as well. You can link it with databases, export your XML files, read files, spreadsheets, and synchronize code as reusable libraries. It is a very lightweight open source tool. Apart from these three, you also have Ranorex, Rational Functional Tester, Tosca, and many others. Next up, we have mobile testing tools. Mobile applications have become more and more important for businesses, and I'm sure you agree with that. So testing teams need to adapt and get ready to verify and evaluate mobile apps as part of their projects. There are various tools and online resources to help testers build their tests for mobile devices, record and run automated user interface and unit tests on these mobile applications. Some of the popular tools that you might have heard of include Appium Studio, Appium, CTest, Eggplant, Test Complete, and Cobiton. So guys, APM is the most popular mobile testing tool, and we have a separate video for APM and APM Studio in the Edureka software testing playlist. You can go ahead and refer to that video if you want to know more about these tools. We also have load testing tools. The use for websites, web applications, and application programming interface or APIs has become more and more critical in recent times. It's important to design and build them efficiently so that they can handle a huge number of requests that are coming from users. So to actually test and verify the performance of these services under load, developers can perform load and stress tests using different kind of load testing tools. For example, you have JMeter, WAPT or WAPT, Load Ninja, WebLoad, Smart Meter, Song, and many others. And lastly, we have test management tools. Software development teams can benefit by test case management tools. They can use web page management tools to manage their projects, testing resources, recording test results, and generate report to help optimize all their testing activities. So basically everything regarding tests, like creating test cases and analyzing the results of the test cases, creating some statistics based on the analyzed results. For all these purposes, they can use managed or test management tools. So there are various test management tools which are available for different needs, and the most popular ones include Zephyr, Qmetry, Qtest, TestLodge, TestRail, TestLink, and many others out there. The primary objective of any software project is to get a high quality product while reducing the cost and the time required for completing the project. And to do that, companies most of the time need to test their software before it actually goes out the door. Software testing over time has evolved as an important domain in computer science. Software testing basically is the process of executing the software or in any kind of application to find out if there are any bugs or errors in it. Before software actually goes public, programmers spend hours trying to iron out every little bug there is in an application or software. They check for any mistakes or problem in the design and the functionality of the software. Until then, the product won't be available for commercial use in the market. Finding out bugs can be a lot of fun, and it's not only for testers, but it's also for everyone who wants their application to be bug-free. Today's tester has a very high demand in IT market. Well, according to recent reports, companies contribute about 25% budget to software testing. And by 2025, it might be around 33%. So you get the point, right? The demand for testers is really high. Well, that's out of way. Now let me ask you guys a question. Is documentation really necessary in software testing? What do you think? Yes, it is. Documentation plays a very important role in software testing. Either it can be manual testing or automation testing. Here's an example to convince you people. Well, a company, let's call it ABC, had delivered a project and the project had a known issue. That delivered this project to one of its client, let's say a very angry client, and they found out the issue at client side, which became a very bad situation for the company. And as usual, all the blame was put on quality analyst of the company. The issue was something regarding the compatibility of one website. Well, when this issue was taken to higher authorities, they showed the client a written proof of not receiving any requirement asking to check the compatibility of the website. So the issue was resolved very peacefully. In a way, documented requirements save the company from getting sued. And that's how documentation comes handy. Now, if you were asked to write a test case, would you know what to do or what that is? What would a test script or a test scenario be? The first step is learning what these terms are. Each of these terms implies a different level of detail in documentation and is used for different purpose. Once a tester knows what each of these terms mean, they can figure out how to use them to describe the testing that they're doing on a daily basis. So let's get started then. The story actually begins with most detailed way to document testing, which is the test script. It is a line-by-line description of all the actions and the data needed to perform a test. A script typically has steps that try to fully describe how to use the program, like which button to press or in which order to carry out a particular action in the program as such. Sometimes they also include specific results that are expected for each step. For example, an example step might be click the X button, and for that step, example result would be the window closes. So that's what test script is. It's a detailed way of documenting what you're actually doing during or after or before the testing. The second most detailed way of documenting testing work is to use test cases. Test cases describe a specific idea that is to be tested without the detailed steps which are actually specified in test scripts. For example, a test case might say, test that discount codes can be applied on top of a sale price. This doesn't mention how to apply the code or whether there are multiple ways to apply the code. Will the tester use a link to apply a discount or enter a code or have a customer service app that apply the discount? It doesn't matter. Test cases give flexibility to the tester to decide exactly how they want to complete the test. And apart from test script and test cases, we have least detailed type of documentation, which is test scenario. A test scenario is a description of an objective a user might face when using the program. An example might be test that user can successfully log out by closing the program. Just based on that light description, tester might choose to close the program through the menu option, kill it through the task manager, turn the computer off, or see what happens when the program runs out of memory and crashes. Since test scenarios offer little information on how to complete the testing, they offer the maximum amount of flexibility to the tester who is responsible for testing. So guys, well, these are 3 ways of documenting what you're actually doing before or after testing. Apart from these, there are other types of documentation, but as for today's session, we are going to concentrate on test cases. The primary goal of a test case is to ensure whether different features within an application are working as expected under the given conditions or not. It helps validate if software is free of defects and if it is working as per the expectations of end users. The activity of writing test cases help you to think through the details and ensures you're approaching the test from as many angles as you possibly can. So basically, test cases ensure good test coverage, which is really a key functionality when it comes to testing. It improves the quality of the software and decreases the maintenance and software support costs. It allows the testers to think through different ways of validating features. As a tester, you'll have the option to think from different angles. And in test cases, you can write test cases for negative test data as well, which is often overlooked most of the time. And these test cases are reusable for future. Anyone can reference them and execute the test. And they also help you to verify that the software meets the end user requirements and the end user or a customer is really happy about your product or an application. So guys, these are few reasons why test cases are extremely useful in software testing. Test cases are powerful artifacts that are beneficial to future teammates as well as a good source of truth for how a system and particular feature should work. However, before we deep dive into the lessons for writing top-notch test cases, let us have a basic idea on the terminologies associated with them. So the primary ingredients of a test case are an ID, description, bunch of inputs, few actionable steps, as well as expected and actual results. Let's learn what each of these terms mean. First, you have test case name. The first step for writing an effective test case is giving it a name or a title that is self-explanatory. As a best practice, it's good to name the test case along the same lines as the modules that you're actually testing. For example, suppose you're testing a login page, title can be something like login page. If the tool you're using doesn't already do this, it might make sense to include a unique identifier instead of a long title. So what I'm saying is that instead of using a test case name, you can actually use an ID for the test case as well. And make sure the ID is unique for each test case. But if you are using a title or a name, it should be self-explanatory. So one look at the title name, any person who is looking at it should get to know what you're actually testing on. So moving on to next parameter, it is test case description. The description should tell the tester what they are going to test. Sometimes this session might also include other information such as test environment, test data, preconditions, assumptions and all that. A description should be easy to read and immediately communicate the high-level goal of the test. It should not be lengthy, right? So if it's actually very lengthy, nobody's going to look at it. It should be in such a way that it should be very small, and one look at it, the reader will know what it is actually about. So crisp, that's the word I'm looking for. So the next parameter is preconditions. You should include any assumptions that apply to the test or any kind of preconditions that must be met prior to the test being executed. Well, this information can include which page the user should start the test on, dependencies on the test environment, and any special setup requirements that must be done before you actually start the test. This information also helps testers keep the test steps short and concise. For instance, in our logout example, the assumptions and prerequisite can be the user is logged in and already has a valid yahoo.com email address along with the password. And as for the assumption, it could be the user is trying to access yahoo.com on a supported web browser. So anything that you want to actually mention before you actually start testing, you can do it in this preconditions. The next one is actually the test case steps. The test steps should include the necessary data and information on how to execute the test. This is perhaps the most important part of a test case. It is important to keep the steps clear and brief without leaving any essential details. In case the step is difficult to navigate, having relevant artifacts like screenshots or some sort of comments can be very helpful. And next comes test data. Testing for every data permutation and combination is really challenging and literally impossible. Hence, it becomes important to select a data set that gives you sufficient coverage. So select a data set that specifies not just the positive scenarios but negative as well. So this way you cover all round possibilities. Then you have expected result. The expected result tells the tester what they should experience as a result of test steps. It helps the tester determine if the test case passed or failed. Then comes the actual result. Actual result column in the test case specifies how the application actually behaved while test cases were being executed. If the actual and expected results are the same, it means that your test case was successful. And to show if your test case was successful or not, you can actually add one more parameter like status of the test case. Well, I haven't shown it here, but you can go ahead and add it. And finally, you have something called comments. Any useful information such as screenshots that tester can provide to developers or some sort of instructions can be included in this comment part. So guys, this is the typical format that testers follow when they write a test case. Along with these elements, testers can include additional parameters like test case priority, type of test case like is it a positive test case or a negative test case, or if you have a lot of bugs, you can actually assign an ID separate for each bug. So we have another parameter like bug ID and all. So this is not a fixed format, it depends on the tester, but basically every test case usually includes these parameters plus additional some. So now that you know about the basic format or how to represent a test case, let's go ahead and look at different techniques that you can use to write the test cases. A good test case design technique is really crucial to improving the quality of the software testing process. It helps to improve the overall quality and the effectiveness of the released software or an application. The test case design techniques are broadly classified into three major categories, which are specification-based or black box test, then you have structure-based, and finally you have something called experience-based. So let's look at each of them in more detail. Specification-based or black box test case design techniques are usually used to design test cases in a systematic manner. They use external description of the software such as technical specifications, design details, client's requirement, and more to derive the test cases. With the assistance of these test case design techniques, testers are able to develop test cases that save time and allow full test coverage. And under specification based or black box techniques, you have 5 more types. Let's look at them later. Moving on to our next major category, it's structure based or white box techniques. The structure based designs test cases based on internal structure of the software program and code. Here, developers go into minute details of the developed code and test them one by one. It's further divided into 5 categories again. And finally, the last major category is experience-based techniques. These techniques are highly dependent on testers' experience to understand the most important areas of software. They are usually based on the skills, knowledge, and the expertise of people involved in the testing phase. So these are the three major categories. Moving further, let's look at different techniques which come under the categories that we just discussed. First, under specification based or black box test, we have 5 types, like I said earlier. The first one is something called boundary value analysis, or abbreviation is BVA. This technique catches any input errors that might interrupt with the proper functionality of the program. Then you have equivalence partitioning, or EP. In this technique, the test input data is partitioned into number of classes having an equivalent number of data. So the data is distributed equally. The test cases are then designed for each class or partition that are made. This actually helps you to reduce the number of test cases. And then you have decision table testing. Here, test cases are designed on the basis of decision tables that are formulated using different combination of inputs. And then you have state transition diagram. As the name actually indicates, testers use state transition diagram to write and filter out the test cases. Finally, you have something called use case testing. In this technique, the test cases are designed to execute different business scenarios and end user functionalities. Moving on to our next major type, white box or specification based. Here again, we have 5 types. The first one is statement coverage. This technique involves execution of all the executable statements in the source code at least once. Then there is decision coverage. Well, this is also known as branch coverage. It is a testing method in which each one of the possible branches from each decision point is executed at least once to ensure all reachable code is executed. Then you have condition coverage. Condition testing is also known as predictive coverage testing. Each Boolean expression is predicted as true or false here. All the testing outcomes are at least tested once. This type of testing involves 100% coverage of the code. And then you have multiple condition testing. The purpose of multiple condition testing is basically to test the different combination of conditions to get 100% coverage, which I mentioned in the previous step, which is condition coverage. And finally, we have something called path coverage. In this technique, the source code of a program is used to find every executable path. This helps to find out all the faults within a particular code. Moving on to our next major type, it's experience based. We have something called error guessing. In this technique, the testers anticipate the errors based on their experience, availability of data, and their skill and knowledge of product failure. So that's why it's called error guessing. And then we have something called exploratory testing. This technique is used to test the application without any formal documentation. In this, the test design and the test execution are performed concurrently. So guys, these are some major popular techniques that you can use to write a test case. So the successful application of any of these test case design techniques will render test cases that ensure the success of software testing. So guys, test cases are very important for any project because they are the first step in any testing cycle. And if anything actually goes wrong at this step, it might impact as you move forward in your software testing lifecycle. Knowing how to write good test cases is extremely important. It doesn't take too much of your effort and time to write effective test scripts as long as you follow certain guidelines. Let's take a look at few guidelines or best practices that you need to follow while writing test cases. First of all, you need to consider test cases based on risk and priority. Prioritize which test cases to write based on the project timeline and the risk factors of your application. For example, a high-risk feature that is scheduled for delivery in 6 weeks might be of higher priority than a feature or a low-risk feature which is due to be released in next week. Well, there's no given formula on how to decide on the priority here. You will get to know with experience. Moving on, make sure you don't forget about the 80-20 rule. The 20% of your test should cover 80% of your application. Even writing a short scenario can uncover a significant part of your bugs. So this is basically the principle which is used behind Sanity and smoke test actually. Then start with the good enough test cases. What I mean by that is, writing tests is never done in one swoop. Many times it's better to write test cases that are good enough at the present, but be sure to revise them in future if needed. And the most important thing is, your test cases should be crisp. Test suits should be defined so that they take between 45 and 90 minutes to run. while still covering a significant area of system in one swoop. So when choosing what tests to write, focus on how they can be outsourced. Make sure your test cases can be completed by others if necessary. Next, classify test cases based on business scenario and functionality. This will allow you to look at the system from different angles. The logic here is that you need to know what test to write and when to actually write it. Differentiating will also help organize your test in the test library, so you and your team can actually choose what test cases need to be run based on the need of your testing. Another important thing, put yourself in the shoes of customer. It is often a common scenario, like we discussed one in the beginning of the session, that an angry customer would knock up at customer support explaining that software is not delivering an intended feature up according to his expectation. So while writing test scenarios, keep end users' requirement in the back of your mind, because ultimately the product or the software designed is actually for the customer, right? So that's important. Put yourself in the shoes of customer. Think like a customer. And actively use a test case management tool. Test case management tools are deemed necessary for managing a stable release cycle. They help to develop a level of transparency where everyone knows about who is working on what. They can also be used for tracking deadlines related to a bug fix and a lot more. In order to write effective test cases, it is important that you learn the practical use of your respective test case management tool. Guys, there are a lot of test case management tools in the market. You can choose the one according to your requirements and actually be sure of what you're actually using the tool for. And finally, monitor all the test cases. So when working as a remote software tester, or if there are too many software testers who are working on a similar project, then it's common for two software testers to bump on two similar test cases. Therefore, monitor all the test cases which are written by you and make sure to note them if they are unique or if they are common. Also remember to remove the irrelevant and the duplicate test cases. Well, I can keep going on, but there are way too many guidelines than I can actually cover in this session. The ones that we learned just now should be good enough for you guys to actually get started in writing test cases. So do check out for more as you progress. Now let's see a few common problems that you come across in test case writing process. The first thing is composite step. So what is a composite step? Here's an example. Let's say you're giving directions from point A to point B. When you say something like go to XYZ place and then to ABC, it doesn't make much sense, right? That's a composite step. Instead of that, you can say turn left from here and go 1 mile and then turn right on the road number 11 to arrive at place XYZ. That makes more sense. Here's an actual testing example. So as you can see, that's the wrong way of writing your test case. I have 5 steps here. The first step is to log into a website, then actually to go to real-time test session, select the configurations, and the step 4 is hit start button to run the test and perform testing of your website on respective configuration. And step 5 is to terminate the test session. Now, which do you think of these steps is a composite step? If your answer is 4, you're absolutely right. You'll get to know why. Let me show you the right way of writing it. Instead of just saying hit start button to run the test and perform testing of your website based on the respective configuration, you can just elaborate it. For example, let's say, let's start from the step 4, hit start button to run the test, scroll from the top to bottom of the web page, check all the icons and paddings are supported or not, check resolution display, and then terminate the session. Well, in the wrong way of writing, we've actually skipped all these important steps. So what I'm trying to say here is that test cases should always be self-explanatory. It is important to write the test cases as granular as possible. So guys, be granular while writing down the steps for execution. So break them down instead of making it complex and representing them in the single sentence. Another frequent mistake that you might make is including multiple conditions in one test case. Once again, let's learn from example. On the screen, you can actually see a set of steps which are included in a single test for a login function. Let's check them out. So the first step is to enter valid details and click submit, leave username field empty and click submit, leave password field empty and click submit, choose an already logged in username or password and click submit. So basically, I have included all the 4 steps in one step. Now you might be thinking, what's wrong with that? It's saving a lot of documentation, and what I can do in 4 steps is actually I'm doing in 1 step. Isn't that great? Well, not quite. Here are the reasons as to why. So what if one of the condition fails? We have to mark the entire test as failed, right? If we mark the entire case failed, it means all the 4 conditions are not working, which really isn't the case. It's because just the first case is not working, but you're marking failed for all the 4 conditions. That doesn't make sense. Tests need to have a flow here, which you cannot actually see. So the solution is to write modular test. So guys, these are the common mistake that you might make when you're actually started writing test cases. So please do keep this in mind when writing test cases so that you can avoid them. So guys, that's all with the theory part. Let's go ahead and write a test case now. But before that, here are the simple steps to get you started with. First thing is to prepare to write a test case. First of all, consider if your test case already exists. Before writing a new test case for your module, find out if there are any already existing test cases that test the same component. If you do find anything as such, consider updating the test case rather than writing a new one. Next, know the characteristics of a good test case. Being aware of what constitutes a good test case will help you write a better and a strong test case. Well, you might ask what characteristics. Here are a few. First of all, you have something called accuracy. The test clearly articulates the purpose. Then you have something called tracing. The test is capable of being traced to requirements. Then you have repetition. Test can be used to test as many times as necessary. Reusability. The test can be reused if necessary. And then you have independence. Every test case you write should be able to be performed in any order without depending on any other test case. These are few characteristics that a good test case should have, so make sure your test case falls somewhat under these categories. And the next step is to consider the different scenarios before you actually start writing. Concentrate on what could happen with the product when being used by a customer. Think from the shoes of customer. Think about this carefully and design your test accordingly. And finally, give yourself sufficient writing time. Because scenarios and cases form the base for your future test cases and testing, you need to give yourself enough time to write a quality test as well as time to have procedure thoroughly reviewed. So don't write the test cases in hurry. Like I said, the best guideline when you're actually writing a test case is to write a good enough test case. Start with small and make it perfect as you progress. So these are just prep before you actually start writing a test. And now that you've started writing a test, what you actually need to do is select a tool for the writing a test case. There are a lot of tools out there. Excel spreadsheets are highly recommended for writing basic test cases and for manual testing as well. Apart from that, you have other tools such as TestLink, WebTest, Testopia, and many others. So according to your requirements, choose the tool whichever you feel comfortable with and make sure you know the functionality of the tool. And next step is to write a test case with a chosen tool. Well, we did discuss the template of the test case earlier, right? So include all those parameters and write a well-defined test case. So once you've written a test case, the next step is to write a basic test case statement. For example, you have few parameters like verify, what is being actually tested, using, what tool you're using, the tag name, dialog. Then you have with, what are the conditions under which you're actually testing for. And then to, what is being actually fed as an input to the test, what is being written, and what is the expected result, and all that. So once you've finished testing, it's like a final note on what you actually have written your test case, or a basic test statement for your test case. And finally, review the written test case. Your job isn't quite over once you've actually written the test case. You still need to review everything that has been written and evaluate that all steps are clear and comprehensible and that the expected results match with those steps. So I hope the steps were clear enough, right? And I guess now you're good to go. You can actually start along with me, or you can actually see what I'm doing right now. And after that, you can go ahead and write a test case of your own. So let's go ahead and write a test case for a banking website. So guys, as for this session, in this demo, I will be using Excel sheets to write my test case. You can actually go ahead and use any other kind of test case management tool for your purpose. So before you actually get started with the test case, there are some basic details that you should mention. It's not a compulsory thing, but it's good to have a basic description about what you're actually going to do. So let's say the project name, then module name, as in the module which I'm going to test. The test case is written by, written date, executed or reviewed by, and similarly execute a date, and so the project name would be bank website testing. Then you have module name, which can be login because we're checking the login functionality first. It's written by, let's give my name, date, some month, and some year, executed by some XYZ person, and then again some date, some month, and some year. We're good to go. Now let's just mention the parameters, which should be test case title, or it can be ID if you want. Next should be test case description. Then test steps, preconditions if I have any, test data, expected result. So I'm just gonna add these for now. If according to your requirement, you can go ahead and add other things as well. Actual result, and let's add something called status to see if the test case was successful or not. And finally, comments. Here we go. We are checking on login functionality, so I'm giving the name as login functionality, which is verify functionality with valid username and password. Let me align it. Okay. And as for the test steps, which should be navigate to login page, enter username, enter password, click login. Preconditions, nothing for navigation. Here I'm saying it should be valid username, similarly valid password. Now the test data, let's give username as some random data. And as for the password again, so what should be the expected result for navigate to login page? You should be able to see the login dialog box. Credentials can be entered. Or you can say same thing, credentials can be entered. If or not actually you're trying to enter, when you're trying to enter, if the data is actually getting inserted or not. Then here for the click login, you can say user logged in. Since we are using valid username and password, let's just write the actual result for each of these steps. Let's say we have successfully navigated a login page. So let's just write as expected. It means we are able to navigate to the login page. Then credentials can be entered again as expected. What I'm trying to represent here by writing as expected is that it's as expected to my expected results. And user logged in, since we are entering valid details, it's successful login. Or let's say user successfully. Now the status is pass, which is from all my 4 steps. So I'm going to do this pass. I do not have any comments. That's it, guys. We've successfully written a test case. Let's write another one for the invalid details. So again, the name is same. Let me just copy this and paste it. That's better. With invalid username and password. The rest of the steps are same. Invalid username. I've removed the U if you can see here. Then the password is going to be valid. So I'm going to put that here same. As for this, you should be able to see the login page. That should be successful. Credentials can be entered, as in you're able to enter the details, and user logged in. This 3 should be same as expected because you're able to navigate, you're able to enter in the details. But as for here, user login unsuccessful. So that will be pass, which is going to be same for rest of the 3 steps. But this step is a fail. So guys, as for login, these are 2 cases that I've written here. We can go ahead and write for multiple possibilities like invalid username, invalid password, valid username, invalid password, or if your navigation to the login page is not happening, like that for different combination, you can actually write test cases. Suppose let's say you have logged in successfully. Let's write a test case to upload photo in your profile. So the name should be upload photo functionality. Here we go. What should be the description? Upload a photo as logged in user sounds good. When I say logged in user, I meant valid user. Now I want to add another extra field here. Let's say preconditions or pre-steps actually. I need to insert a column. Yep, here we go. And I'm going to make it as pre-step. What is a pre-step? The pre-step here is login with correct data. Login with valid data. That's the action I actually want to perform. That's why I've written in the step. As for the preconditions, I can say login details should be valid. Now, the test steps, I have 3. First one is click the upload, let's say click the upload photo link or photo button. Link is more better. Then upload a photo as in add the photo. And then you have click on the upload button. So precondition I've already added, that's login details should be valid. I do not have any test data or anything. Let's go for the expected result. What I'm expecting to happen here is upload a photo page should open. That's what I'm expecting to happen. And as for here, when I upload a photo, image should be selected. Image to add should be selected. Image to be uploaded should be selected. Now, the next thing is click on upload button. Photo should be successfully uploaded. So photo uploaded correctly. Properly or correctly, anything. Now, what are the actual results I'm expecting? It's the test case here is upload photo as a logged in user, as in successful user. So as expected, if the navigation works proper, if I click on that photo upload link, if it goes proper, then as expected, similarly. And here's the same as well. So this will be pass because my test is passed successfully, then pass and pass. Well, this was for a logged in user. If you do the same for the invalid user credentials, you wouldn't have anything in the pre-step here. So upload photo as a invalid user. For all these actions, upload a photo page if it navigates properly, that should be a pass. Upload a photo if you actually have any photo that you're uploading, that would be a pass. But when you click on the upload button, it does work properly. But before actually this happens, you are logging in or you're using this as a invalid user. So here your test tape actually fails here itself, before itself, because you're not a valid user. So this way you can actually write the test cases according to your requirements. So guys, based on the things that we have learned today, go ahead and write a sample test case according to your requirement. There are a lot of sample templates on Google that you can search for and verify to actually master writing test cases. So what is a test plan? The overall software testing process also has many other formal procedures, but the plan is actually where we begin, or where a testing company actually begins. Like any project, when you have a plan in place, chances are it will go very smoother. So a test plan in software testing is the document that outlines the what, when, how, who, and more of a testing project. Well, in general, it includes the objective and the scope of tests that are to be run. It contains guidelines for testing process such as approach, testing task, environment needs, tools, requirements, schedule, constraint, and many other things. So test planning is the first thing that should happen in the software testing lifecycle. It's very important because it summarizes the testing process. The plan is basically broken down into manageable pieces so that we know how to deal with each aspect of that process. And it's a record of our objectives, as in the tester's objective. So the tester can look back and see how he actually did the testing and where he has to change, did he follow according to the plan and all that. So a test plan essentially contains the details of what the scope of testing is, what the test items are, what the test items test or pass criteria will do, and what is the need to set up the entire test environment and many other things. Well, now that I've talked so much about what a test plan is, like I said, it contains all the details before you actually start testing. You might be probably wondering, why is it necessary to invest all this time and effort to create a test plan? How about just jumping off to testing and getting the work started? Well, hold on. You might need to rethink. Testing is an important process in software development life cycle which controls and determines the quality of your deliverables. So if you want to deliver a bug-free product at its planned timeline, you need a good test plan to make it happen. Well, here are some reasons to convince you why test plan is really beneficial before you actually start testing. So first of all, it serves as a framework and a guide to ensure your testing project is successful, and it will help you control risk as well. The very act of writing helps us think through things in a way we might actually not consider normally. Not just in software testing, it's the case even when you plan anything in your life, right? So yeah, the test plan contains details of testing scope, which prevents testing team from putting any efforts in testing out of scope functionalities. With test plan, you can have rough estimate of time and effort which is needed to complete the software project. It clearly defines roles and responsibilities of every team member, so every individual in the testing team knows what he is required to do and what is expected to do. Also, it provides schedule for testing activities. Hence, it provides you a baseline schedule to control and track your team's testing process. But one thing, guys, as changes to the test plan are made, the test plan document should be updated to reflect the new decisions that you've actually made. So test plan is not some a fixed document or something. It keeps changing according to the requirements and the test process that you follow. It also outlines the resource requirements and equipment needed, which are essential to carry out the basic testing process. So it guidelines the tester's thinking. It acts as a source of proof if you need to refer to anything in future. Just like the example which we discussed in the beginning of the company ABC. Like the client had an issue, but then the client didn't specify the requirement when he was listing out his requirements. The company had proof, so somehow they were saved from getting sued. So basically, it's a proof which you might refer to or which you can refer to in future. So apart from that, it encourages better communication. The test planning and the plan itself, it serves as a vehicle for communication with the other project team members such as testers, peers, managers, and other stakeholders. It also helps people outside the test team, such as developers, business managers, customers, understand the details of testing. So that's how important a test plan is. In this way, it serves as a guidebook for entire testing process. Even though we are aware of the benefits of having a test plan, we also know that testers may choose not to write one, arguing for reasons like it takes a lot of time. So even though we are aware of the benefits of having a test plan, we also know that some testers may choose not to write one for multiple reasons, like it takes a lot of time and effort to prepare a very lengthy and detailed test plan. Changing management in the test plan can be challenging for dynamic projects, and that plan often has redundant information and many other reasons. So, what happens when one doesn't have a test plan? Let's check out. First of all, it creates a misunderstanding about roles and responsibilities. When there are no clearly defined roles and responsibilities, it could lead to important tasks of testing being left undone or to an unnecessary effort. For example, when two testers work on the same task. So basically, both of the testers are think that they have to test the product, but they're testing the same feature of the product and it's just waste of time. So there's a misunderstanding about roles and responsibilities. Secondly, the test team does not have clear test objectives. For example, the test team is unaware of the different types of testing that should be done on a system, as well as the reasons for doing the different types of tests. Without clear objective for running tests, there's an increased likelihood that critical and essential system characteristics will not be adequately or properly tested. So, well, again, it's a huge loss for the company. And testers without a test plan doesn't know when the process actually ends. Because the exit criteria has not been specified, the testing team does not know when the software testing process actually ends. This is essential, as in the test team should know when the process ends because it helps to finish the task within the stipulated deadline without compromising the quality, functionality, and efficiency of the software. So basically, without a proper test plan, the test team or any tester doesn't know when the software testing process actually ends and what are the proper timelines, schedule, and all that. And lastly, testing scope is not defined. This is important since the client have false expectations regarding the amount of testing work that has to be done and the test items that are out of scope which should not be tested. So, due to these reasons, you need to understand that writing a test plan or developing one is really important task before you actually begin with testing. As you can clearly see, writing a test plan has more advantages than disadvantages. Well, there are different types of test plans. Let's check what they are. So basically, first you have a master test plan. It's a single high-level test plan for entire product or the software project that you're working on, and it unifies, or it's a combination of all the test plans. As you can see the word master right in the name. So basically, it's a combination of the minute test plans which you create along the process of testing. Then you have something called level specific test plan. I might have discussed in previous session that the software testing has different levels, especially four important levels like unit testing, integration testing, acceptance testing, and system testing. Well, not in the same order, but anyway, so you can write a separate test plan for each of these levels. And when you do that, that's what we call a level specific test plan. And then comes type specific test plan. As you already know, there are multiple types of software testing. Basically, having a single test plan for different type makes it complex. I mean, it doesn't put out the benefits of test plan actually. So to make the entire process easier, you create separate plan for different types of testing that you're employing while you're testing the product. So that we call a type specific test plan. This type specific and level specific combine, we call all of them together as master test plan. So I hope you understand the distinction between different test plans, right? Moving on, you already know that making a test plan is really important task of test management process. So how do you go ahead and write a test plan? Is there a procedure or a standard procedure at that? Let's check it out. So basically, to write a proper test plan, there are 6 simple steps that you can follow. First step is to analyze the test product. So can you test a product without any information about it? Well, no, right? So you must learn a product thoroughly and you need to understand the product more deeply before even testing it. So the first step towards creating a test plan is to analyze the products, its features, functionalities, so that you gain deeper understanding of the product. Further, explore the business requirements and what the client wants to achieve from the end product. Understand the users, use cases to develop the availability of testing the product from user's point of view. So basically, at the end, it's user who you are trying to impress or satisfy the requirement. So you need to have proper understanding of the product, the user requirements and expectations of the product. So how can you actually analyze a product in a systematic way? The first thing is you can go ahead and interview your client, designer, developers of the software product because it's who they start preparing the product from the scratch. So they'll know more about the product than you do. So go ahead and ask them about each and every minute detail. Review the product and the entire project once you get them. Don't avoid the important details, go through all the details. Secondly, you perform a product walkthrough. That's nothing but just use the product as if you are the end user and see if it's, as an end user, if it satisfies your requirements or not. So that's how you analyze the product. Moving on, the second step is to develop a test strategy. Once you have analyzed the product, you're ready to develop the test strategy for different test levels. So your test strategy can be composed of several testing techniques. Keeping in mind test cases and business requirements, you can decide on which type of technique that you want to use. For example, if you're building a website which has thousands of online users, you will include load testing in your test plan. Similarly, if you're working on an e-commerce website which includes online transactions, you will emphasize more on security and penetration testing. So depending on your requirement or actually the user requirements, you decide on the different technique or the strategy that you want to use when you're testing. Well, under this step, we do have multiple steps, which is to define the scope, identify the testing type, document the risk and the issues that you might come across and how to face the risk and all that. And lastly, create the test logistics. Let's not make it more theory based. I hope you've understood the second step. Let's move on to next step, which is to define objectives. So basically, a good test plan clearly defines the testing scope and its boundaries. So as you guys know, the objective of testing is to find as many software defects or bugs as possible. Ensure that software and the test is bug free before you release it to market. So you need to define a test objective. To do that, you can just follow 2 steps, which is to list all the software features. It can be anything: functional, performance, graphical user interface, security, many other things, which you might have to test. Secondly, after listing all the requirement features, define the target or the goal of the test based on the features that you have listed down. Make a list of features which has to be tested, which need not be tested. This will make your test plan specific and more useful. So like I said, one of the benefits of test plan is you can avoid your time spending or testing the features which needs to be tested and avoid out of scope functionalities. And along with that, you might also have to specify the list of deliverables as output of your testing process. You might need to explicitly define if any testing technique, such as security testing, for example, is out of scope for your product, or if you need it, or if you don't need it. All such things come under defining test objectives. Moving on to next step, we have something called resource planning. Obviously, when you're testing, you need a lot of resources, tools, people, and all that. So resource plan is a detailed summary of all types of resources required to complete a project task. It could be human, like I said earlier, equipment, materials needed to complete a testing project. It's an important factor of test planning because it helps in determining the number of resources, it could be employment, equipment, anything, to be used for the project. Therefore, the test manager can make the correct schedule and estimation for that particular project. Well, I'm not going to list down all the roles and responsibilities or the people involved and all that, but to understand the step, it's nothing. It's just planning about the resources which you might require when you're actually testing. The next step is schedule and estimation. So with the knowledge of testing strategy and scope in hand, you're able to develop schedule for testing. So divide the work into testing activities and estimate the required effort. You can also estimate the required resources for each task. So make a table. It's simple, right? In one column, you can have the list of testing activities. In second column, you can have the members who are responsible for performing those activities. And then you might actually include the schedule as well, as in when this task has to be completed by, when is the deadline and all that. You can also include another column which says what resources are required to complete the task. So that way you can control the progress of your testing process. So to create the project schedule, the test manager needs several types of inputs like we discussed about deadline, estimation, risk, and many other details. So a good test plan clearly lists down the roles and responsibility of testing team as well as the team manager as well. So basically the table which you've created, which you should create, will tell everyone what to do, when to do, and what are the risks that they might come across and all that. And last step is to determine test deliverables. So test deliverables is basically a list of all the documents, tools, and other components that has to be developed and maintained in support of the testing effort. There are different test deliverables at each phase of software development life cycle. So basically you can divide entire software testing into three parts: before testing, during testing, and after testing. And during these three phases of testing, you do have different test deliverables. For example, before testing, you might need something regarding test plan document, test case document, test design specifications. This is all before you actually even begin testing. Then during testing, you need something like test scripts, test cases, simulators, test data, matrix, error logs, execution logs, and many other things. Similarly, after testing, you might need to create reports, defect reports, release notes, issues regarding the risks that you have faced and how did you overcome and all that. So these are nothing but test deliverables. Well, these are the 6 simple steps that you should follow, but lastly, your test plan is incomplete without anticipated risk, mitigation techniques, and risk responses. Well, there are several types of risk in software testing, such as schedule, budget, expertise, knowledge. So you need to list down the risk for your project along with the risk responses and the mitigation techniques to lessen their intensity. So that's how we write a test plan, guys. It's easy, right? You analyze the product. After that, you develop a test strategy, decide on the type of testing that you want to do. Then define your objective, as in why do you actually want to test. Then estimate the amount of resources that you might have to require or that you might require by performing testing. Then do think about schedule and estimation. Write that as a point in your test plan. And lastly, determine the test deliverables. Well, it sounds easy, but what do you actually include in a plan? Different people may come up with different sections to be included in testing plan, but who will decide what is the right format? Well, you can go for IEEE standard test plan template to assure that your test plan meets all the necessary requirements. Well, anybody just can't go and write test plan according to their requirements, right? It messes up. So there's a standard format which was created by IEEE that you can write or you can use to write your test plan. Now, if you're wondering what an IEEE is, it's an international institute that defines standards and template documents which are globally recognized. So you can use the standard template to write your test plan. It has defined IEEE 829 standard for system and software documentation. 829, it specifies the format of set of documents that are required in each stage of software testing. So let's briefly discuss what are the things that you should include in your template. I won't make it much theory based. I'm just gonna mention the parameter and what does it actually have to include. So let's start. So the first parameter is test plan identifier. So as the name actually suggests, it uniquely identifies the test plan. It identifies a project and it may include version information as well. It also contains information of test plan type, the types that we discussed earlier: master test plan, test level specific test plan, and testing type specific test plan. So that's all. Basically, a one look at test plan identifier, you need to know what testing is done, what are you going to test, and all that. Then an introduction. It contains the summary of entire test plan. It sets the objective, scope, goals, and many other things of test plan. It also contains resources, budget constraints. It will also specify any constraints and limitations of a particular test plan. Coming up next is test items. It's a software item, that is application which is under test. This parameter lists the test items such as software, products, and their versions and all that. And next you have features to be listed. In this section, all the features and functionalities which need to be tested are listed in very detail. It shall also contain references to requirement specification documents that contains details of features which need to be tested. So basically, it contains all the features and the links to the features which need to be tested. Obviously, since we have features to be tested, we also have a parameter which says features not to be tested. It basically lists the characteristics or the products or the features of the product that need not be tested, or you can say out of scope. It also contains the reasons as to why these features should not be tested. And then you have something called approach. In this section, approach for testing will be defined. It contains details of how testing will be performed. It contains information of the sources of test data, inputs, outputs, testing techniques, and priorities. It will define the guideline for requirement analysis, develop scenarios, derive acceptance criteria, construct and execute test cases, and many other things. And then you have something called item pass or fail. As you can see, it's straightforward. It describes a success criteria for evaluating your test results. Basically, it documents whether a software item has passed or failed the test, and based on what you should decide if it has passed or failed the test. Then you have something called suspension criteria. It will describe any criteria that may result in suspending the testing activities and subsequently the requirements to resume the testing process. Then you have test deliverables. We did discuss the different things that you might require during 3 stages of testing. That's before testing, during testing, and after testing, and all that. Then you have testing task. In this session, testing tasks are defined. It also describes the dependencies between any task, resources required, and estimated completion time for these tasks. Testing tasks may actually include creating test scenarios or creating test cases, creating test scripts, executing these test cases and scripts, reporting bugs, creating issue logs, and many other things. Basically, the tasks that you want to perform while testing are all come under this testing task. Then you have environmental needs. So this section describes the requirements for test environment. It includes hardware, software, or any other environment requirement for testing. So the plan should identify which testing equipment is already present, what needs to be newly brought, and all that. Moving on, we have something called roles and responsibilities. Obviously, when you're performing testing, you have a lot of people in your team. So you need to define the roles and responsibility of each person involved. That's what you do in this parameter. Then you have staffing needs. It basically describes the training needs of the staff for carrying out the planned testing activities successfully. While if they need, they can be further trained on before moving on or before putting them on to next level of testing. Then you have something called schedule. So you provide a summary of the schedule, specify key test milestones, or you provide a link to the detailed schedule and all that. The schedule is created by assigning dates to the testing activities. You can prepare a detailed table like we discussed earlier. And then obviously the risk play a very important role. You have different risks regarding security, bugs, and many other fields. So you list out risk and how to mitigate them and how does that risk actually affect your testing and all the details here. And finally, you have approval. This section basically contains the signature of approval from your stakeholders that your test plan is perfect and you can proceed to testing. So I hope it wasn't very difficult to understand, right? It's straightforward. You can actually understand by just looking at the names of the parameters, really straightforward. So please do go through it again if you found that the theory part was more. The slide should help you out here. So that's it, guys. With this, we have reached the end of the session. We discussed the details of the test plan and what to include in a test plan. Basically, a test plan is a guidebook for testing process and it's vital to keep testing process on right track. So basically, you can use a test plan as a mechanism to seek answers, to drive information exchange and consensus, and to prepare yourself for further rounds of testing. Make it valuable for you and your stakeholders. Make your test plan work for you and not against you. So the main aim of the test plan is to make testing much more easier for you.
So what is functional testing? Now this particular testing is defined as a type of testing which verifies that each function of the software application operates in conformance with the requirement specification. Now this testing mainly involves the black box testing, and it is not concerned about the source code of the application. Now each and every functionality of the system is tested by providing appropriate input, verifying the output, and comparing the actual results with the expected results. Now let's have a look at some of the advantages of functional testing that makes it more preferable. So this testing reproduces or is a replica of what the actual system is. That is, it is basically a replica of what the product is in the live environment. Now testing is focused on the specifications as per the customer usage. That is, system specifications, operating system, browsers, etc. Also, it does not work on any if and buts or any assumptions about the structure of the system. So basically, there are no assumptions for this testing. Next up, this testing also ensures to deliver a high quality product which meets the customer requirement and makes sure that the customer is satisfied with the end results. It also ensures to deliver a bug-free product which has all the functionalities working as per the customer requirement. Finally, the risk-based testing is also done to decrease the chances of any kind of risk in the product. So now that we have seen all the advantages of functional testing, let's move ahead and have a look at the different steps involved in this functional testing. Now, the very first step involved is to determine the functionality of the product that needs to be tested, and it includes testing the main functionalities, error condition and messages, usability testing, that is whether the product is user-friendly or not. Now the next step is to create the input data for the functionality to be tested as per the requirement specification. Later, from the requirement specification, the output is determined for the functionality under test. This is the step 3 here. Now in the step 4, the prepared test cases are executed. And finally, the actual output, that is the output after executing the test case and expected output, are compared to find whether the functionality is working as expected or not. Now, functional testing has many categories and these can be used based on the scenario. So let's have a look at some of the most prominent types of functional testing. First up, we have the unit testing. Now, unit testing is usually performed by a developer who writes different code units that could be related or unrelated to achieve a particular functionality. This usually entails writing unit tests which would call the methods in each unit and validate those when the required parameters are passed and its return value is as expected. Now, code coverage is an important part of unit testing where the test cases need to exist to cover the line coverage, code path coverage, and the method coverage. Next up, we have the sanity testing. Now, testing that is done to ensure that all the major and vital functionalities of the application or system are working correctly. Now, this is generally done after a smoke test. So, what is smoke testing? Now, the testing that is done after each build is released to test in order to ensure build stability is known as the smoke testing. It is also called as build verification testing. Then we have the regression tests. Now, testing performed to ensure that adding new code, enhancements, fixing of bugs is not breaking the existing functionality or causing any instability and still works according to the specifications is known as the regression test. Now, regression tests need not be as extensive as the actual functional tests, but it should ensure just the amount of coverage to certify that the functionality is stable. Next up is the integration tests. Now, when the system relies on multiple functional modules that might individually work perfectly, but have to work coherently when clubbed together to achieve an end-to-end scenario, validation of such scenarios is called integration testing. And the final one is the usability testing. Now, the product is exposed to the actual customer in a production-like an environment and they test the product. The user's comfort is derived from this and the feedback is taken. This is similar to that of user acceptance testing. So these were some of the important types of functional testing. Now moving on, let's have a look at the different functional testing techniques. So basically we have two main techniques that are known as the positive testing and negative testing. Now in positive testing we have the end user based or the system tests. Now the system under test may have many components which when coupled together achieve the user scenario. Then we have the decision-based tests. Now, the decision-based tests are centered around the ideology of the possible outcomes of the system when a particular condition is met. And the alternate flow tests are basically run to validate all the possible ways that exist other than the main flow to accomplish a function. Now, in negative testing, we have the equivalence test. Now, in equivalence partitioning, the test data are segregated into various partitions called the equivalence data classes. Now, data in each partition must behave in the same way. Therefore, only one condition needs to be tested. Then we have the boundary value tests. Now, the boundary tests imply data limits to the application and validate how it behaves. Therefore, if the inputs are supplied beyond the boundary values, then it is considered to be a negative testing. So, a minimum of 6 characters for the user sets the boundary limit. Then we have the ad hoc tests. Now, when most of the bugs are uncovered through the above techniques, ad hoc tests are a great way to uncover any discrepancies that are not observed earlier. Now, these are performed with the mindset of breaking the system and see if it responds gracefully. So, these were the different techniques involved in functional testing. Now, let's move on and have a look at the various tools that are used for this particular testing. Now, you can explore the best tool based on your project requirements. Almost every high-level company is working on automation in today's world. So, just being a manual tester will affect one's career for sure. So, you need to know something called automation to boost your skill and get shortlisted for some good companies. So, now is the right time to know more about the need for functional testing tools. But which tools we should opt is really a confusing one. So let's have a look at some of the topmost functional testing tools. So first we have the Regression Studio. Now this one is a commercial Windows GUI test automation tool that supports functional UI testing on desktop, web and mobile applications. It is used by over 4,000 companies worldwide. Now Regression Studio is easy for beginners with a codeless click and go interface and helpful wizards, but powerful for automation experts with a full IDE. Next up, we have Selenium. Now, Selenium is an open source functional testing tool and one can download and use it without any cost. It is supported by the Apache 2.0 license. It is a web application testing product and it accepts many languages to write its test scripts, and the languages can be C#, Java, Perl, PHP, Python, etc. It can be deployed on Windows, Mac OS, and Linux. Now, this one is also one of the most preferable tools for functional testing. Now moving on, next up we have the Test.io. Now for this, make sure that your web apps, websites and mobile apps work everywhere by running functional tests on real devices, real browsers and under real world conditions. Now running functional tests with Test.io lets you call upon the skill and insight of thousands of testing professionals to improve the quality of your websites and mobile apps. Over 200 customer-obsessed organizations rely on the power and flexibility of Test.io to ship high-quality software faster. Next up is the Edureka. Now, this is one of the most simple and user-friendly testing tools in the market. It provides functional, exploratory performance as well as load testing solutions. Though it's not free, its subscription to download the complete tool along with its license is available at a reasonable amount. Now it comes with Visual Studio plugin, hence, in order to bring the best out of this tool, one must know the Visual script. Finally, we have the CUI test. Now CUI test is a Microsoft tool. To use this tool, the user shall need Visual Studio 2013 Virtual Machine, which is also a Microsoft product. Now by using the CUI test tool, one can completely automate tests for validating the functionality and the behavior of the application. Now, before considering this tool, one must check for the latest cost of the CUI test tool and VSTS licenses cost with Microsoft. Now, out of all these tools, Selenium is one of the most preferred tools when it comes to functional testing. So let's have a look what makes it the most preferable one. So let's talk about some of the advantages of Selenium. So Selenium is basically an open source tool which is used for automating the test cases carried out on web browsers or the web applications that are being tested using any web browser. So it's an open source tool which supports cross-browsing and automates web applications. So now let's see, why do we need Selenium IDE for automation testing? Now Selenium is basically an open source and also there is no licensing cost involved, which is a major advantage over other testing tools. Now the other major reasons behind Selenium's ever-growing popularity are about their test cases, OS platform and browser support. So the test scripts can be written in any of these programming languages such as Java, Python, C#, PHP, Ruby, Perl and .NET. And the tests can be carried out in any of these OS such as the Windows, Mac or Linux. Also, the tests can be carried out using any browser, that is the Mozilla Firefox, Internet Explorer, Google Chrome, Safari or Opera. So now that you know what is functional testing and also you have learnt about the best tool that is used for performing functional testing, let's have a look at a small example that will help you understand how we are performing this functional testing with the help of Selenium. So now let's have a look at the example. So here we will be performing functional testing with the help of Selenium. So let's take the example of our Edureka blog page. So now if I want to click this particular element, let's see how I can do this with the help of Selenium. So now this can be done with the help of locators. So first let's see what are locators in Selenium. Now the locator can be termed as an address that identifies a web element uniquely within the web page. Now locators are basically the HTML properties of a web element which tells Selenium about the web element it needs to perform the action on. Selenium uses locators to interact with the web elements on the web page. Now there is a diverse range of web elements like the text box, ID, radio button, etc. And identifying these elements has always been a very tricky subject, and thus it requires an accurate and effective approach. Thereby we can say that more effective the locator is, more stable will be the automation script. Essentially, every Selenium command requires locators to find the web elements. Thus, to identify these web elements accurately and precisely, we have different types of locators, namely the ID, name, link text, CSS selector, partial link text, and XPath. So now in this particular case, I am using the link text to connect to the particular link. So here we will be clicking on the interview questions and select on inspect. Now here we will get to see a link text named as the interview questions. So here I'll copy this and use the link text locator to locate the element. Now before that, let me first tell you what is link text. Now all the hyperlinks on a web page can be identified using link text. Now the links on a web page can be determined with the help of anchor tag. Now the anchor tag is used to create the hyperlinks on a web page, and the text between the opening and closing of anchor tags constitutes the link text. So let's switch back and see how we are going to do it. Now this is the example that we are going to use for our test. So first of all, I have created a class named example, and after that I have set the property where I have used the Chrome driver. And next up I have used the system.set property in order to launch my Chrome driver here. So now this is the path where I have saved my Chrome driver. Now Chrome driver is very important when you are using Google Chrome. Next here I have added another object for Chrome driver. And next up I have used driver.manage.window.maximize in order to maximize the window. And next up there is delete all cookies, where I have deleted all the previous cookies that existed. And next up I have specified an implicitly wait time as 30 seconds, where the page would wait for 30 seconds until it is loaded. And next up I have used the driver.get in order to navigate to our Edureka blog page. Now using the driver.find element by link text locator, I am trying to click on to the interview questions link. Now let's run this code and check the output. So now here you can see that the Chrome driver launched the Google Chrome and navigated to our Edureka page. As soon as it entered the Edureka blog page, it went to the interview questions link. And here you can see the output. So basically, whatever we would have done manually has been done with the help of the automated tools. It navigated through our blog page and also went inside the interview questions link all by itself. So this is how functional testing takes place with the help of Selenium.
Let's understand the parameters based on which we'll compare these two types of testing. So we'll compare them based on these particular parameters. Starting from their objective, we'll discuss on how these two testing types differ based on their objective. And then we'll move on to their area of focus, or where exactly the testing is done. And once we're done with this, we'll talk about their ease of use, stating how easy is it to run a case in functional and non-functional testing. After that, we'll talk about their functionality, where we'll understand their main features. And finally, we'll compare them based on their execution process. So let's start comparing them based on their objectives first. Functional testing is carried out to verify or validate the software actions like the login functions and so on. Whereas the non-functional testing helps in verifying or validating the performance of the software, that is, how the system performs under a given situation or condition. So these are the objectives of functional and non-functional testing. Now let's move on to understand their area of focus. Functional testing mainly concentrates on the user requirements, that is, what are the functionalities that takes place in the process and so on. Whereas the non-functional testing mainly concentrates on the user expectations, that is, how the system interacts with the user, how the system is built, and how you can customize your functionalities. So the functional testing basically provides the answers to the what functions here, whereas the non-functional testing provides answers to how functions here. Okay, so this is about their area of focus. Now let's understand their ease of use. Functional testing finds it easy to execute the black box testing. By black box testing, I mean the internal structure or the implementation process is not known to the user. So the functional testing supports this kind of execution. Whereas the non-functional testing finds it easy to execute the white box test cases. In white box testing, the internal structure or the implementation process is known to the user. That is, the user can actually see the process that takes place in the system. Okay, so this is about their ease of testing. So now let's move on to understand their functionalities. Functional testing helps in describing what the system should do, whereas the non-functional testing describes how the system should work. Okay, so I think you've already understood what this means. Like I've mentioned earlier, functional testing provides answer to all what functions in the system, whereas the non-functional testing provides answer to all the how functions in the system. So this is about their functionality. Now let's move on to understand their execution process. Functional testing is executed before the non-functional testing. I think you guys have figured out how the execution process takes place, right? Functional testing helps in defining the test cases. Okay, so this is the reason why the execution of the functional testing happens before the execution of the non-functional testing, whereas the non-functional testing execution takes place only after functional testing. That is, only if the test cases are defined, you can proceed further and test them according to your wish. So now that you've got an idea of how functional testing and non-functional testing work, let's take a look at their types. Software testing is broadly classified into two major types, that is, functional testing and non-functional testing. Let's start the discussion by understanding the different types of functional testing. Functional testing comprises of the unit test. Unit test is basically the first phase of testing. That is, you can prepare the test cases, review them, rework on them if there are any errors, and create a baseline for the test cases. This particular type helps in testing the units of the test case. So this is about unit testing. Say if you don't want to test the system unit-wise and you want to integrate the entire process and then test, how would you do that? We will use integration testing, where the integration testing is the level of software testing where the individual units are combined and tested as a group. So this is about integration testing. Now, if you want to test the entire system on a whole and not integrate the process and then test, how would you do that? We will use system testing. System testing is actually a series of different tests whose sole purpose is to exercise the computer-based system. Okay, so this helps in testing the system on a whole. Now, say if you want to run the test scripts on another system, how would you do that? We will use interface testing. Interface testing verifies whether the communication between two different software systems are done correctly. Okay, so this is about interface testing. Now, say if you want to change a particular piece of code or if you want to add a few more commands to the test cases, how would you do that? We will use regression testing. Regression testing is a test to confirm that the recent program or code change has not adversely affected the existing features. That's what you want, right? You need to have a test scripts which doesn't change even if there are modifications. Okay, so this is about regression testing. So now let's try to understand the last phase of functional testing, that is user acceptance testing. User acceptance testing helps in handling the real-world scenarios according to the specifications. So this is about the different types of functional testing. Now let's move on to understand the different types of non-functional testing. Let's start by understanding the first type, that is the documentation testing. Documentation testing helps in estimating the testing effort required, the test coverage, and how to track the requirement. So these are the particular features of documentation testing. Now, once the documentation process is done, say if you want to install any particular software to your system, and what if there is a bug in it? How would you test it? We are going to use a type of non-functional testing called installation testing. Installation testing checks if the software application is successfully installed and it is working as expected after installation. So this helps in simplifying the test cases during installation. Now say if you want to check the performance of a system, how would you do that? We will use performance testing. Performance testing is basically considered as the heart of testing. Let's understand what is performance testing. Performance testing is used to ensure that the software application will perform well under any expected workload. That is the main objective of testing, right? To check if the system performs well under any workload. Like I mentioned, performance testing is the heart of software testing. So now let's try to understand the different types of performance testing. We'll start with understanding the first type, load testing. Load testing is used to monitor the response time and staying power of any application when the system is performing well under heavy load. Okay, so this is about load testing. Now let's understand what is stress testing. Stress testing is used to determine or validate an application's behavior when it is pushed beyond the normal or peak load conditions. So stress testing is used under these conditions. Now, what is endurance testing? Endurance testing involves testing a system with the expected amount of load over a long period of time to find the behavior of the system. Now, what is spike testing? Spike testing is carried out to validate the performance characteristics when the system under test is subjected to workload models and load volumes. So this is about the different types of performance testing. Now let's move on to understand another type of non-functional testing, that is reliability testing. Reliability testing checks whether the software can perform a failure-free operation for a specific period of time. It also assures that the product is fault-free and is reliable for its intended purpose. So this is about reliability testing. Now let's try to understand the last phase of non-functional testing, that is security testing. Security testing helps in determining that its data and resources are protected from possible intruders. That's the whole point of testing, right? Security is the key to software testing. So this is about the different types of functional and non-functional testing. Now let's try to take a look at their use case. Let's understand the use case of functional testing. Functional testing helps in checking the login functionalities. Say for example, if you want to log into a particular web page and you want to sign into an account, you'll be asked to fill a few details like your name, your mail ID, create a new password, and so on. So these particular fields can be checked using functional testing. So this is one of the use case of functional testing. Now let's understand the use case of non-functional testing. Non-functional testing helps in customizing the test cases according to the user requirements. Say for example, after logging in to a web page, you want the particular page to load for a few seconds and then pop up. So this kind of customization can be done using non-functional testing. And say if you want to add a wait command and want to wait for a few seconds in the dashboard, you can do that using non-functional testing.
So what is the first thought that comes to your mind when you hear the word sanity testing? If you make a guess by its name, then as the name implies, sanity testing aims at checking whether the developer has put some sane thoughts while building the software product or not. That's quite close to actual meaning of sanity testing. Sanity testing is a software testing technique which does a quick evaluation of quality of the software release to determine whether it is eligible for further rounds of testing or not. So sanity testing is usually performed after receiving a fairly stable software build, and sometimes the software build might have minor changes in code or functionality, and it is sent for sanity testing to check if the bugs have been properly fixed. So what exactly is the intention of performing sanity tests? Let's discuss the objectives. First thing is to verify and validate the veracity of newly added functionalities and features. Secondly, to evaluate the accuracy of new features and changes if they are added. And thirdly, to ensure that introduced changes doesn't affect other existing functionalities of the product. Lastly, test rational thinking and logical implementation of the developers. That's the core and basic purpose of sanity testing. So basically, sanity testing is surface level testing, which helps in deciding if the software build is good enough to pass it to next level of testing or not. Well, that's clear, right? So here's a basic representation of sanity testing. As you guys can see, I have 3 builds here, and I want to send these stable builds for sanity testing. And once they are sent to sanity testing is performed on them to see if any new features or changes are made. If yes, then if they have affected the existing features in any way, and if there are any bugs, were they fixed, and all that are checked or performed under sanity test. And the builds, if they pass the sanity test, then they're sent for further rounds of testing, else they're rejected. Or you can say they're added to the rejected build list. It's simple, right? That's all there is about sanity testing. Well, it's very simple and basic form of testing that's performed before any product is sent for further rounds of testing. So to make it more presentable and simple, here's an example. Let's say the build which I just subjected to sanity test is a new feature which is added by Gmail. That's nothing but auto acknowledgement feature. What does this auto acknowledgement feature do? It sends a written email that the email which you tried to send is delivered successfully. Now this is a new feature and it's fairly developed, so we already have a build that's stable. Sanity testing is performed to see if this new feature, that's auto acknowledgement feature, is working properly or not. And because of this feature, if any other features are affected. If not, it means that it has successfully passed the sanity testing and the auto acknowledgement feature is sent for further rounds of testing. It's as simple as that. So to summarize, sanity testing is performed when a new product or functionality or change is implemented to see whether the software product is working correctly or not. It determines if thorough testing of software product shall be carried out or not. So if sanity testing fails, rigorous testing is not necessary to be conducted. Well, that's well and good, but how do you perform sanity testing? Is there a specific procedure that you need to follow? Well, unlike other types of software testing, sanity testing does not come with a handful of techniques. You do not need to script the test cases for sanity testing because you want to perform very quick and speedy testing. So what I want to say here is that sanity testing is a very speedy and quick process of testing the application as it does not involve the scripting of test cases. So guys, the thing that you need to remember here is the main purpose of performing sanity testing, like I have been saying from the beginning of the session, is to verify if the newly added changes and functionalities have affected the existing functionalities. Are they working properly? Are there any software bugs? So that's the main purpose. Now, how do you perform sanity testing? It's quite simple. Well, just 3 steps. The first step is to identify the newly added functionalities and features along with the modification or changes introduced in the code when you're fixing bugs, or you can say bug fixation process. So the first step is to identify all the bugs, new features, or any changes made to the code. Second step is to evaluate these identified features and changes to ensure that they're working as intended and they're properly working. And that's what we call evaluation. And the last step is testing. That is, we consider and test all the related parameters, associated functionalities, and elements of the above evaluated features and changes to ensure that the related features are working properly as well. What I mean to say is that the new changes or the functionalities or the bugs which were introduced did not affect the existing features. That's what you do in testing. So very simple, right? Just the 3 steps. First, you identify if there are any new changes to the features and functionalities. Then you evaluate them, and then you test if they are affecting the existing features in any other way. If all these 3 steps goes well, then the build can be subjected to more thorough and strenuous testing. So if all these 3 steps go well, then the build has successfully passed the sanity testing and it can be sent for further rounds of rigorous testing. So that's how you perform a sanity testing. Imagine the following scenario. You have several modules in your application. You have a user registration form in module X that allows user to enter data and submit it. The client has now requested to add Preview My Profile button in the user registration form, which enables the user to preview his profile before he actually submits the details. You got my point, right? You have an application, multiple modules, and you have a module called X. Now the client is requested for additional feature called Preview My Profile before he actually submits his profile or the details. So now the development team has implemented the request according to the client's requirement. The release in your hands and the build is sent to you. So the release is in your hands, that is testing team, and you want to perform sanity testing. So first you will ask the development team or the manager what's the new feature that's been added to the release. Then you'll get to know that Preview My Profile is the feature that's been added, and according to that the code has been modified. So then you go through the code, you test that particular feature which has been added and check if it's working properly or not. That's what we call evaluating. So once you check that the Preview My Profile feature is working or not, then you come to testing feature, where you see if on adding that, if it has affected the submit button in any way. If it has, it means that the software build has not passed sanity test. Else it means that the software product or the software change which is being made to the build has worked properly and it can pass to further rounds of testing. Simple, right? So by now you might have figured out certain key points of sanity testing. If not, don't worry, I've got them covered. First of all, sanity testing is carried out on relatively stable builds. Secondly, it doesn't require any documentation like I have been saying, and obviously it's performed without any scripts. Unlike smoke testing, which is performed from end to end, sanity testing is just performed on limited functionalities, which we will discuss about later while discussing the differences between smoke testing and sanity testing. And usually it's performed by the testers, not the developers, so the developers are not involved here. Well, if I have to define sanity testing in simple terms, it's a narrow and deep type of regression testing, and yet it's performed on limited functionalities, not from end to end. Lastly, it acts as a gatekeeper, as in it helps the testers to decide if the software build is worthy enough or stable enough to be sent for the further rounds of testing. So these are some important features. If I have to summarize, it doesn't require documentation, less scripting, carried out on relatively stable builds. Limited functionalities are covered in this testing, usually performed by testers. It's a very narrow and deep type of regression testing, and it helps decide if the software build is to be passed for next level of testing or not. So these are some basic features of sanity testing. So what would you consider would happen if sanity testing is not performed? So when a new release comes in, the tester would put entire effort in preparing test cases and executing them and all that. The testing team would thoroughly test each test case, each functionality of the application, and its user friendliness as well. Well, do you see any problem in here? No, right? But there is a problem. The scenario sounds good only as long as new and old functionalities are working well and fine. What if the changes and the newer code have messed up your previous functionalities? What if the newer release is crashing down at every other action? Do you still consider it's wise to undergo such a release through the full testing cycle? No, right? This is where sanity testing comes in. It's really important phase of testing. So what are the advantages of sanity testing? First of all, it offers you speedy evaluation. It offers speed. Sanity testing has a very narrow focus for functionalities or areas to be tested. Like I said, it's not end-to-end testing. It's performed on limited functionalities. So you don't need to script the test cases before carrying out sanity testing. Rather, you can say it's very unplanned or intuitive approach to perform sanity testing. Next, it saves a lot of time and effort on testers' part. Sanity testing, it determines whether the application should be further tested or not. Like I said, it acts as a gatekeeper. This saves testers time if the release is in a very poor condition to meet the rigorous rounds of testing. Also, testers do not need to report the issues or log down them anywhere. This saves a lot of reporting time as well. Secondly, sanity test identifies deployment and compilation issues as well. Suppose a tester may face inaccurate user interface if the developers do not check all the resource files in the compilation. Sanity testing also identifies deployment and compilation issues. A tester may face inaccurate user interface if the developer did not use all the resource file in the compilation. Also, developers may not specify some important features to make them visible for testers. A sanity check detects any such problem and it offers a quick solution for well-functioning release. And obviously, like we discussed earlier, it does not involve any documentation. Well, you can say very less documentation. So that's one more merit. And the other one is sanity testing gives you a quick state of product which can help you plan your next step accordingly. So if sanity test fails, you might plan your development team, or you can tell your development team to postpone the next task and fix the found out issue. On the other hand, if sanity test is passed, you might ask your team to go ahead with the next release and spend less time on fixing bugs. So that's how it is. Lastly, compared to other types of testing, sanity testing is really cost effective. Well guys, now you know how important sanity testing is, right? With this, we have almost reached the end of the session. Last topic of today's session is how smoke testing and sanity testing differ from each other. Smoke testing and sanity testing are two very different practices, but people still get confused because the distinction between them is somewhat subtle. So let's discuss few key differences between them. So the first difference is the software build here. We already discussed what software build is. Well, if you're not sure, the term build is the process by which source code is converted to a standalone form that can run on any system. The smoke tests are executed on initial build of software product, whereas sanity tests are performed over the builds which have passed the smoke test and gone through rigorous testing cycle, or you can say regression testing cycle. What I mean to say here is, smoke testing is usually performed on very initial builds, whereas sanity testing is executed on slightly stable builds than they are in smoke testing. Moving on to motive of testing, smoke testing makes sure that the core functionalities of your program are working absolutely fine. So the motive of smoke testing is to measure the stability of newly created build so that you can move on to the next round of rigorous testing. Whereas sanity testing is to check if the new functionalities or the bugs have been fixed properly without going any deeper. So the objective here, or in the sanity testing, is to verify the rationality and the originality of code functionalities to proceed with further rounds of testing. Talking about component tested, throughout the session I've been telling that smoke testing is performed from end to end, whereas sanity testing is a narrow testing which is performed only on limited functionalities, or you can say certain components of software where it's required. Next up is documentation. Usually smoke testing is documented and well scripted compared to sanity testing, whereas sanity testing is not that documented and it's usually not scripted at all. Test coverage. Smoke testing is shallow and wide approach to include all the major functionalities without getting into detail. Well, it may be seen as a general type of testing covering all basic functionalities. But sanity testing is a narrow and deep approach involving detailed testing of functionalities and features. It's more focused on certain features rather than from end to end. And lastly, performed by smoke testing is usually performed by developers as well as testers because it's usually performed on initial builds, and initial builds are passed on from developers to testers, and it's quite possible that sometimes developers themselves perform the smoke testing before sending it to testers. But when it comes to sanity testing, it's usually done in between the development of software product, as in not on the initial builds. So it's usually executed by the testers. Well, that's it, guys. With this, we have come to the end of the session. So let's wrap up the discussion and quickly take a recap of what we have discussed so far. Well, we did discuss what sanity testing is. It is a tool to tell whether your software release meets the merit to go to further rounds of testing or it's too flawed to be tested. It's performed when a new functionality, change request, or bug fix is implemented in the code. Its scope is narrow and it's focused on only functionalities that have been implemented or impacted by the change. And lastly, many people confuse between sanity testing and smoke testing, so we did discuss the key differences between them.
So before jumping straight into smoke testing, let's just first understand what a software build actually is. When you are developing a simple software program that consists of a few lines of source code, it's easy to compile and execute the code. But this is not the real situation in companies. A typical software program or application usually has hundreds or even thousands of source code lines. Creating an executable program for huge code is quite complicated and time-consuming process, as you guys know. So in such cases, you need a build to generate the executable program. The term build is the process by which source code is converted to a standalone form that can be run anywhere on any system. Well, it's not just the matter of compiling the individual components of an application, but the linking them together as well. So you will need to tell the individual components which you have compiled where to find the things they require or depend on to run properly. And this complete process is what we call software build and software engineering. So in simple terms, you can consider build as a particular model of an application or a software that's still in testing phase. This build is further put on the test environment and it's handed over to QA team for testing purpose. Each time a developer fixes anything in the code, or if he writes a new code for different functionality, it goes through same process again. So there are a number of development builds planned in any given project. But it is always a risk that build does not work properly on the environment because of number of issues like configuration issues, code issues, regression issues, and environmental issues. So our initial build, after it's developed by the development team, is subjected to basic testing before it's sent to other levels of testing. This basic testing is what we call smoke testing. So smoke testing is a high-level test performed on initial software build to make sure that the critical functionalities of the software or the application that you're testing on is working properly. It is executed before any detailed functional or regression tests are executed on that particular software build. So the process of smoke testing targets all key features and it's often considered a cost-effective approach because you're just checking the basic functionalities and you do not have to spend much effort, time, and cost on that. So if key features aren't working or major bugs haven't been fixed, there's no reason to waste time on further rounds of testing, right? So smoke tests should be scripted. This ensures that you're touching all the major components of the software and no key features or the core functionalities are missed by you. And most of the time, all the high quality smoke tests share common characteristics and area of coverage. Like it involves clicking or navigating through many or sometimes all screens of an application, testing the key functionalities such as sign-up forms, adding to the shopping carts, exporting files, moving data, and rest of other things, verifying correct layout of the graphical user interface and visual correctness. So all these are the basic features which we check during any smoke test. But it's optional that even after checking these features, you can add on other features to check on according to your requirements. But the question here is, how important are these smoke tests? Let's consider a simple example to understand smoke test. Suppose if you're given a Gmail application to test, what are the important functions there? Log into Gmail, compose mail, and send. Correct? Yeah. So for instance, if there's an error in sending an email, does it make sense for you to test sent mail, drafts, folders, and other features? No, right? which means you are rejecting the build without further testing or without testing other functionalities. That's because your basic functionality or the core functionality of your application is not working properly. That's what smoke testing is all about. Of course, thoroughly testing your application is really important for ensuring the code quality. But performing a suite of smoke tests is even more important since it's sensible to get answer to preliminary questions like, can the application that you're testing will be successful without any error? Does the login process function correctly? What happens when you click on the primary buttons or the menus? So a major benefit of running a smoke test is that it provides quick feedback within a matter of few minutes. And as a tester, you do not have to wait for hours to get the results. As you can see, I have like about 3 builds on the screen, and I want to check the functionality of my last build. So I have subjected it to smoke test. If all the functionalities are working well, as in if it passes the smoke test, it'll be passed on to next rounds of testing. If it doesn't, the build is either rejected or it's subjected for further development to remove the errors or the bugs that we have found. So that's what smoke testing is all about. Guys, have you ever wondered why the name smoke testing? Since smoke testing came into existence, there are a lot of theories and studies associated with the nomenclature. However, out of all this, only 2 of them seem appropriate. One theory is that, according to Wikipedia, the term smoke testing likely originated in the plumbing industry. Plumbers would use smoke to test for leaks and cracks in the pipe systems. Sometime later, the term was applied to testing of electronic things as well. Another theory states that the term smoke testing is originated from hardware testing, where a device, when first switched on, is tested for the smoke or the fire from its components. Like power up a device, and if you see a smoke, then, well, that's bad, right? So these are like the 2 most popular theories about a smoke testing. But today, the concept of smoke testing is widely used in software development. While actual smoke may not be involved, the same principles are applied in smoke testing software as well. But to get a better insight into this process, it's important for us to understand various features of smoke testing. So let's go ahead and check them out. First of all, smoke testing is often referred to as build verification testing. So next time you hear someone telling build verification testing, it's nothing but smoke testing. It's known as build verification testing or build acceptance testing, where the build is verified by testing the important features of the application and declaring it as good for further detailed testing. It delivers quick and decisive answers on the viability of the particular build that you're testing on. Smoke testing is an integral part of the software development lifecycle, which ensures that the critical functionality of an application are working well and fine. This you already know because that's the main definition or the concept or the objective of smoke testing. As smoke testing decides the path of the build for further testing process, it's often referred to as intake test. So with the help of automation tests, developers can check build immediately whenever there's a new build ready for deployment. Smoke testing can be done manually or it can be automated. Usually it's the testing team begins manually and then later on they automate the entire process. It also works as a gatekeeper to accept or reject the build based on its stability to undergo through further rigorous and in-depth testing activities. So you can say it's called build verification test or build acceptance testing. It ensures critical functionalities are working fine. It can be referred to as intake test because it decides on the next level of testing. It often refers to as gatekeeper as well. Smoke testing, as you guys know, is a subset of regression testing, but it's not a substitute for regression testing. And it's applicable to different levels of software testing like integration testing, system testing, and acceptance testing as well. Finally, it's a non-exhaustive testing with very limited number of test cases. You don't do testing here very deeply. You just check the basic functionalities. And usually smoke testing is performed with positive scenarios and with valid data. And the entire process is usually documented for referring later on. So these are the basic features. Well, in conclusion, you can think of smoke testing as a normal health check on the build of an application. So guys, now that we're aware of what smoke testing is and its key features, let's go ahead and answer some important questions about smoke testing. Well, the first question is, when is the right time to perform smoke testing? Or when do we do smoke testing? First of all, smoke testing is done whenever the new functionalities of the software are developed and integrated with existing build that's developed in QA team. It ensures that all critical functionalities are working correctly or not. It is done in a development environment on the code to ensure the correctness of the application or the build before releasing it to QA team. After the build is relayed to QA environment, smoke testing is performed by QA engineers or QA lead. So whenever there's a new build, QA team determines the major functionality in the application to perform smoke testing. These actually answers our second question as well, which is who performs smoke testing. Like I said, it's done by development team before build is released to QA team. It's done by QA team before subjecting the build to further rigorous testing. So smoke testing basically is performed either by developers or testers or both sometimes. Moving on to our next question, why to do smoke testing? What are the benefits or advantages of performing smoke testing? Smoke testing offers various advantages to team of testers and allows them to effectively evaluate various aspects of the software. So let's check out what those benefits are. First of all, it helps you in finding the bugs and defects in the early stages of testing itself. You can uncover and fix as many as 80% of the bugs that discover simply by configuring or executing a simple smoke test. So with smoke tests, you might be covering only 20% or less than that of your test cases, and yet you can catch up to 80% or more of the bugs. Secondly, it minimizes the integration risk and help in finding the issues that get introduced whenever you integrate the components after unit testing. Smoke testing can be carried out in small time. It can be executed within few minutes for every particular build. Smoke testing also improves the effectiveness of the QA team. Instead of spending and wasting test cycles by attempting to run a large test suite when there are issues, QA team can simply opt for smoke testing. Smoke testing also reduces the manual intervention because you can easily automate the entire process and the test cases are not many here. It helps in verifying the issues fixed in the previous build are not affecting the major functionality of the application currently. This way, it improves the quality of the system that you're testing on as well. And lastly, very limited number of test cases are needed to perform smoke testing. And it also offers the advantage of getting faster feedbacks as it's frequently run very quickly. So these are the advantages. Let's list out. First of all, you can find defects and bug in the early stage of testing. Integration risks are reduced when the components are combined. There's no need for manual intervention. You can opt for automation. It improves the effectiveness of your QA team. It saves a lot of time and effort on testers' part. It improves the quality of the system as a whole. And the most important thing is very limited number of test cases are needed to perform smoke testing of entire application. So smoke test, take your code, build it, run it, and verify a thing or two. They will not verify that your software is 100% functional or not. In a production app, they will act as a quick bailout. If the smoke test fails, then the whole build is failed. And the entire process is so quick that you do not have to waste a lot of amount of time here. So my point is that for a simple application, smoke test is often all you need. Next question is, how do you actually perform smoke testing? Well, it's quite simple and it's very similar to other testing process. So the common first step for companies who want to build a suite of smoke tests is that they start with manual testing. Builds are deployed by the development team and are then sent to QA team or testing team for further rounds of testing, or you can say smoke testing. Now, once the QA team receives the build, according to the requirement, they'll start designing the test cases to expose all the errors before this build is released to market. So once you have the test case, you read and create a test suite. A smoke test suite combines a number of smoke tests into small suites of tests so that when application is ready to deliver to pre-production environments, developers will know in matter of minutes whether the latest build is worth sending it to next level of testing or not. So to be efficient and purpose-built, a smoke test suite should contain easily manageable number of test cases. Well, the recommended number of test cases is generally 20 on the low side and around 50 on the high side. Any less than this and you're probably not covering enough amount of test cases, and any more than this you're probably trying to cover too much ground at a single point of time. So you should always concentrate on sizing your smoke test suite. That's very important step. Once you have suite of smoke tests defined, you're going to want to think about automation, right? Automation can improve the quality and it can be efficient and it reduces a lot of effort and time on testers' part. There are many reasons for automating your smoke testing, like I said just now, but the best reason is that your tests will run faster, more consistently, and the written results automatically. There are a number of automation frameworks available in market that you can prefer to perform smoke testing. So once you have your suite created and an automation framework selected, you will want to think about a couple of key areas in order to keep your tests running and healthy. And what are those? You need to keep track of test creation and maintenance. You need to execute smoke testing on daily basis. You need to access a penalty on any developer whose contribution fails to pass. You should consider continuous integration made possible with such as Jenkins and Circle CI. Lastly, execute the test cases and clean up the entire setup. Cleanup might include stopping a server, deleting files, or emptying the database tables. This can also be done before the initial setup because so when you start testing, the entire environment is clean and it's like a clean slate where you can begin testing. So these are general steps that you can follow to perform smoke testing. Well, these are the general steps that you need to follow, but let's consider a simple example to understand how is smoke testing performed in real world. So assume that you're working on an e-commerce site. When a new build is released for testing, as a software QA tester, you have to make sure whether the core functionalities are working or not. So you try to access the e-commerce site and add an item into your cart to place an order. That's a major flow in most of the e-commerce sites. You agree with me, right? What's the major flow? You log in, you add the item to your cart, you purchase it and sign out. If this flow works, you can say that the build is past testing. You can move on to next level of testing like functional testing and regression testing. So here's an example. You have a build which is being released by the development team. It's been sent to you or the QA team. So you create a set of test cases and combine them and place them in a test suite. You execute the smoke test. What are the smoke tests that you're going to execute on? First, if you're able to access the home page or not. After that, you access the menu links. Are you able to access the menu links or not? You check that part. After that, you add the item to the cart and check if the functionality is working. The main functionality is after adding the items to the cart, you need to purchase them. So that's what we're checking basically in smoke testing. So you're checking the checkout and the place order functionality. If this functionality is past the test, you move on to the next level of testing. Otherwise, the build is rejected and it's sent back to development team to make changes. So it's as simple as that. Moving on, there's another term that you should know about, like sanity testing. It's often misunderstood with smoke testing. The sanity testing is done on a software build after it has gone through smoke testing and other levels of testing. Sanity testing is done to ensure that the bugs are fixed and there are no persisting problems with the application. So that's the major difference. Motive of smoke testing is to measure the stability of newly created builds so that you can move on to next round of rigorous testing. Whereas sanity testing is done to check either new functionality or the bugs that have been fixed properly without going any deeper. So the objective of sanity testing is to verify the rationality and the originality of core functionalities. It might sound complicated. The simple thing is that whenever you start on initial builds, you go with smoke testing. After your initial builds are smoke tested and after they've gone through other levels of testing, you perform sanity testing. That's the most basic difference. So in smoke test, you verify the critical functionality or the core functionality. In sanity test, you verify new functionality and check out if there are any errors. So guys, with this, we have almost covered all important concepts which are related to smoke testing. Now let's check out the best practices that you should follow when you're performing smoke testing. First of all, conduct smoke tests during the early stage of project. Record all your smoke tests. It's a very good practice and it'll provide you reliable data later on. Smoke test cases should be short and very precise, like less than 6 minutes at most. The intention with smoke testing is to catch those bugs that block the development progress during the initial stage of a project. Your goal should be to get the developer to resume the development as quickly as possible without having to wait for the complex and drawn out test phases. So at max, you can go up to 60 minutes. Well, it's not a fixed time limit, but that's what is suggested to be effective. Automate whenever possible. Tests will run faster, more consistently, and they'll return results automatically. Maintain a test case repository. Chances are 90% of your team are working on projects that bring new features or transform an established project, or they're making changes constantly. So it's always suggested to maintain a test case repository to keep track of all the test cases. Don't just stop with smoke testing, it's just a first level of testing. Move forward with other rigorous testing if the build has passed the smoke test. And once again, remember that you just have to use smoke test to test the basic functionalities, so don't go testing very deep. Now, talking about tools, many tools are available in the market to perform smoke testing in an automated way, actually. top tools include Selenium and Phantom.js. But the question here is which tool is best out of these two? Well, both of them have their pros and cons. Let's take a look. Coming to Selenium, I'm sure you might have heard of it. It's an open source automation tool and a JavaScript run automated testing frameworks that enables you to run tests across different platforms. So the most commonly used browsers with Selenium are Chrome, Firefox, Safari, and Internet Explorer. Selenium, it does have a downside when compared to Phantom.js. It needs a user-friendly graphical desktop for running the test, making the entire process of testing literally slow. However, you can leverage the full potential of Selenium when you set up virtual machines for various operating systems and connect them all together. What developers love about Selenium is that its capability to use bindings that allow them to run tests on common programming languages like Java, which is a native language of Selenium, JavaScript, Python, Ruby, and C#. So basically, all these languages are supported, and you can use any of them to perform tests on Selenium. Coming to Phantom.js, it's an incredibly powerful tool for testing as it supports several web standards, and this makes it a suitable option for automation and integration with CI tools. Phantom.js gives you the advantage of capturing screenshots. Being a headless version of WebKit, it works as a windowless command line browser. So it's without graphical user interface portion, and it's mainly because of this fact that the entire process of testing is very much easier and faster on Phantom.js. Phantom.js works as a single version of WebKit, so that's the main disadvantage of Phantom.js. So I hope this has cleared the differences between both these tools. And again, when it comes to choosing out of them, it's up to your requirements. So go ahead and think properly and choose one that suits your requirements. That brings us to the end of the theory part. Now let's check out how to write smoke test in the demo part. We won't be performing any kind of smoke test here. We'll be learning how to write smoke test cases so that you can send your application or part of your software to next level of testing. Well, I'm using Excel sheet to write down the test cases here. So guys, here we are. In this demo, we'll learn how to write simple smoke test cases. And for that purpose, I'll be using Excel. You can use any other tools to write test cases. So let's give a proper name to this sheet. Let's say smoke test cases. Before we begin, the most important thing to remember is that speed is better than thoroughness when it comes to smoke testing. So don't worry about trying to get everything 100% right the first time. You can always improve later on. Just think about the things you would normally do in your application and make a list where each line is a separate test. For example, let's say if you're browsing through an e-commerce site, you found an item that you like and you have added the item to the cart. And after that, you've logged out. Now let's try to write a smoke test for this particular scenario. Before we actually get started with the test cases, let's go ahead, like I said earlier, and create a test plan where each line should indicate a separate test. So let me give a project name. And the name would be smoke test application for e-commerce site. Okay. So if you want to test on e-commerce site, what are the basic functionalities that you want to check according to the scenario which I said earlier? The first thing would be the login functionality, right? And the next thing would be the cart functionality, as in, are you able to add the item to the cart or not? I'm just skipping the purchase option here because the test cases get very complicated, and I'm sure you guys know how to write test cases. If you do not, there's another video in the Edureka software testing playlist. You can go ahead and refer to that. The video is how to write test cases in software testing. It's explained with an example in a very proper way. So if you want to know how to write test cases, you can refer to that. Coming back to today's demo, what are the functionalities we were discussing? The login functionality, cart functionality, and obviously the last thing is sign out. So these are the three things that we want to check. And now we're going to write the test cases for these three functionalities. So every test case has few components, and you can add on more components according to your requirements. But as for today's, let me add few components here. Let's say about 6 of them, the very basic. So the first thing is test ID, then the test scenario, then the description part, the test steps, expected results, actual results, and the status. So let me explain you each of these properties. Give me a second. Okay. So the test ID, because you have a lot of test cases, you need to assign an ID to keep track of them. The scenario is very simple, explained in very detailed way what you're going to test on. Description is a one-line description. It should be very brief and up to point. One look at it, any tester or anyone who's looking at it should understand what you're testing on. Then these are the test steps, as in what you're testing on, the steps that you follow. These are the expected results, the results that you're expecting. Actual result is nothing but the actual result which you're getting after performing tests. And status is if or not expected and actual results meet or not. Based on that, the status will be either pass or fail. So let's start with the first test case. What we want to check here, the first case is login. And description would be test the login functionality of the application. As simple as that. It should be very short and up to point. In this case, application is nothing but the e-commerce site which we're testing on. And what would be the test steps? The first step would be to launch the application or e-commerce site. And the second step would be to navigate to the login page. Before we proceed, guys, I need to remind you, these are just sample test cases. For a particular scenario, you can write any number of test cases according to your imagination and what you can think is relevant. For example, when we go for login functionality, I can go ahead and write a test case for registration as well. Because to become a user, first you need to register, right? But I'm skipping that part here, just so we won't take a lot of time for you to understand the concept. But you can go ahead and add the test case as well. So what would you do the next thing after you navigate to the login page? Obviously, enter the username, then enter the password. And the last step would be to click on login button. So what would be the results that you're expecting? Login successful. And let's say the actual results that you've got after performing the test case is as expected. So the status definitely be pass because the expected results and the actual results are nothing but same. Moving on to second functionality, which is cart functionality. We want to see if we can add the item to the cart successfully. That's what we're going to check. So what are the steps involved? The first step that you would do is select the item, right? The next step would be to add the item to the cart. Or you can say click on add to cart option or button. And what would be the expected result? Item added successfully to the cart. And suppose item is not getting added. So you have tested the functionality, but the item is not getting added to the cart. So what would be the status? Definitely fail. This particular component has failed. So the third component would be to check the sign out. Check out the sign out functionality. It's very simple, right? First thing is you navigate to settings. Well, again, it depends on the application. Sometimes you have the logout option directly on the screen, but sometimes you need to go to settings and check for the sign out option. And what is the result that you're expecting that should happen when you actually do that? The user should be able to log out. And let's say user is able to log out. And based on that, what would be the status? It's pass. So that's it, guys. We have written test cases for a simple scenario of an e-commerce site. As you can actually see, these are very simple set of test cases that you can easily pass to a manual team, and you do not have to give them a lengthy explanation on what to test as well, because it's very clear that all they have to test is login functionality and if the item is being added to cart properly or not, and after adding the item, if the user is able to log out properly or not. So your test cases should be in such a way that they shouldn't be complicated, and whenever a QA team takes a look at that, they should understand what they're actually going to check. But again, these are the basic functionalities. You can include any number of test cases for the functionalities. But the main purpose of smoke testing is to check the core functionalities. So when you pass these test cases to manual team, they should be able to easily understand. Even if you are going to automate or take the trouble of writing Selenium code, you should handle these steps very easily. Now, after you've got a solid, fast, automated smoke test suite in a place, a good evolution would be to integrate your full suite of tests into a CI tool or a continuous integration tool. This continuous integration tool or CI tool can automatically initiate your test suite. It will communicate you with the alerts, and it finalizes the reports concerning the results of all the tests. Now, if all these three critical components after being tested or smoke tested by the QA team work fine, it means that the build is stable enough to proceed with detailed testing. So that's all about smoke testing, guys. Very simple, right? Well, there are mainly 4 stages of testing that need to be completed before a program or an application can be cleared for use. Namely, we have unit testing, integration testing, system testing, and acceptance testing. The first level of testing, unit testing, is the micro level of testing. It involves testing individual modules or units to make sure they're working properly. A unit here can be anything. It can be a functionality, a program, a particular procedure of a function within an application. It can be anything. Unit testing helps verify internal design, internal logic, internal parts, as well as error handling. After unit testing, we have integration testing. Integration testing is done after unit testing. This level tests how the units work together. Individual modules are combined and tested as a group. It's one thing if units work well on their own, but how do they perform together when combined? Integration testing helps you determine that and ensures your application runs efficiently. It identifies interface issues between modules. Well, there are different techniques that can be used for implementing integration testing. We will discuss more about them later since the topic of today's discussion is integration testing. The next level of testing is system testing. As the name implies, all the components of the software are tested as a whole in order to ensure that overall product meets the requirements which are specified. So basically, system testing is particularly important because it verifies the technical, functional, and business requirements of a software or an application. Well, there are dozens of types of software testing, like you have usability testing, regression testing, functional testing, and many more. If you guys want to know more about these testings, you can refer to Edureka software testing YouTube playlist. We do have videos on different type of software testing there, and do subscribe the Edureka channel if you like them. Getting on with our today's topic. The system testing is usually done by testing team, and it includes a combination of automation testing as well as manual testing techniques as well. And the final level of testing is acceptance testing, or basically we call it UAT, which is user acceptance testing. It determines whether or not the software product is ready to be released to market. Well, let's face it, guys, requirements keep changing throughout the development process, right? So it's important that the tester verifies the business needs are met before the software is released into production. So are the functionality or the functional requirements met, or the performance requirements met or not? Well, these are the questions that you ask in this level of testing. So UAT is the final say as to whether the application is ready for the use in real life or not. So basically, each level of testings, that is unit testing, or it could be integration testing, system testing, acceptance testing, each have their purpose and they provide value to software development lifecycle. So the most basic type of testing is unit testing or component testing. The main goal of unit testing is to segregate. It isolates the smallest piece of the testable software from the remainder of the code and determines if or not it behaves exactly as you expect. Generally, we refer to those small pieces of software as unit. But the problem is, although each software module or unit is tested, defects still exist for various reasons. Let's check few of them out. For example, a module in general is usually designed by an individual software developer whose understanding and programming logic may differ from other programmers. And sometimes programmers are highly skilled and very creative. They won't read all the design specs or approach coding features the same way like others do. Well, this can lead to disconnects and glitches when their modules must talk to each other. So there's a clash between different modules developed by different developers. Secondly, unit tests work with internal module communications using software stubs that simulate the rest of the systems. Well, these stubs are make-do workarounds, and when the system's module have to communicate, features like data formatting, error trapping, hardware interfaces, and third-party service interfaces tend to have unforeseen issues that were not observable at the unit level testing. That's another problem. Well, at the time of module development, there are wide chances of change in requirements by clients, right? Because user requirements keep changing. These new requirements may not be unit tested, and hence we have to perform integration testing. Similarly, you might have external hardware interface issues as well. Inadequate exceptional handling could also be a problem. So even after performing unit testing, even after testing each module specifically, you do come across these problems. So as a solution to this, we perform integration testing. So keep in mind, no matter how efficient each unit is running, if these units aren't properly integrated, it will affect the functionality of the total software program. To avoid all these issues, integration testing is introduced as a level of software testing. Integration testing is done to test the modules or components when integrated to verify that they work as you expected. That is, to test the modules which are working fine individually does not have any issues when integrated. So the meaning of integration testing is quite straightforward. Integrate or combine the unit tested module one by one and then test the behavior as a combined unit. That's what integration test means. So we normally do integration testing after unit testing, as you guys already know it. Once all the individual units are created and tested, we start combining those unit tested modules and start doing the integration testing. So once again, the main function or goal of integration testing is to test the interfaces between these modules. Not the modules, but the connection or the communication or the interface between these modules. That's the aim of integration testing. Let's learn more about integration testing. Integration testing basically makes sure that integrated modules and components work properly. Integration testing can be started once the modules to be tested are ready. While it does not require the other modules to be completed for testing to be done. And how is that possible? We'll check that out later. And integration testing also helps detect the errors which are related to interface between the modules, like I said earlier. It is also helpful when there are frequent requirement changes. It's very common for a developer to deploy changes without unit testing sometimes. So integration testing can help when the modules need to interact with APIs or some sort of third-party tools. You can test the modules to find out if the third-party tool accepts the module's data or not. Integration testing typically covers large volume of your system than a single test, so it's more efficient. And lastly, writing both unit and integration test increases the test coverage at faster speed and it improves the reliability of your software. So well, these are the advantages of using integration testing. Here I have a simple diagram for you to understand what integration testing is. As you can see, I have 4 levels of testing. We begin from down, we have unit test, integration test, end-to-end is nothing but system testing, then UI test, that's nothing but acceptance testing. As you can see in the diagram, we have the red coded part, which is a small unit or a module. It's tested. Then it's combined with other unit, and these both are encoded, as you can see in the green part. So that's integration testing. You're combining 2 modules and you're checking out the interface or the communication or the interaction between these modules. That's integration testing. As next level, obviously, you have system tests that you combine multiple modules and check them as a whole. And lastly, you have acceptance tests before the product or application is released to market. So it's as simple as that. So before we proceed any further, here's one more question. Who performs integration testing? Well, software engineers or developers usually perform integration testing. However, there are instances when the company employs independent testers to do it for them. So guys, there are different approaches to perform integration testing. But before that, you should note that integration testing does not happen at the end of the cycle. Rather, it's conducted simultaneously with the development. So in most of the times, all the modules are not actually available to test. So the challenging thing here is, how do you test something which does not exist? For that, we have a concept called stubs and drivers. So sometimes we might face a situation where some of the functionalities are still under development. So the functionalities which are under development will be replaced with some dummy programs. These dummy programs are named as stubs and drivers. Let's check what they are. So here I'm considering a single application, and this application has 2 components. Component 1, which is login page, let's say module A, and we have module B, which is admin page. As you can see, login page is dependent on admin page. Now suppose if you have to test login page, developers have developed the login page and they have sent it to the testing team to test. The problem here is that admin page is not yet developed. So what do? Instead of the actual admin page, you create a dummy admin page, which has same functionality of the original one, but not all the core functionalities. And then, since login page is dependent on dummy page, you check the functionality of the login page in linking with admin page. So without waiting for another module to be developed, you finish the testing. Here, the dummy admin page is what we call stub or a called program. Next, coming to drivers. It's just reverse of stubs. Let's say you have to test the admin page. It's ready, it's developed, it's been sent to testing team for testing. but the problem is login page is not yet developed. What you do, just like you created dummy admin page, here you create a dummy login page which is dependent on admin page. So this dummy login page is what we call a driver. It's called a calling program. So now you know the difference between stubs and drivers, right? Stubs is a call program and drivers is a calling program. So now that you're aware of these concepts, which is stubs and drivers, let's get started with different approaches to integration testing. So basically there are 3 types. To begin with, we have top-down approach. The top-down approach starts by testing the topmost modules and gradually moving down to the lowest set of modules one by one. And then we have bottom-up approach, which is exactly opposite of that of top-down. So in bottom-up approach starts with testing the lowest units of application and gradually moving up one by one. And then we have something called Big Bang testing. This Big Bang testing involves testing the entire set of integrated modules or components together simultaneously. Since everything is integrated together and being tested at once, this approach makes it difficult to identify the root cause of problems. We will discuss more about advantages and disadvantages later on. Let's explore each of these techniques in detail. So let's begin with top-down approach first. So like I said earlier, top-down approach testing takes place from top to down following the control flow of software system or architecture. So high-level modules are tested first and then low-level modules, and finally integrating the low-level modules to a high level to ensure the system is working as it's intended to. But it's quite possible that, like we discussed earlier, when we are testing the high-level modules, lower-level modules might have not been developed yet. So what do you do in such cases? You deploy stubs. Like we discussed, stubs are dummy modules that simulate the functionality of a module by accepting the parameters received by the module and giving an acceptable results. Basically, it acts as a dummy missing module. Generally, stubs have hard-coded input and output that helps in testing the other modules integrated with it. So for you guys to understand top-down approach in a better way, I have an example here. I have 7 modules. Module M1 is dependent on M2, M3, and M4. Similarly, M3 depends on M5 and M4 depends on M6 and M7. Now, while performing top-down approach, we begin with a granular module, the first one, which is module M. So you want to test module M. As you perform unit testing, it's working well and fine. Before you even start with integration testing, all these modules undergo unit testing, so they're well and fine. Now that we start integration testing, the module M1 depends on M2, M3, and M4. We want to check module M1. But M2, M3, and M4 are not yet ready. What you do? You employ or deploy stubs instead of these original modules since they're not developed yet. These stubs simulate the activity of M2, M3, and M4. Similarly, when you're testing M3, it depends on M5, and if M5 is not ready yet, you again use a stub here. Same goes for the next level of testing, which is M4, which depends on M6 and M7. Easy to understand, right, with the help of an example? So that's what stubs are. These are called programs. And one more thing, simple applications may require stubs, which would simply return the control to their superior modules or high-level modules. More complex situation demands that stubs stimulate a full range of responses like parameter passing and many other features. These stubs may be individually created by tester, or they can be provided by software testing harness, which is a sort of software specifically designed to provide a testing environment. So in top-down approach, if the dependent modules are not ready yet, we use a concept called stubs. Well, just like any approach, this approach has advantages and disadvantages as well. The tested product here is extremely consistent because integration testing is performed in an environment which is mostly similar to real-world environment. Secondly, the stubs in top-down approach can be written in lesser time compared to drivers because these stubs are simpler to author. Here, fault localization is also very much easy. In top-down approach, the critical modules are tested in priority, which further helps tester in finding major design flaws early in the stage of testing. Detecting major flaws is done very early in the process. Coming to disadvantages, as you can see, if the modules are not developed or ready yet, they require several stubs. Modules at lower level of software are tested inadequately when compared to other modules. And the most popular disadvantage that you have to remember is that the basic functionality of the software in top-down approach is tested at the end of the cycle. That can be a problem sometimes. That's all with top-down approach. Let's go with next approach, which is bottom-up approach. Well, it's complete opposite of top-down. Here, the bottom level units are tested first and upper level units are tested then step by step after that. So here testing takes place from the bottom of the control flow to upwards. Again, it's possible that the higher level modules might not have been developed by the time lower level modules are tested. Just like we use stubs in top-down approach, we use something called drivers here. These drivers are calling programs. They simulate the functionality of higher level modules in order to test lower level modules. Let's consider the similar example which we did earlier. As you can see, I have 7 modules: M1, M2, M3, M4, M5, and M6 and M7. M1 dependent on M2, M3, and M4, and M3 on M5, M4 on M6, and M7. Now, each of these modules are unit tested, so that's well and fine. So we begin here from the lower level. So we start with M5, M6, and M7. But as you can see, M3 and M4 are not developed yet. So what you do, you replace this M3 and M4 by drivers, and then you test M5, M6, and M7. Same goes for M3 and M4 if M1 is not ready yet. And same goes for M2 because M1 is dependent on M2. And if M1 is not ready, we create a driver which simulates the functionality of module M1. Here, just like stubs, the driver can have different functionalities. The driver would be responsible for invoking the module under test. It could be responsible for passing the test data, or it might be responsible for receiving the output data. And similarly, just like stubs, the driving function here can be provided through a testing harness or may be created by tester as a program. So that's the choice that the tester have to make here. Coming to advantages, in this approach, development and testing can be done together. So the product or the application here will be efficient and it will be according to customer specifications. The time requirement here is comparatively less and tester conditions are much easier to create here. Coming to disadvantages, just like top-down approach, the bottom-up approach also provides poor support for early release of limited functionality. And the need for drivers, because we use drivers, right? If the modules are not developed, it complicates the test management. Sometimes high-level logic and data flow are tested late during the test process. And even the key interface defects are found later on than earlier stage. So these are the disadvantages. And then after that, we have another approach called Big Bang approach. Once all the modules are ready after testing individually, this approach of integration testing combines them at once and perform testing. That's what Big Bang testing is. So instead of just starting from top or down, it just combines all the units or modules once they are ready and performs testing at once. Though Big Bang approach seems to be advantageous when we construct independent modules concurrently, this approach is quite challenging and risky because when you combine all the modules and test them at once, and if there are any errors, it's difficult to find out what is the reason for error since all the modules are combined and tested at once. I'm going to take similar example here. There's nothing to explain. It's pretty straightforward. All the modules are unit tested. Then you wait until all the modules are developed. You don't use any stubs or drivers here. Once all the modules are developed, you combine them and test them as a unit, as a combined unit, as a whole. So that's what Big Bang testing is. And we have advantages and disadvantages. Talking about advantages, as you can see, all the components are tested at once. So it saves a lot of time because we don't use any stubs and drivers, and also it saves a lot of time. And this process is convenient for smaller systems because there'll be less number of modules to combine or act on. Coming to disadvantages, you'll have to wait for each of this module to be developed, right, before you start testing. So a lot of time is wasted or delay. There's a lot of delay before you actually start Big Bang approach. And since there are a lot of modules which are combined and tested at once, it's difficult to trace the cause of failures if there are any. And sometimes it's quite possible that when there are so many modules, few interface links between some modules might be missing, and you will not even notice that. And as you can see, no module is prioritized, which sometimes might be problematic. Critical modules need to be prioritized sometimes. So these are the disadvantages. So to overcome the limitations and exploit the advantages of each of these top-down, bottom-up, and Big Bang approach, we have something called sandwich integration approach, or it's also known as hybrid testing approach. Well, as the name suggests, it is a mixture of two approaches like top-down approach as well as bottom-up approach. In this approach, the system is viewed as 3 layers consisting of the main target layer in the middle, another layer above the target layer, and the last layer below the target layer. So 3 layers. As you can see, M2, M3, M4 are the middle layer, the target layer. M5, M6, M7 are the layer below that, and M1 a layer above target layer. So the top-down approach is used in the topmost layer, that's layer 1, and bottom-up approach is used in the lowermost layer, which is layer 3. It might sound a little complicated, but sandwich approach is very useful for large enterprises and huge projects that further have several sub-projects. And sometimes when development teams follow a spiral model, The module itself is as large a system. Then you can use sandwich testing. The resources that are required here are immense, and big team perform both top-down as well as bottom-up method at once, or sometimes one after the other. So basically here you use the advantages of both top-down as well as bottom-up. Well, obviously this process, as it looks complicated, it has a lot of disadvantages. Since both top-down and bottom-up are executed at the same time or one after the other, the cost of testing is literally high. It cannot be used for smaller systems because the interdependency between the modules is quite complicated. It also makes sense that when individual system is as good as complicated system, then sandwich integration is best. And obviously you're using different approaches here. So the development team or the testing team should have different skills to ensure that the testing is done in a proper way. So these are the disadvantages. Moving on to next topic, let's see how you actually perform integration testing. Well, it's highly similar to any of the testing process, just like unit testing or any other testing. So the first thing you do is choose the module or the component which you have to test, and you also select the strategy that you want to employ out of the strategies which we just discussed. And before you actually proceed, you have to make sure that each of these modules which you have selected is unit tested already. Then you deploy the chosen modules or the components together, and you make the initial fixes that are required to get started with integration testing. Then you perform functional testing and test all use cases for the components chosen. Similarly, you perform structural testing and test the component chosen. After you've done all the testing, you record the results of the above testing activities. You repeat the above step until the complete system is fully tested. As in, you combine two modules, test them, and again, everything is proper, you combine with third module and do the same thing again and again. So to summarize, very simple. First, you should prepare a test plan. Then you design test cases, test scenarios, test scripts according to your plan. Execute the test cases followed by reporting of defects. Now track and retest defects as soon as they arise. And then you follow the entire process again and again until your entire system is tested. So that's how you perform integration testing. Simple, right? Moving on to the next part of the session. I'm sure you guys have understood what integration testing is by now. But anyway, let's go ahead and try to understand it in much better way with help of an example. So as you can see, I have three modules here: a login page, a mailbox, and a delete email page. So like I said earlier, integration testing majorly focuses on interfaces and the flow of information between these software modules. So priority here is given to the integrated links instead of the unit functions that are tested in advance. So you do not have to focus on testing the login page as it's done already in the unit testing. You should focus on its interface link with the mailbox page. Similarly, check the interface link of mailbox with the deletes email module. So let's go ahead and take a look at the test cases. So the first test case objective here is to test the interface link between the login page module and the mailbox page module. So the description, you enter the login details and you click on the login button. As soon as you do that, you should be taken to the mail page. If that's happened, it means that the interface link between your login page as well as mail page is working properly. Similarly, we have second test case to check the interface link between mailbox and delete email module. So what do? You go to mailbox, check the email that you want to delete and click on delete option. As soon as you do that, it's quite straightforward that email should be deleted. That's not what we're checking. What we're checking here is that the deleted email should appear in the trash folder. So that's the interface between the mailbox and the delete interface page. So integration testing, like I said earlier, is all about the interfaces between modules, not about the functionality of individual module. So guys, like any other testing, integration testing also has challenges that you might come across. For example, integration testing means two or more systems are integrated to ensure that system is working properly. So not only the integration links are to be tested, but exhaustive testing related to environment should also be performed. It ensures that all the integrated system components are working properly. There are different paths and permutations to apply for testing the integrated systems. So basically, test data management becomes difficult because you have multiple test cases and different paths and permutations that you have to follow to perform integration testing. It's tough managing integration testing sometimes because you have various factors that you should consider like database, platforms, environments, etc. Similarly, whenever a new system is integrated with a legacy system, it needs a lot of testing efforts and changes. Same goes when you're combining one legacy system with other legacy systems. In such cases, you have to develop test cases which test the entire unit functionality or combined unit functionality. So developing test conditions and test cases also becomes quite challenging. And lastly, when you're integrating two systems developed by two different companies, it's a big challenge for programmers. No one is sure how one system will affect the working of another system. So to minimize this impact, several considerations should be kept in mind to make integration more successful. Well, we cannot avoid all this, but you can follow certain practices to at least make the effect of these challenges a little lesser on your testing. First of all, you need to check if the testing strategy that you've applied is suitable one for your requirement, that is for your application requirement or software requirement or not. And based on the test strategy that you've chosen, and if you're sure it's right, you prepare the test data and test plan accordingly. After that, you need to focus on the architecture design of an application and identify the critical modules. These critical modules should be tested on priority. And then you get the interface design for the application from the architecture team and generate test plans to verify interfaces in detail. So the main concept or goal of integration testing is to check the interface link between modules, right? So you need to have the basic understanding of the interface architecture. Each of these interfaces, like database, external hardware, or any other software application, should be tested and should be understood in detail. Test data plays a critical role in any integration testing, so you have to take into consideration that as well. So keep mock data handy before the execution of test cases. So do not decide on the test data while executing test cases itself, because as you know, the user requirements keep changing. And according to that, you might have to change the data that you want to test on. Apart from these, I have few things which I've put up on the screen. As you can see, you need to identify each module, check how data is communicated, understand the user requirements, create multiple test conditions according to those requirements, and focus on one condition at a time. So these are certain things that you can follow to make integration testing much more simpler and less complex. So guys, that's all about it. Integration testing, its types, examples, strategies, practices, challenges. We have discussed everything. I've tried to explain what integration testing is with an example for better understanding of the concept. So integration testing is an important part of testing cycle that makes it easy to find defects when two or more units are integrated. So that's all about integration testing. APIs have been around since 1960s. So if they aren't a new concept, why are they such a hot topic lately? Why do you think so? Because without APIs, the digital experiences that we expect every day as consumers wouldn't be possible. APIs are doing everything from driving information-rich marketing campaigns to connecting mobile apps to streamlining internal operations. Well, here's a brief introduction to what APIs are and what they can do. To understand APIs better, let's consider a simple example. Imagine you're sitting at a table in a restaurant with a menu of choices to order from. The kitchen here is part of the system that will prepare your order. What is missing here is that the critical link to communicate your order to the kitchen and deliver your food back to your table. That's where the waiter or an API comes in. The waiter is the messenger or an API that takes your request or order to the kitchen or the system and tells them what to do. Then the waiter delivers the response back to you. Well, in this case, it is the food. Well, put it in that way, it's easy to understand. API, just like a waiter, is a messenger between you and your application. Well, that being said, let's take a look at real-world example of an API. Let's see how we are using APIs in our daily life. Let's say you are searching for a hotel room from an online travel booking site. Using the site's online form, you select the city you want to stay in, fill in the check-in and check-out dates, number of guests, number of rooms, and other information. Then you click the search button. So what's going on between you entering your information and the application displaying you the choices? APIs, that's what. So as you know, the traveling site aggregates information from many different hotels. So when you click search option, the site then interacts with each hotel's API, which delivers the result for variable rooms that are available according to your choice. This can all happen within seconds because an API, which acts like a messenger and runs back and forth between your application, database, and devices. Now you understand what I meant when I was comparing API with a waiter. So it's basically a messenger. API is an acronym for Application Programming Interface, which is a software intermediary that allows two applications to talk to each other without any glitches. So every time you use an app like Facebook to send an instant message or to chat with your friend, whenever you check weather on your phone, you are using an API. So why use an API? What are the main reasons? First of all, it offers effortless integration. It allows customers to access data, server, or any other application in very stable and secure way. Secondly, mobile phones and devices embedded with sensors fit perfectly with the service-based structure of API. So as you know, cloud computing is already in rise. APIs are mainly needed for both the initial migration and integration with other systems in the cloud. And next, APIs offer flexibility. They allows you to quickly leverage and use your desired services on mobile and web. And the IT market is rising, so everyone wants their product to be best, which depends on how intuitive and usable their API is. And lastly, the huge success of APIs. If any company has employed or deployed API and has been successful using that, then other companies also want to do as well. So because of these reasons, API is very popular these days. As you know, software is exactly not perfect every time. So guys, now you know why is there so much hype about APIs. APIs are what gives value to your application. It's what makes our phones smart, and it's what streamlines business processes. So if API doesn't work efficiently and effectively, it will never be adopted regardless if it is free or not. Also, if an API breaks because errors weren't detected, there's a threat of not only breaking a single application, but an entire chain of business processes hinged with it. So the solution: to test APIs before they are put to use. Here are the most common reasons as to why you should test your APIs before putting them to use. First of all, you want to be sure that they're doing what they're supposed to do. You want to make sure that the APIs are handling the maximum load or the amount of load that's been assigned to them. And you want to find all the way users can mess things up when they're using the applications that are linked with API. You also want to make sure your APIs work across different devices, browsers, and operating systems. And lastly, if you don't test your API, it can be costly for you later on. So these are the simple reasons as to why you should test your APIs before putting them to use. So basically, the entire process of testing these APIs is what you call API testing. It's a type of software testing that involves testing your application programming interface or APIs as a part of integration testing to see if they meet expectations for functionality, reliability, performance, and security. So as you can see, I'm stressing on 4 words here. So basically in API testing, you check if APIs meet expectations for functionality, reliability, performance, and security. Most basic level, API testing is intended to reveal bugs, inconsistency, or derivations or deviations from the expected behavior of an API. And obviously the next question that follows after knowing what API testing is: where do you perform API testing? Since APIs lack a graphical user interface, API testing is usually performed at the message layer and can validate application logic very quickly and effectively there. Instead of putting it that way, let me make it more simple to you guys. Commonly, applications have 3 separate layers or tiers, you can say. First comes is presentation layer or user interface. Then you have business layer, application user interface, or you can say for business logic processing. And then you have database layer for modeling and manipulating your data. So application programming interface testing is performed at the most critical layer, which is the business layer, where business logic processing is carried out and all the transactions between user interface and the database happen. So basically in API testing, our main focus will be on business logic layer of the software architecture. And I have to tell you guys, API testing, like graphical user interface testing, won't concentrate on the look and feel of the applications. So it's entirely different from graphical user interface testing. And API testing also requires less maintenance and effort when compared to GUI testing, which makes it perfect choice for Agile and DevOps teams. So making sure that API offers complete functionality allows for the easy future expansion of the application if you want to do so later on in the future. So that's what API testing is all about. So now that you know what API testing is and where you perform API testing, how do you actually go ahead and proceed or perform API testing? Well, it's a 5-step process. First step is documenting the API testing requirements, like what is the purpose of API, what is the workflow of your application, what are the integrations supported by the API here or in your application, what are the features and functions of the API that you have included in your application. Documenting all these API testing requirements is the first thing you need to do. This will help you in planning API tests throughout the testing process. So the first step is just preparing a plan. Next step is setting up test environment according to your plan. So you'd set up testing environment with the required set of parameters around the API. This involves configuring the database and the server for the application's requirements. So once the setup is done, it's good to make an API call right away to make sure nothing is broken before we move forward with any kind of testing. So the next step is to combine your application data with your API test to ensure that API is functioning as it is expected to under different or basic conditions, or you can say different input configurations. And then you need to organize yourself around the API test. For that, you need to start asking questions like, who is the target audience here? Who is your API customer? What aspects are you testing? What problems are we testing for? What are your priorities to test? What could potentially happen in such circumstances? Now, after performing the test, when you should consider a test as a pass or a fail? What other APIs could this API interact with? And so on, like that. Many different questions. So after you have created these testing boundaries and requirements, you need to decide what you want to test on your API for. Well, we will look into what kind of API tests we can perform in the next part of the session. So I leave that step blank for a while, which is our fourth step, deciding on what to test API for. And finally, once you have decided, the next step obviously is to create test cases around the requirements and execute them. A basic guideline is to identify the most common parameters and conditions that an end developer will use when calling the APIs. And based on that, you should create your test cases and execute the tests. And I'm sure the last step is the common step. You document your test results and give it for review. So let's just summarize what are the steps. The first step is preparing a documentation or a plan on what you're doing or you're trying to do. Then according to the plan, you set up your test environment. Then you combine your application data with your API test to make sure that your API is working perfectly under different input configurations. And then decide on what kind of API test you want to perform. And lastly, create the test cases based on your requirements and execute the test and create the test result report. So it's that easy. So one of the most important steps while performing API tests is to decide on what kind of test you want to perform. For that, you should be aware of different types of API testing. As you can see, there are multiple types of API testing. First, you have functionality testing, the basic testing. So you perform functional tests to check if the API works and does exactly what it is supposed to do. Functional testing includes testing of a particular functions in the code base. So that's what functional testing is. It's all in the name. Then you have reliability testing. Basically here, you're checking if API can be consistently connected to whenever you want and lead to consistent results always. And then you have load testing. Well, load testing you can say is a test which is obsessed with reality. Here, you ask yourself, you test your API on different scenarios like, does this code of my API work in theory? Will this code work with 1K request, 10K request, and 100K request? So basically, you're trying to check if API can handle the load. Load testing is basically performed to ensure that the performance under both normal and at peak conditions is normal for an API. You have different scenarios under that. For example, you have baseline scenario. It tests the API against textbook values, regular traffic that API expects in an ordinary usage. Then you have theoretical maximum traffic. That is to make sure during the full load periods, the solutions respond to the request properly. Then you have overload test to test the maximum capacity according to the theory. Maybe then add 10 to 20% more to the peak traffic. So this way you have different kind of load testing. And then you have end-to-end testing or UI and UX testing. It involves testing user interface for the API and other integral parts. Interface here naturally can be graphical user interface or GUI, or it can rely on the command line endpoints as well. And then you have interoperability testing and compliance testing. This type of testing applies to SOAP APIs. It ensures that the predefined standards of your API is met. And then comes security testing. Security testing, penetration testing, and fuzz testing are the three separate elements of security auditing process. They are used to ensure that the API implementation is secure from external threats. That's the common point for all security, penetration, and fuzz testing. So besides enclosing with penetration and fuzz testing, security testing also includes additional steps like validation of encryption methodologies and of design of the access control for the API. And then comes penetration testing. It's considered the second step in the security auditing process. In this testing type, users with limited API knowledge will try to attack to access the threat vector from outside perspective. Well, it's all about functions, resources, processes, or sometimes it can be an entire API from the outside perspective. And then comes fuzz testing is another step in the whole audit process. In this testing type, a vast amount of random data, which you usually refer to as noise or fuzz, will be input into the system with the aim that they want to forcefully crash the system and see what happens. This way, when there's an actual threat from the outside, they can react back to it very quickly. That's what fuzz testing is all about. So basically, fuzz testing will help the API in terms of limit to prepare for the worst case scenarios. With that said, these are the most frequently performed API tests. So by performing this test, what are you trying to test for? And what will you find? So basically, by performing all these tests, you're checking for duplicate or missing functionality, or improper messaging, multi-threaded issues, or performance issues, or it could be about incompatible error handling, or it could be about reliability issues. So basically, by performing all this different kind of API tests, you are trying to find these kind of bugs. Since API testing is gaining popularity, we have many tools available for performing the same. Here are some of the top API testing tools that you can use for REST and SOAP web service testing. For example, you have Postman, you have Catalan Studio. Well, we'll be using one of these, which is Catalan Studio, to see how to create API tests. Then you have SOAP UI, then you have Tosca, Parasoft, Assertable. Well, these are very few. Basically, I just listed the most popular ones. Apart from these, there are many other tools outside. Well, you can choose any one of them according to your requirements and comfort. Now let's discuss benefits and challenges that you might face while performing API testing. So as we discussed, API testing is an important activity that testing teams should focus on. It offers a number of advantages over other kinds of testing. For example, first of all, it's language independent. Data here is exchanged via an XML or JSON format. So any language can be used for automation independent from the languages used to develop the application. XML and JSON are typically structured data. So the verification is literally very fast and stable. In these XML and JSON also have built-in libraries to support comparing data in different data formats. So the first reason is it's language independent. Then it's graphical user interface independent or GUI independent. We can perform API testing within the application prior to GUI testing. And this early testing will help you get feedback sooner and so that you can improve the team's productivity. Core functionality can be tested to expose small errors and to evaluate team strength or your application build strength. Then it offers improved test coverage. Most API services have specifications allowing us to create automated tests with high coverage, including functional testing and non-functional testing as well. And nowadays there are multiple techniques which are available using which you can find API test cases that could not be automated. So this way you can improve the test coverage by using either manual API testing or automated API testing. And another most important benefit of API testing is it reduces testing costs. API testing helps us to reduce the testing cost. With API testing, we can find minor bugs, like I said, before graphical user testing. These minor bugs will become bigger during graphical user interface testing. So finding these bugs in the early stage itself is a very good process and will be beneficial. And lastly, API testing is a step for faster release. It's common that executing a UI regression test takes about 8 to 10 hours, while the same scenario with API testing takes only 1 to 2 hours. You see the difference there, right? The flackiness of API testing is also lower than that of UI testing. All these allow us to release are built faster with API testing. So these are certain benefits that you get out of performing API testing before putting your API to use. It's language independent. So basically you can use any language irrespective of the language the application is developed on. It's graphical user independent. You can find out the bugs in early stage. Because of that, the testing costs are also reduced. And obviously it offers improved test coverage and faster release as well. Well, that's about the benefits. But again, like any other testing process, there are certain things that you will come across or you will feel difficult when you're performing, just in API testing as well. The point of not having graphical user interface can be a benefit as well as a challenge. We discussed why it is a benefit. Now let's see why it's a challenge. APIs are primarily intended for computer-to-computer communication. Like I said, they're like a messenger between two applications. Computer doesn't need a user interface. This is a challenge if you're a tester who is used to testing applications designed for end users with a graphical interface where you can click, drag, and in general manipulate an application or data visuality. So basically, if you are familiar with all those graphical user interface features, it might be difficult to jump into API testing. And then you have synchronous and asynchronous dependencies. So often APIs rely on other APIs or other backend systems to function properly. So if any of these steps or systems are out of place, all the assertions connected to it will fail. So this way, when your API is connected to other APIs or any backend systems, like synchronous and asynchronous dependencies are there, then it might pose a problem. And during API testing, it's difficult to test data management. So basically, API testing verifies the business logic of an application layer, which often has millions of permutation and use cases. So it can be difficult to propagate scenarios that sufficiently test your API boundaries. And then there is a problem of request and response. As stated before, APIs work on a request and response relationship. SOAP and REST APIs have different standards for the request and response calls that you will have to be familiar with before you actually start performing API testing. And that task can be difficult. SOAP-based API use XML as a communication protocol. That means as a tester, you must be able to read, understand, create, and update XML documents. With REST-based services, the request can be much simpler. For the most part, it only involves sending an URL to the service. Thing here is you need to have certain technical knowledge before you actually jump into API testing. That's very necessary. And lastly, there's no documentation and there are a lot of time constraints in API testing. The APIs developed will hardly have any documentation. Without the proper documentation, it is difficult for the test designer to understand the purpose of these calls. Parameter types, the possible valid and invalid values, the written values, the calls it makes to other functions, and usage scenarios. To avoid that, like I said earlier, the first step of your API testing should be documentation. Thorough testing of API is almost time consuming. It requires a learning overhead and resources to develop tools and design tests that will suit your requirement. So these are certain challenges that you might come across while performing API testing. So guys, that's all with the theory part. I hope at this point of time you're aware of what API is and why do you need to test your APIs before you put them to use and how to perform API testing. Like I said, there are different tools which you can use to perform API tests. Like you have Postman, Catalan Studio, Parasoft, Assertable, and many others. Now that we're aware of the theory part, let's go ahead and use a tool called Catalan Studio to see how to create API test cases and how to perform tests on API. So guys, in today's session or demo, we'll be using a tool called Catalan Studio. So basically, Catalan Studio is a robust and comprehensive automation tool for testing APIs, web, and mobile testing. I already have it downloaded and installed on my PC. All you have to do is search for Catalan Studio and you can just go for the first link that you find. So this Catalan Studio provides easy deployment by including all frameworks, ALM integrations, and plugins in one package. It has a unique feature which is combining UI and API web services for multiple environments. And another thing is that it's a free tool. And apart from that, Catalan Studio also offers paid support services for small teams, businesses, and enterprises. As you can see, the most benefits of using Catalan Studio are listed here. Simple deployment, its easy to use interface, and like I said, it has a full feature package and it has an active community of about people from different 160 countries across YouTube channels, GitHub repositories, Udemy courses. So if you face any problems or if you have anything to contribute, you can go ahead and discuss your queries there. So the things that we are interested today or we would be interested today about Catalan Studio is that it supports both SOAP and REST requests. SOAP and REST are two different kind of APIs. It also supports data-driven approach and it supports CI/CD integration. Apart from this, it has many other cool features that you can go ahead and research on. So like I said earlier, I already have it installed. If you do not, you please go ahead and click on this download button. A zip file will be installed on your computer or downloaded on your computer. You can unzip it and install the application. Well guys, I am using this tool for no particular reason. There are many other tools which might suit your requirement and you're free to go ahead and use any of these. So let's proceed with the demo part now. So guys, if you have installed Catalan Studio perfectly, then this is the home page where you will land on. So as you can see, this page is basically what is known as Catalan Help, or you can say the documentation part here. You have tutorials on how to use different features of this application. Then you have different FAQs and different plugins that you can add. Like I said earlier, you can use Catalan to perform tests on web user interface, API, mobile testing, and scripting as well. But as for today's demo, we are interested only with API. So you have getting started as in the tutorials here. You have the sample projects that you can go ahead and start with if you're not familiar with the tool. Then you have the folder which shows the recent project that you might have done. So as you can see, I've done a sample demo. So it's showing a sample demo here. But if you have missed the page, all you have to do is go for help here and you have Catalan help here. You can click on that and you'll land on this page again. So let me close the tab. So if you have gone for API, the page we'll land on is this page. You can see the test cases, object repository, you have test suite, data files, checkpoints, different keywords, and you have test listeners, reports, and other features or other plugins. We won't be using all these today for few. So the first thing you need to do is go ahead and create a project. You can see the plus a symbol or the new symbol here. Click on that and go ahead and create a folder. Let's say testing API. And okay. So the first thing here is we need to have an API to perform tests on, right? For that, you can go ahead and search for sample APIs that are available on the net. Before that, we'll create a folder in object repository where you actually store your APIs. So go for new, create a folder. Let's say API testing and okay. Under this, you can go ahead and create a web service request. User details. It's a RESTful API. For now, since we don't have URL, let's just leave it blank and click OK. So as you can see, it's ready here. But the only thing that we need here is an API, a sample API to perform tests on. For that, we have a Google. All you have to do is, I'm going to search for sample APIs. So like I said, guys, there are different APIs, REST API, SOAP API. But for today, we'll be checking out how to perform tests on REST API. So I'm basically going for the first link that's here. You can go ahead and use any of these fake online REST APIs or the sample REST APIs available online. So as you can see, I have different kinds of APIs here. I have get, I have post, put, then I have delete, patch, post, and all that. So let's go ahead and take one, list users. And all you have to do is copy this link in and paste it in a new folder and copy the request. Control C. So as you can see, here is our API, but it's in a different format. All you have to do is copy this URL, go back to Catalan Studio and place it here and click on this test request button. And it's asking if I want to save the changes and okay. So the request has been sent and we're waiting for the output. Let's see. So here it is. So as you can see, the status of this response is 200 okay. It has taken so and so time and the size is about 1 KB. You have different formats of representing your API request here. For now, it is in JSON format. You can opt for XML or HTML or JavaScript and all that. So let me get back to JSON. And you have something called pretty format. As you can see, it's better to understand and easy to figure out. You have something called raw format, which we saw when we just copied the URL, right? This is the raw format. Going back, you have preview, and that's how it's supposed to look in the preview and all that. So any of these you can choose according to your comfort. So right now we have created a folder under object repository called API testing, and we have a get API or the get command. This is the URL. We have pasted it here. So now that our API is ready for testing, the next thing is to go ahead and create test cases. So guys, I've directly started doing all that stuff here, but you have an option to go and start with the sample project where the sample test cases and the sample API will be provided to you in the Catalan Studio. Go ahead and explore the Catalan Studio application. You'll find it. So now that we are done with our object repository, as in we have our API, let's go ahead and create few test cases. So the good practice to follow is always to create a folder and create test cases under that so that your test cases are not jumbled or placed here and there. So let's create a folder. Let's give it a user detail verification. Details verification and okay. Now under that, new and create a test case. Verification, let's say a details verification. Tags are really important because right now I have only one test case, so it's very easy to search. But when you're doing an actual project of performing an API testing, you'll have multiple thousands of test cases, like I said earlier, when we were discussing the challenges that you come across when you're performing API testing. So you'll have multiple test cases for multiple scenarios. So it's better to add tags so that whenever you want to search a particular test case, and if you just type the tag related to it, you'll be easily able to find where the test case is. Details and okay. So here we go. As soon as you create a test case, you'll land on this page where you can add your service word. There's an option where it says add web service keyword. Then you have just add option. This is for the web service keyword because we are doing a simple project or the sample project on web service testing here or API testing. But you can go ahead and do it for mobile testing, cucumber keywords or custom keyword. If you create one, you can add different kind of decision making statements and all that. That's way too complicated for this video. So let's go ahead with our demo. So anytime you're performing an API test on web services, the first thing you need to do is send a request. You have that here as well. So click on this add web request. The first thing that pops out is send request. And the object repository or the API which we're performing test on, or for the API request to get, all you have to do is copy, drag and drop it here. Or you can just double click on the folder and it will take you a page where you have list of APIs and you can choose on the one you want. And you need to assign a name to the output which you get for the object. So let's just say response. Let's say result1. So yeah, we have added our first command and let me save it. So what I want to check for here, let's go back to the view. I want to check if the status code is 200 or not while testing. So what I'll do is I'll add the web service command there. But before that, you have different status values here. You can just click on this and it'll take you to a page where you'll be shown with what each response code means. For now, we have something called 200, okay? Similarly, you have different things like 100, 101, 201 and all that. What does it say? For now, it's 200. And then you have 202, which says the request is accepted. Then you have 206 for the partial content. Then you have 303 for see other. Then you have to use proxy 305, like that. Multiple. Every request has an status associated with it, right? So if you want no more, you can just double click on that. You'll be taken to that page. So where was I? Getting back to what to test. Let's test if the status code is 200 or not. Let's go back to our test case and I'm going to add a new web service. You have a drop down command here. You can just click on that. And what I want to check verify response status code. Click on that. So input. To test, you need to give the input, right? So you can double click on that and it's the response object, which is a variable. What did we give? It's result. So type that here. And obviously the value which you want to test it for. Let's say 200. And okay. And that's done. Let's add one more command. Let's say for now, I know that this request is supposed to be 200 status. But what if I don't know the status? I just know the range of it. Then I want to check if the status of my request lies within the range. You have that option as well. You can go on add web service again. And you have something says verify response status code in range. Again, you can just go ahead and add the input here. So again, guys, if you are new to web service keywords or this API testing, and if you have no idea what keywords to choose, what you want to test for and all that, you have an option which says keywords browser, and there you have different kind of options to browse, or you can say documentation. You can actually go for official documentation in the Catalan Studio website, but you also can do that here. You have built-in commands for web UI keywords, you have mobile keywords, you have cucumber keywords, you have web service keyword. So the thing which is related to the demo which you're doing right now is web service keywords. So you have different options for element number, request, test, and utilities. Let's say for request, we just use the send request. So when you click on that, dialog box pops up which says what exactly does that keyword do. It sends an HTTP request to web server. That's what this send request does. And what if an error pops out, it throws an exception. So what are the parameters that you need to mention for that keyword and all that? There's something called send request and verify as well. It sends an HTTP request to web server and verifies the response. It does the both. You will check that out later. And then we have something for number basically, or equal to, greater than, less than and all that. You can go ahead and check that. Then you have element features which you want to check. We'll do that right now in the demo part. You have an option to check verify element property value. Let's see what that is. So if I scroll down, it says verify that there's an element with expected property value appear in the return data from a web service call. Basically, you're checking if the particular value which you have given in the input is there or not for that particular element using this element keyword. You have text, verify element text, verify element count. Then you have verify element response code, which we just did, and verify response code range that we're using. So if you're not familiar with the keywords, you can go ahead and use these. Refer to that or in the documentation. Getting back to our command, we have three options here. The first one is basically the object variable which you've assigned. So it's a variable. And what is that? It's result. It's a number. I want to check if it's between 100 and let's say 150 and 201. And okay. So let's get back to our request format and see what else we can do. As you can see, under this data, I have three elements. I have one which is related to ID4 and one ID5 and ID6. So basically I have 3 elements for this data. So I want to check if for the ID4 the first name is Eve or not. So what do? Go for the detail verification and click on add web service keyword here, verify element property value. And as you can see, we have 3 inputs that we are supposed to provide. Obviously the first one is the variable name which we've given, its result. Next is locator. Locator is something which is basically telling the application or the Catalan Studio application here that please go there to that particular location, and that's the element value that I want to check on. It's like a path. So what do you do for that? Let's just click for OK. For that, you can find something called JSON Path Finder. You have a Chrome plugin as well that you can add to your plugins. So you can just use an online JSON Path Finder. I'm just using the first one I found. So what you have to do is here, enter your JSON in the editor, select the item to view its path, and replace X with the number or the name of your variable. So that's what I'm going to do, user details. This is my JSON inputs. So I'm going to copy the entire thing and paste it over here. So as you can see, the details are shown in the third page. I mean the next part of the screen. So as you can see under data, I have 3 elements. What I want to check is if the first name is Eve or not. So click on that. You can see a locator here in the path variable. So copy that. Go back to the Catalan Studio. In the string, I'm going to paste it here. And next is obviously again the string that I want to check for. Right now I'm giving the right value, which is Eve, right? So again the string Eve, and click on OK. So guess this is enough for now. Let's go ahead and check if the test is running. All you have to do is click on the run button here. So guys, this is what you say the manual format, as in you're manually entering using different drag and drop options and all that. You have something called script format as well. You can go for that. As you can see, this is a script format. Let me just minimize this. So these are the commands that we just added. First of all, we sent a request for the web server. Then we added a command to check if the response code is 200 or not. Then we did the same thing to find out the range of it, as in if it lies within the range, and to check the property value now. So guys, what I'm trying to tell here is that you can either use the manual format of it or the script format of it. If you're most familiar with the script, go ahead and use that. So again, let's go back to manual. And now I want to check if the test is performing well or not. All you have to do is click on this run button. And to view the output, you can just go for this log viewer. As you can see on the screen, the test is being performed. The output for every step or every keyword that we've added will be shown here. It says the first step is a success, as in the request is being sent. Our status code is 200 and status code range is 200, which lies between 150 and 201. But then there's a failure with the last one, which says unable to verify element property value, root cause null pointer exception, cannot get property data in the null object. Give me a minute, guys. I'll figure out the error. So guys, so what do you think the error is? Let me check the user details again. Okay, the first name is Eve, but it's in capital. So as you can see, that is why the test has failed. Now let me edit the string value here and see if it works. Capital Eve and click on OK. Let's save it and try to run the test now. I'm going to go for the log viewer for the full thing. So again, the test connected. Again, it's wrong. So it's not the problem. So sorry about that, guys. The error was that here in the JSON path, I had another variable, which is x.data, the copy thing. I mean, there was an extra letter in the JSON path, which I pasted here. So I did paste the correct part right now. It says the 0th or the first element of data. And the first name that I want to check is Eve or not. So after doing that, I did. And then if I click on run button. So here we go, the log viewer. So as you can see, all the 4 steps are correct. By mistake, I've shown you the result of giving the wrong input as well. So that way you can make sure your API testing is working well by giving different options for different web service keywords here. Well, we have checked few. Let's go ahead and add one more. So as you can see in the user details, I have 3 elements under the data elements. As you can see, the one with ID, one with ID 5, and one with ID 6. So I want to go ahead and add one more command, add keyword. I want to check the elements count here. It checks the number of elements present. Well, again, the variable is result. So I'm going to enter that. And again, I need a JSON path. And let's say I want to check if it's 2. It should basically give me an error because there are 3 elements. So let's go ahead with the negative case and OK. So data. And I'm going to copy this So as you can see, the error which I did earlier was I copied the X as well. I don't need to do that. I just copy data from data, whatever it is. So when I say first name, I just have to copy from this data to the first name. Right now, I just want the path of this. So that's just data. We can just type it here. So data and enter. Well, it should show us an error, but how about we give positive keys? Anyway, we're testing, so I'm gonna save it. So what do we do before that? I'm gonna show you another thing. Let's make it negative case. Let's say if and okay. Now after saving, if I run the test, so it's basically checking for the every step. The request is being sent. The next step is to check for the response code. That's done. Response code range, that's also done. But since the fourth keyword, which is to check the element property value, since we have a negative case, the program stopped executing there. It didn't go beyond that. But after that, we do have another keyword for which it has to check to. So for that, we have different properties to go ahead and change how this keyword has to behave. You can right click on that. You have something called change failure handling here. So you have different option which says you have to stop on failure or continue on failure. Let's say we have given continue on failure. So it will stop, it will execute the step even if it's there error, it shows an error and go to the next part of it. Let me save it, and if you click on run again, let's go for the log viewer. Here we go, guys. It didn't stop there, it went for the next step as well, and since that was also a negative case, it's shown that there's an error. It says it's not equal with the actual property value Eve, and there's one more error, right? When you click on that particular step, it says expected element count 2, which is not equal to the actual count 3. So that's the error. That's how you perform tests on API. Apart from this, if I click on the objective or the API request here, which is get request basically, you have different options here as well to check out. You have something called authorization. If you are actually providing some email ID and all that, you have, or as in you're testing for the login page and all, you have authorization. Right now, we do not have any authorization. You have multiple authorization options as well. Basic, auth 1, not 0, 2, not 0, and all that. Then you have something called HTTP header. Right now, we do not have an HTTP header. If you do, you can add it here. Same goes for the HTTP body. But the important thing here is something called verification. So as you can see, there are already some snippets here, or the test scripts which are already written for this, for which response is received. You have get a variable, response body contains string. Then you have convert to JSON is equal to string or not, status code. So if I click on that, you can see a command being added. Let me hide this and let me expand this for you. As you can see, when I clicked on that, this was added. Assert that the entire thing to verify if the status code is 200 or not, and to assert that it's equal to 200. Similarly, let's check out on the snippets. I clicked on JSON value check. Let's see what does that have to add. So it says the verify element property value is so and so, but right now the actual data is not put here. It says the random data. Let's say I want to check if the ID is 6. All you have to do is place the cursor on the option that you want to check on and press Ctrl K. You can see a command or the verification command being added to it. You can see a fly command property value. So it says verify element property value data 2 as in the for second element if the ID is 6 or not. So that's another way of adding verification snippets. Once you've added, all you have to do is click on this test request and do you want to save changes? Okay. So the request has been sent again. Now you can go for something called verification log here. So guys, as you can see, when I place the cursor on ID6 and pressed Ctrl K, the command has been added to my script, which is verify element property value if the ID is 6 or not for the second element. Now that I've added it, I want to check if the verification is passing. What you have to do is test click, not just click on the run button, click on that and say test request and verify. If you do that, again, a request will be sent. And you have something called verification log here. As you can see, when you see that, it says the result has been passed. So that's another way of doing it. Now let's go back to details verification, and after send request, let me add one more command. I want to send request and verify for the same thing, result 1, and click. Then let me make all this right. I want to give the right data, Eve, and I'm going to make it 3. So now if I run, everything should be green because we have given the right data, right? So I've clicked on the log viewer, it's maximized the screen. So as you can see, the first is supposed to send the request. It's walk and verify the status code is 200. Yes, the result one, send request and verify. So it'll verify the verifications which you just added. That also work. Then you have status code range. 200 lies between 150 and 200 mod 1. So it worked. Then the property value for Eve and the result data is 3. So as you can see, everything is passed properly. So guys, that's as easy it is to perform testing using Catalan Studio. Well, what I've done is really basic because since we're learning the basics here, so we have just performed testing only for the GET request. So like I showed you guys earlier, we have different kind of requests here. We have post request, patch request. But when you go for the post, you have two things. You have response and request here. So you have an HTTP body as well that you will have to add. Well, obviously this is your JSON format API request, but this is the body where you have to add. I did show you here in the user details. You have something called HTTP body. So when you are trying to test for post or put and all that, you'll have two things. You'll have to paste this thing in the body part and then proceed with your testing. Then same goes for the get. For the get, we do not have any body, so that's it. So guys, that's all about it. And one more thing, this is for the REST API. You also have something called SOAP API. For that as well, you have an option to go ahead and perform tests. So guys, that's about it. We did see how to use Catalan Studio to perform API tests. Like I said, it's a very basic testing which we did earlier. You can go ahead and use the Catalan Studio for performing SOAP tests and add your test cases to Test Studio so that you can view your reports and all that.
So what is this agile testing? Now, agile testing is basically a software testing process that follows the principles of agile software development. Now, agile is basically an iterative development methodology where requirements evolve through collaboration between the customer and self-organizing teams, and agile aligns development with the customer needs. It is not sequential but a continuous process. Now, this methodology is also called release or delivery-driven approach since it gives a better prediction on the workable products in short duration of time. So let's move on and have a look at the different principles of agile testing. Now, the first one is that testing is continuous. Now, the agile team tests continuously because it is the only way to ensure continuous progress of the product. Then we have the continuous feedback as well. So, agile testing provides feedback on an ongoing basis, and this is how your product meets the business needs and also satisfies the customer requirements. Then we have the tests performed by the whole team. Now, in a traditional software development life cycle, only the test team is responsible for testing. But in agile testing, the developers and the business analysts also test the application. Next up is the decreased time of feedback response. Now, the business team is basically involved in each iteration in agile testing, and continuous feedback shortens the time of feedback response. Then we have the simplified and clean code. So all the defects which are raised by the agile team are fixed within the same iteration, and it also helps in keeping the code clean and simplified. Next is less documentation. Now, agile teams use a reusable checklist. The team focuses on the test instead of the incidental details. And finally, we have the test driven. Now, in agile methods, testing is performed at the time of implementation, whereas in the traditional process, the testing is performed after implementation. So these were some of the principles that are followed while performing agile testing on any software. Now let's move on and have a look at the different advantages of agile testing. So the first benefit is that it saves time and money. Now, with the help of agile testing, you get to know about the problems in your software in the earlier stages, and this saves a lot of time and money as well. Next up is the documentation. So agile testing basically reduces a lot of documentation involved in the process. Then we have the flexibility and adaptability. So agile testing is basically flexible and highly adaptable to changes. So you would not face any trouble if there are any changes that are to be made in the software during the process. It also provides a way for receiving regular feedback from the end user. So the more amount of feedback that you receive, the easier it becomes to solve the problems and also meet the requirements of the user easily. And finally, there's better determination of issues through daily meetings. So there are daily meetings happening for the agile testing that lets you know about the whole process and also the improvement that is happening. So these were some of the advantages. Now let's have a look at the different testing methods for agile testing. Now there are various agile testing methods. So first we have the behavior driven development, then the acceptance test driven development, and finally there's the exploratory testing. So the first one is the behavior driven development. Now the behavior driven development improves communication amongst project stakeholders so that all members correctly understand each feature before the development process starts. Now there is continuous example-based communication between the developers, testers, and business analysts. Now these examples are called scenarios which are written in a special format. The scenarios hold information on how a given feature should behave in different situations with different input parameters. These are called executable specifications as it comprises of both specification and inputs to the automated tests. Next up, we have the acceptance test driven development, that is the ATDD. Now, the ATDD focuses on involving team members with different perspectives, such as the customer, developer, and tester. So, the three amigos meetings are held to formulate acceptance tests incorporating perspectives of the customer, development, and testing. So, the customer is focused on the problem that is to be solved. The development is focused on how the problem will be solved, whereas the testing is focused on what could go wrong. The acceptance tests are a representation of the user's point of view, and it describes how the system will function. It also helps to verify that the system functions as it is supposed to. In some instances, acceptance tests are automated. Now moving on, the final one is the exploratory testing. Now in this type of testing, the test design and test execution phase go hand in hand. So the exploratory testing emphasizes working software over comprehensive documentation. The individuals and interactions are more important than the process and tools. So the customer collaboration holds greater value than contract negotiation. Exploratory testing is more adaptable to changes as well. Now in this, testers identify the functionality of an application by exploring the application. So the testers try to learn the application and design and execute the test plans according to their findings. So the process goes like this. First you learn, then you design a test and then execute that particular test, and then finally you analyze the test results. So these were some of the agile testing methods that you need to know about. Now moving on, next up, let's have a look at the life cycle of agile testing. So the life cycle of agile testing consists of 5 different phases. So first we have the impact assessment, then agility test planning, then daily scrums, then agility review meeting, and finally release the readiness. So in the first phase, we gather the input from the stakeholders and users, and this will act as feedback for the next deployment cycle. The next phase is the test plan meetup. Now here all the stakeholders come together to plan the schedule of testing process, meeting frequency, and deliverables. The third phase is the daily stand-up meetings. Now this includes the everyday stand-up morning meeting to catch up on the status of testing and set the goals for whole day. Next up is the agility review meeting. So weekly review meetings with stakeholders meet to review and assess the progress against milestones. And finally, the last stage is the approval meetings for deployment. So at this stage, you review the features that have been developed or implemented and are ready to go live or not. So this is the life cycle that is followed in the process of agile testing in case of any particular software. So now that you know what is agile testing and also the different advantages and how it actually works, let's have a look at the test plan for agile testing and also the quadrants. So first let's talk about the agile test plan. Now in agile testing, the test plan is written as well as updated for every release. So the test plan in agile includes the scope of the testing, then the consolidating new functionalities that are to be tested, then we have types of testing or various levels of testing. And next up we have performance and load testing that needs to be performed on your software. Next we have the consideration of infrastructure. And then we have mitigation or the risk plans where you have to know about the risks that might occur during the testing. Then we have the different planning of resources, and finally deliverables and milestones, because you need to deliver your product as soon as possible in order to meet the requirements of your customer. So this is the plan that you must follow while performing agile testing on your software, and also in order to deliver an error-free software. Now, talking about the agile testing quadrants, these basically separate the whole process in 4 quadrants and help to understand how agile testing is actually performed. Now, for the first quadrant, that is the agile quadrant 1, the internal code quality is the main focus in this quadrant. It consists of test cases which are technologically driven and are implemented to support them. So it basically includes the unit tests and the component tests. So here we have the various unit tests and component tests. And also this is the automated quadrant. Now the agile quadrant 2 contains test cases that are business driven and are implemented to support the team. Now this quadrant focuses on the requirements. The kind of test performed in this phase is the testing of examples of possible scenarios and workflows, testing of user experience such as the prototypes, and also pair testing. This can be automated and manual as well. Now the Agile Quadrant 3 provides feedback to quadrants 1 and 2. The test cases can be used as the basis to perform automation testing. Now in this quadrant, many rounds of iteration reviews are carried out, which builds confidence in the product. So the kind of testing done in this quadrant is basically the usability testing, exploratory testing, pair testing with customers, collaborative, and also user acceptance testing. Now moving on to the final quadrant, the fourth quadrant basically concentrates on the non-functional requirements such as the performance, security, stability, etc. Now with the help of this quadrant, the application is made to deliver the non-functional qualities and the expected value. Now in this quadrant, the kind of testing done is the non-functional tests such as the stress and performance testing. Then we have the security testing with respect to authentication hacking, and also infrastructure, data migration, scalability, and load testing. So now that you know why we need to perform agile testing in our everyday life, let's move on and have a look at the big companies that actually use agile testing for their software. So let's have a look at some of the big names. So there are Cisco, Sky, Philips, Vistaprint, JP Morgan Chase, IBM, and many more such companies that use agile testing as one of their methodologies. Now Sky might be a household name famous for its satellite TV, broadband, and telephone services, but the media provider is almost making a name for itself in software development. So the company, which has launched products to combat the likes of Apple's TV box, has been placing agile methodologies and open source at the center of their software development approach. Not just that, Philips has also adopted the agile principles. Now, after numerous changes to management structure, the firm introduced several agile coaches that went to deploy Scrum principles, such as Scrum boards and breaking down teams into smaller ones. As a result of changes like this, teams could react to situations quicker, bureaucracy was removed, and it was ultimately easier for these smaller teams to take responsibility for their respective products. Not just that, Vistaprint is also the go-to marketing company for small businesses. Now, the company performed some analysis of their existing waterfall methodology and found that teams were taking more than 60 days to move from the ideation phase to product delivery. Now, the 60-day cycle only amounted to 40 hours of actual work. The company looked further into why this was the case. It transpired that unclear decisions and long creative lead times were to blame, all of which resulted in feedback loops. That's when they moved to the agile testing. This is also the case for JP Morgan Chase. Now, a few years ago, the baking giant overhauled their business processes to help improve product development and simultaneously slashed the cost of training as part of a high-profile IT initiative. Now, agile methodologies were a key part of that particular initiative.
So the most basic type of testing is unit or component testing. The goal of unit testing is basically to segregate each part of the program and test those parts individually to check if they're working properly or not. So it isolates the smallest piece of testable software from the remainder of the code and determines if it behaves exactly as you expected and according to your requirements or not. Generally, those small pieces of software that I've been telling before are usually referred to as unit. So this unit can be almost anything you want it to be. It can be a line of code, it can be a method or a class or some sort of program or a part of application program, anything. But smaller the unit is, it's always better. Smaller tests give you much more granular view of how your code is performing at basic level. There is also the practical aspect that when you test very small units, your tests can run very fast, like 1,000 tests in second fast, that fast. Well, here's a simple example to help you understand what a unit can be or how unit testing is. So consider this simple code. Well, I have a simple function or method here. The function, as you can see, the main function, it's performing division operation. It's accepting two parameters a and b, and it's returning the value that you get after dividing a by b. And next comes the testing function. As you can see, the testing function is written in Ruby. Well, the language doesn't matter. The language, whichever you're comfortable with, you can use that. Anyway, as you can see, I have two variables, a and b, and I'm assigning values 6 and 2. And in the assert equal function, I'm calling the divider function. And I also have the first parameter, which is the value which I'm expecting that the division function should give it to me. So the value which I'm expecting is 3, and I'm passing the function and parameters to that function. So after dividing a by b, which is 6 by 2, I get the answer 3. And assert equal functions tells me that 3 and 3, the expected answer and the actual answer I got are the same. So my function is working properly. Well, this is a positive case. You can also do that with the negative case, as in you can just change the 3 expected value to 4 and see if the assert equal function returns you the actual answer. It says that your test fails. It means that the expected answer and the obtained answer are not the same. So that's how you perform a testing on small unit, which is a part of your entire program. So here the small unit is division function. So like I said, a unit can be almost anything you want it to be. It can be a line of code, or it can be a method, or it can be a class. So this is very basic example, but I'm sure it gives you an idea of unit testing, right? So guys, unit testing is usually performed at the earlier stages of development process, like I said earlier. In many cases, it is executed by the developers themselves before handing the software over to testing team. One of the biggest benefits of this testing is that it can run every time a piece of code is changed. So that way, you can resolve if there are any errors very quickly. And since you're dividing your code into modules here, you can reuse your code and testing becomes much easier and efficient, and your product is well versed in the market. Now to understand unit testing better, let's go ahead and see a simple algorithm. So you start writing your test. So you add your test to the test suite. Then you run the unit test. If the test passes, then you add one more test or add it to the next level of testing. In case your test fails, what you do, you make the necessary changes and you run unit test again. And after you run your test again, if it fails, then you make changes again and you repeat the cycle until the code which you have written is perfectly working and it's returning the value that you're expecting or the results that meet your requirement. And suppose after making changes, if your test passes, then you can add it to the test suite and move it on to the next level of testing. So once you're sure that all your tests are working properly, it means your test suite is perfect and your product is working properly. You can stop unit testing and perform next level of testing. Very simple, right? This type of basic testing offers a lot of advantages, guys. Unit testing provides numerous benefits, including finding software bugs, facilitating change, simplifying integration, providing a source of documentation, and many others. So let's take a look at them right now in more detail. So here are the benefits of using unit testing in software development cycle. So first of all, it makes coding process more agile. When you add more and more features to software, you sometimes need to change old design and code. I'm sure you agree with that. However, changing already tested code is both risky and extremely costly. If we have unit tests in place, then we can proceed for refactoring very confidently because we know that each part of our code is working properly. So code completeness is very important in software testing, especially agile process. So running unit tests can demonstrate code completeness. So unit testing makes code practice more agile and very simple. Secondly, unit testing improves the quality of your code. It identifies every defect that may have come up before the code is sent further for further testing. So writing tests before actually coding makes you think harder about the problem. It exposes the edge cases and makes you write better code. Also, the code that you've written is since divided into modules, it becomes reusable. This means that codes are easier to reuse when you perform unit testing. Unit testing also helps find software bugs early. Since unit testing is usually carried out by developers who test individual code before integration, issues can be found very early and can be resolved easily without impacting other pieces of code. So the advantage of detecting any errors in software early in the day is that by doing so, the team minimizes software risk and avoids spending too much money and time. Unit testing also facilitates changes and it simplifies integration. It allows programmers to refactor code and upgrade system libraries at later date and make sure that the module still is working properly. Unit testing helps with maintaining and changing the code. It reduces the defects in your newly developed module of your code. It reduces bugs when changing the existing functionality as well. Unit testing actually verifies the accuracy of each unit. Afterward, the units are integrated into an application by testing parts of the application via unit testing. So basically, it makes integration much more better. It provides documentation to developers. So code documentation is basically drag and it shows mostly how little code documentation gets written. Unit testing can make the documentation burden a little easier by encouraging better coding practices and also leaving behind the piece of code that describe what your program is actually going to achieve. Unit testing also makes debugging easier and quicker. It helps simplify the debugging process. If a test fails, then only the latest changes made in the code need to be debugged. It's easy, right? It helps create better software designs. Writing the test first forces you to think through your design and what it must accomplish before you actually write the code. This not only keeps you focused, it also makes you create better designs. So that way you're sure that the code you write will perform the right thing at the right time. And lastly, it reduces testing costs. Since the bugs are found early, unit testing helps reduce the cost of bug fixes. So just imagine the cost of bug found during the later stages of development. You will have to modify the entire code of your project. That sounds really tiring and waste of money. So performing unit tests saves you a lot of money and effort on your part. So guys, these are a few benefits of regression testing. I'm sure there are others as well. Make sure you research on it and learn more about them. So there we go guys. I hope you're convinced as to why you should use unit testing. So we have covered the basics of unit testing. If you have any queries regarding what we have discussed till now, please do post them in the comment section and we'll get back to you as soon as possible. So moving on, let's do a simple demo on how to write unit tests. But before diving into the main part of this tutorial and writing unit tests, let's quickly discuss the properties of a good unit test. Unit testing principles demand a good test is easy to write, it's easily reliable, it's readable, and faster and efficient. So easy to write. Developers typically write a lot of unit tests to cover different cases and aspects of application behavior. So it should be easy to code all those test routines without much effort. It should be readable. The intent of unit tests should be clear. A good unit test tells a story about some behavioral aspect of your application. So it should be easy to understand which scenario is being tested. And if the test fails, it should be easy to detect the bug without actually going through the entire program. That's how easily readable your unit test should be. So with a good unit test, we can fix a bug without actually debugging the code. Then it should be reliable. Your unit test should fail only if there's a bug in the system under the test. Well, the thing is, programmers often run into an issue when the tests fail even when no bugs are introduced. So good unit tests should be reproducible and independent from external factors. Lastly, you write your unit tests so that you can repeatedly run them and check that no bugs have been introduced. If your unit test is slow, it will affect the final product. One slow test won't make a significant difference, but add 1000 more and we're surely stuck waiting for a while. Slow unit tests may also indicate that either the system under the test or the test itself interacts with external system, making it environment dependent, which is not a good thing in unit testing. So that's it guys, there are no secrets to writing unit tests. So let's go ahead and write one. So guys, before we actually start with the simple demo, there's certain things which you should know. First of all, to perform this demo, you need IDE. It could be your Eclipse or IntelliJ, anything that you're comfortable with. And you need a unit testing platform, or you can say framework. In here, in this demo, I'm using a framework, a popular framework for Java called TestNG. There's another one called JUnit. You also have different frameworks for different languages that you can use. We'll discuss about the unit testing frameworks later. But as for in this demo, as you should know, I'm using Eclipse IDE and I'm using TestNG for my unit testing framework. So that's all you should know. And regarding how you should install TestNG, there are different ways you can install it using Maven. The easiest way in Eclipse is you can actually install it using Eclipse Marketplace. Well, you have help command here. You can see the menu. You can go for Eclipse Marketplace here and click for TestNG and just click on install. After you've done that, to make sure it's installed properly, all you have to do is go for show view here and click on other. And under Java, make sure that you have TestNG installed here. If it's showing TestNG here, it means that installation has been done properly. So that's all, guys. I've already written program. Well, it's a very easy program. As you can see, I have a math function first of all, and it has one method which adds two numbers. So it's returning int value, and I have first parameter and the second parameter, and I'm adding and I'm returning the value to my testing function. So this is my basic function, and I have a test function which is conducting the test here. So as you can see, I'm using annotations here and importing this because to perform test, since I'm using TestNG, I need to import these details. So I'm using annotations, which is at test. This is called what we call annotations. And I'm using a method called assert equals. So I'm importing that as well. So again, this class contains a single method, which is adding two numbers. I have two variables here. One is expected and the actual. Expected is the one which you want the method to return to, and the actual is the one which actually the method returns to you. So as you can see, the expected value, I'm giving it as, let's say, 4. And as for the actual value, I'm using a math add function, which I've created here. As you can see, I have add function here. And I'm sending two parameters, which is 2 and 2. So if I go back to function, since I'm calling this function, the parameters here will be first is also 2, second is also 2. So 2 plus 2, it should return 4. And here I have a method assert equals. This is the actual value which I'm getting from the math function, and this is the expected value which I've given it 4. And since both are 4, the test should result success. Let's go ahead and check it. It's as easy as that, guys. So this is one unit of your entire program. You can keep adding units in this way. So first we're checking if this unit is working properly. For that, let me run the test. As you can see, it says this test has passed and the test run 1, failure 0, skip 0. It works, right? Let's go ahead and check another further values. Let's say, let me give it as -4 and -2 plus 2. That should be, let me just give it as -3. So -2 plus -3 should be -5. Now if I call assert equals function, the expected value is -4 and the actual value is -5. So the test should return failure. Let's go ahead and check it. So here, as you can see, it's giving a long message. It says this test is failed because expected value is -4, but the actual value is found to be -5. And as you can see in the default test, one test was run. You have one failure and 0 skips. That's it, guys. And now let's make it a little more bigger, as in let's add one more function. In the math function, I have a multiply function here. So let me go ahead and add it. So I'm not negating or I'm not commenting the add function. Let it be there. It's going to give us result for both the functions here. So this multiply function, again, it's taking two parameters. One is multiplicand and one is multiplier. It's multiplying them and returning the answer to us. Let's go to math Java test. Here, I don't have a test annotation for that, right? So let's go ahead and write one. So public void multiply two numbers, return sum. Any name of your function could be according to your wish. And here I go. So final int expected. Let's give it 4. Let's keep it simple for a while and then we'll make it complicated. Final int actual. So multiplicand, let's give it as 2. And the multiplier also, let's give it as 2. Assert equals actual and expected. Okay, let me save it. So obviously the add function, it should result a failure, and multiply, it should return the correct value. So let's go ahead and test it. So as you can see, 2 tests are performed, 1 failure. So let's go ahead and see. It says multiply 2 numbers has successfully passed, but add has failed because expected value is -4, but it was found to be -5. So that's how you write unit test. Let's make it -4 and check if it's working for the negative numbers as well. As you can see, it's showing 2 failures here. Both our multiply function and add functions have failed. So guys, it's as easy as that. First, I wrote a unit test for add function. So that add function is a unit. You can call it a unit, a part of your program. And I've checked, I've tested since the method is working properly. I'm going one step ahead and added one more unit, which is a multiply function. Even it's working properly, then you go ahead and add one more part of or one more unit to your function or the program of your application. So guys, that's how you write simple unit tests. As you can see, the tests were very simple and these are very basic level tests. You can go ahead and explore and make them complicated. So I'm not going to do the divide function. The purpose of this demo was for you to understand how simple it can be and how your unit test should be. Not very complicated. They should be very easy to understand. One look at it, the person who is looking at your code should understand what your code is actually performing. So there you go, guys. That's how you write your unit test. Let's get back to the theory part. So I hope you've understood what we did in the demo. Let's move forward and check out the most popular or the best unit testing frameworks to automate unit tests. So the unit testing framework for C# is NUnit. NUnit is a unit testing framework that belongs to XUnit family and it's written entirely in C#. Now as for Java, you have many. The most popular ones are JUnit and TestNG. JUnit is basically an open source unit testing framework for a test-driven development environment. We call it TDD. It supports the core concept of first testing, then coding. This framework is specifically designed for Java programming language. In this, data is first tested and then it is inserted in the piece of code. So it provides the simplest approach for writing code very swiftly and easily. It also offers annotation for test method identification. As we did in the demo part, we used TestNG and I've showed you how to use annotations and an assert equal function. Moving on, a unit testing framework for C and C++ is MUnit. It's an open source unit testing framework which is designed for software application which is written in C or C++. Well, it's used by both developers and testers for software applications which are written again in C and C++. So next we have unit testing frameworks for JavaScript. As you guys know, JavaScript is the language of web, which is the reason there are a large number of test automation frameworks that support JavaScript. So here's one of the most popular unit testing framework for JavaScript, which is called HTML Units. It is an open source unit testing framework that supports JavaScript and it provides graphical user interface features like forms, links, tables, etc. It offers an open source Java library which contains graphical user interface, less browser for Java programs. It also supports cookie submit methods like get, post, and proxy server. It is used for testing applications that are used within frameworks like JUnit and TestNG. So guys, these are not the only ones which are there in the market. There are many other popular frameworks, but these are the top unit testing frameworks which support different languages. As we discussed, for C#, it's NUnit. For Java, you have JUnit and TestNG. For C and C++, you have MUnit. For JavaScript, you have HTML Unit, JUnit, TestNG, and many others. So if you want to know more about them, you can go ahead and research on them. So what is regression testing? A regression test is a system-wide test that's intended to ensure that a small change in one part of the system does not break existing functionality elsewhere in the system. It's important because without regression testing, it's quite possible to introduce intended fixes into a system that could create more problems than they solve. So let me give you a simple real-world example. You take your car to a mechanic to get the air conditioning fixed, and when you get it back, the air conditioning is working properly, but the gas tank sensor is no longer working. If regression test is an unintended change, then regression testing is the process of hunting for those changes. Put simply, regression testing is all about making sure old bugs don't come back to haunt you. Let's take a look at a technical example that illustrates what can happen when regression testing is not used. So one day, the manager of accounts receivable department at Wayne Industries uncovered a bug in company's financial system. It turns out that the module responsible for reporting overdue invoices was not listing all the overdue invoices. The bug was assigned to a developer to make the fix. The developer followed company policy and unit tested the new code. The unit test proved beyond a shadow of doubt that fix worked as intended. Developer did a good job. The fix was released into production. So far, so good. A week passes. Then a strange behavior occurs when the accounting department tries to run the company's month-end profit and loss statement. Whenever the system tries to issue an aging report, the system times out. So what is aging report now? Aging report separates and sums invoice amounts according to age, like 30 days past due, 60 days past due, 90 days past due, etc. So what happened was, when they were trying to issue an aging report, the system timed out. Without its month-end profit and late statement, the company doesn't know if it's making money or losing money. The accounting department is really upset about it. The accounting manager contacts the software development manager to report the issue and seek remedy as soon as possible. So tech leads and quality analyst manager brought in to find out the issue. Turns out that the new code, which was encapsulated in the function, was only tested for small database. When the same was applied for production data, which is usually very large, the code didn't work as expected. So what you have to notice here is that if the fix had been incorporated into system-wide regression tests that used a copy of data running in production, the chances are very good that issue would have been resolved before the release to production, or discovered actually. That's how important regression testing is. Well, that was a little technical, right? Here's a simple one. This is just the testing of a simple e-commerce website, and here we're checking the functionality of payment options. So first of all, there was only one payment option, let's say credit card. So item has been added into cart, you use the one payment option which is available, then make the payment, and everything is working properly when tested. Now the company wants to add one more payment option, let's say PayPal. So now the company checks if the option of using PayPal is working properly or not. So again, the item is added to cart, the payment is made through the new option which is added, and everything is working again. Now what company does is, it goes ahead and tests for the previous payment option again. Then they find out that the previous payment option is not working properly. So what happened here? The new payment option, which is PayPal, has affected the old one, which was credit card. So what they do? They perform regression testing. So what they've done here is, they're checking if the new payment option has affected the old one in any way. If so, the bugs are identified and resolved. That's what regression testing is all about. So basically, this regression testing is not just done at the beginning, it's done throughout the testing phase, and that we call regression testing cycle. Let me show it to you guys. Here it is. So as you can see, the one on the left side is the regression cycle. So you incorporate your code into the build and schedule the tests. You find a bug, resolve it, and write your regression test again based on those bugs and the fixed issues, and run those regression tests. And the cycle goes on until you get a perfect product, and then you release your product into the market. So that's what we call a regression cycle. And on the right side, you have a graph which represents what regression testing is. Basically, let's say you have version 1 of your any software product, and this is the feature 1 which you have enabled during the version 1. And that was released after 20 days of its development. And then you have version 2 or release 2. You have added new feature F2. It's working properly. So you go ahead and check if F2 has affected F1 in any way. That's what regression testing is all about. And your second release is released after 40 days. Similarly, it goes on. Next version, you add new feature. You check out if the other features or the previous features are dependent on it. If there are any errors because of the new feature. If no, then you release your product. So that's what regression testing is. So I hope after so much explanation, you guys are clear with what regression testing is, right? Yes, let's carry on then. Well, the basic aim behind conducting regression testing is to identify bugs that might have got developed due to changes introduced. Conducting this test benefits in a number of ways, such as regression testing increases our chances of detecting bugs caused by changes to any software or application. These changes can be anything. It could be just updates or patch fixes or defect fixes or anything. During unit and integration testing, regression testing can help catch defects early, and thus they reduce the cost to resolve them. So basically, it's cost effective. It also helps in researching unwanted side effects that might have been occurred due to new operating environment. It ensures better performance software. And why is that? Because using regression testing, we can identify bugs and errors in the early stage itself. Because of that, the performance of your product is literally high. It makes sure that the issues which are already fixed do not occur again. That's one of the best things about regression testing. Most importantly, regression testing verifies the code changes do not introduce any old effects, improve the quality of deployed software. This way, it ensures the correctness of the program, and as a result, the best version of your product is released to market. So to summarize, it reduces the amount that you have to pay on your testing by reducing the amount of bugs, and making sure that the old bugs don't return. It gives you the best product, or the quality of product is improved when regression testing is performed, and you can actually catch the bugs or any kind of issues in the early stages itself. So these are some benefits of regression testing. However, in real world, designing and maintaining a near infinite set of regression tests is not actually feasible. So it is important to determine when to perform regression testing and when not to. Regression tests are frequently executed throughout the software testing lifecycle at each different level. It can be unit testing level, integration testing level, system testing level, or acceptance, any level. However, it is recommended to perform regression testing on the occurrence of following events. Let's discuss what they are. First of all, when new functionalities are added, ideally you should perform regression testing after making any changes to the code. For example, a website has a login functionality which allows users to do login only with the email. Now you add a new feature like Facebook login. So you need to check the entire login functionality of the Facebook. Just like the simple e-commerce website payment option which we discussed earlier. We need to make sure that the new payment option, or in this case the new login feature, hasn't affected the old login functionality. Then you apply regression testing when there is change requirement, or usually you call it CR in the market. For example, whenever you log in, there's this option which pops out, right? Do you want the system to remember the password? I'm sure you've seen that. So, remember password should be removed from login page, which was available earlier. That's change requirement. It was available earlier, but you want to remove it. That's when you can apply regression testing to see if the removal of thing has affected the website that you're using in any way. And then you can apply regression testing when there is defect fix. That's straightforward. You already know that. Imagine login button is not working in login page, and a tester reports a bug stating that the login button is actually broken. So once the bug is fixed by the developers, tester tests it to make sure whether the login button is working as per expected results or not. Simultaneously, tester tests another functionalities which are related to login button, like registration or any other features which are directly related to login functionality. And then you can apply regression testing when there is performance issue fix. For example, when there's modification of code based on your needs and requirements. You've made some changes to the code, and since then the loading homepage takes 5 seconds. You want to reduce the load time to 2 seconds. And you have done it, but you want to see if this has affected the functionality of your website in any other way. You can also apply regression testing when there's an environment change. For example, when you've updated the database from MySQL to Oracle. All the features which are dependent on your database should be tested. And lastly, you can apply regression testing when there's a patch fix. Although meant to fix problems, poorly designed patches can sometimes introduce new problems, like they can break the functionality or disable a device. So in such cases, you need to perform regression testing to see if fixing a patch has actually been a profit for you or loss. So guys, these are some test cases, or you can say situations or scenarios where you can apply regression testing, and that would be beneficial for you. So guys, often regression testing is done through several phases of testing. It is for this very reason that there are several types of regression testing out there. Let's check out what they are. To begin with, we have unit testing. So immediately after coding changes are made for a single unit, a tester, usually the developer who is responsible for the code, reruns all the previously passed unit tests. So test-driven development, which we call it TDD, and in continuous development environments, automated unit tests are built into the code, making unit regression testing very efficient when compared to other types of testing. That's what unit testing is. Then you have progressive testing. So progressive testing works efficiently when there are changes done in software or application specifications, as well as new test cases are designed. That's when you use progression testing, and it will be more helpful for you as well. Then there is selective testing. In selective testing, testers use a subset of current test cases to cut down the cost and the effort. So in this strategy, a test unit must be rerun if and only if the program entities, example functionalities, variables, etc. it covers have been changed. So basically only things like functionalities, variables which are under the unit test are changed, only then you should perform testing on that unit test. The challenge is basically to identify the dependencies between the test case and the program entities it covers. So basically, as the name indicates, you do not perform tests on all units. You just select few out of those which might have affected due to change and then test those units. That's what you call selective testing. And then you have reset all testing. Reset all testing is very time taking because in this testing we reuse all the tests. This strategy is not much useful when you have small modifications or small kind of changes which are done to your code in the application. You can straight away point out, right? You have made a very small change and you are trying to retest everything because of that small change. It's literally costly and it takes a lot of effort and time on your part. During small modifications or changes to your code in your application, it's not effective. Retest all strategy involves testing of all aspects of a particular application as well as reusing all test cases even where the changes have not been made. So that's one of the most costliest type of testing when compared to others. Lastly, we have something called complete testing. Don't confuse it with retest all testing. Sometimes people often refer to both of them as the same thing, but anyway, complete regression testing is very useful when multiple changes have been made in the existing code. Performing this testing is highly valuable to identify unexpected bugs actually. So once the testing is completed, the final system can be made available to the user. So guys, it is important to make sure the type of regression testing that needs to be conducted. So you should choose the one which suits your requirement properly. And how you choose or which one you choose totally depends on other factors such as recurrent defects, criticality of the features, etc. But what remains on the priority is ensuring that the software delivers the best functionality and proves to be beneficial addition to your company or industry. So guys, now that we have established what regression testing means, let's go ahead and check out how regression testing is actually performed. So every time the software undergoes a change and a new version, update or release comes up, the developer carries out these steps as a part of regression testing process. The first thing it does is developer execute unit level regression tests to validate the code that they have modified along with any new tests that they have written to cover new or the changed functionality. Basically, whatever the changes they have made, they check if the changes are working properly or not. So that's the first step. We did learn what unit level regression tests are earlier, right? So any code changes made for a single unit, a tester or basically the developer who's responsible for the code reruns all the previously passed units as well. So that's what unit level regression is. Once that is done, the changed code is merged and integrated to create a new build of application under test. After that, smoke tests are performed. These smoke tests are executed for assurance that the build which you have created in the previous step is good before any additional testing is performed. These tests may be automated and can be executed automatically by continuous integration services such as Jenkins, Hudson's, and Bamboo. So once the build is perfect, Sanity testing confirms that new functionality works as expected and known defects are resolved before any other conducting or rigorous integration testing is actually performed. So why do you perform this integration testing? To verify that the interaction between the units of application with each other and with the backend services such as databases is working properly or not. For that, you perform integration testing. The next step is to schedule your regression tests. So depending on the size and the scope of the released code, either a partial or a full regression test may take place. Defects are reported back to the development team, and many require additional rounds of regression testing to confirm the resolution. So lastly, based on the reports that you've written, you analyze and figure out what test cases should be added for the next checking process as well, and you create a report on that. So that's how you perform a regression testing. So like you've seen, it's similar to any other testing. It's just that you check the functionality of your developed software whenever there is an update or some new release. So basically on introduction of new feature, you check out if the previous features are working or not. So remember guys, regression testing is not just performed in the beginning. So basically it's carried out throughout the testing process whenever a new feature is added. And we discussed when to perform regression testing earlier, right? So whenever one of such cases occur, we perform regression testing during the entire testing phase. So basically what you're doing here, you select the test for regression, choose a proper tool and automate the regression test, verify your application with checkpoints, manage regression test or update when required, you schedule the test, integrate the build and analyze the result. So that's as simple as that. If that was a little theoretical and if you've not understood, here is a pictorial representation of it. So first of all, whenever we make some changes to the code for any reasons, like adding new functionality, optimization, etc., our program, when executed, fails in the previously designed test suite for obvious reasons. So after the failure, the source code is debugged in order to identify the bugs in the program. After identification of bugs in the source code, appropriate modifications are made. Then the appropriate test cases are selected from the already existing test suite, which covers all the modified and affected parts of the source code. So we can add new test cases if required. In the end, regression testing is performed using the selected test cases. So selecting test cases is very important. Effective regression test can be done by selecting the following test cases. Test cases which have frequent defects, test cases which verify core functionality of the product that you're checking, the complex test cases, integration test cases. You have functionalities which are frequently used. So those are the first ones that you should check out. Then you have test cases which cover the module where the changes have been made. Those are obvious. Then test cases which frequently fail for no reason. Then you have boundary value test cases. So these are certain test cases where you can apply regression testing, or you can actually select these test cases for regression testing. So when you're trying to shortlist the test cases for regression testing, these are some points that you should consider. So regression testing simply confirms that modified software hasn't unintentionally changed, and it's typically performed using any combination of following techniques. So basically what I'm trying to say here is that there are 3 techniques that you can apply for regression testing. So the first type we have is retest all. This method of regression testing simply retests the entire software suite from top to bottom. In many cases, the majority of these tests are performed by automated tools. And certain times, automation is not necessary at all. Moreover, purely using automation ignores the benefits of human testers and any change for exploratory testing. So this retest all type of technique is an expensive method as it requires more time and resources when compared to other techniques. Well, it's all there in the name itself, right? Retesting. The next is selective test cases. Again, from the name itself, you can guess what that is. Rather than a full retest process, this method allows the team to choose a representative selection of tests that will approximate a full testing of test suite. The primary advantages to this practice is that it requires far less time and effort when compared to retest all method. So these kind of regression testing is usually performed by human testers such as quality analyst team or development teams, who will typically have better insights into the working of test cases and their unexpected behaviors. And lastly, we have test case prioritization. This is one of the popular techniques. The goal here is to prioritize a limited set of test cases such that more potentially impactful tests are executed ahead of all less critical ones. So try to prioritize test cases which should impact both current and future builds of your software. That way you're not wasting your time, money, and effort. Apart from these 3, we have another one called hybrid. Hybrid technique is literally a combination of regression test selection and test case prioritization. So rather than selecting the entire test suite, select only test cases which are executed or re-executed depending on their priority. So what are the different techniques? We have retesting, where you perform testing on the entire test cases that there are. Then you have selective test cases. Based on certain criteria, you select the few test cases. Then you have prioritization. You select the more impactful test cases compared to less critical ones. And lastly, the hybrid, which is combination of selective and prioritization. So these are various ways of implementing regression testing, guys. Now that we know what regression testing is, its types and its techniques, let's go ahead and do a demo on how to create a regression testing plan. For that, I'll be using an Excel sheet. So guys, here we are. In this demo, our main goal is to actually learn how to create a regression testing plan. It's a very simple example. So with this example, I'm sure you'll be able to get started on how to perform regression testing. So first thing, there are certain terms that you should know about. As for this regression testing plan, we'll be using an e-commerce website to test on, or to create a plan actually. So let's take Myntra. Here we go. Okay, what do I want to see? So we go, I'm choosing wall lamps and lights, anything, just a basic example to check on. Let's perform or create a regression testing plan for the sort option here. You can see, right? The sort here, when you click on that, you have different options like sort the elements based on what's new, popularity, better discount, price high to low, price low to high, and faster delivery. So we'll be creating a regression testing plan on that. Let's go back to our Excel sheet. Like I said earlier, there are certain words or terms that you should be aware of. The first thing, let me just write the headings first. Let me increase the size. Then we have what they mean. And then comes our example. Okay, Let me increase the size of this one as well. Okay, first terminology is test objective. So what does a test objective mean? It's basically what you're trying to do. Here in this, you're trying to test a functionality of your feature. That's what your objective. The goal or the objective of creating this plan. That's what we call test objective. So you can say what you are planning to do. So what would be the example here? We're trying to check the functionality of a feature here. Trying to check the functionality. The next term is test object. So what do you mean by test object? It's basically the component which you're performing test on. So component to be tested. So what's the component that we're trying to test here? The sort component. So that's our test object. So I'm going to say sort feature. So we are done with test object and test objective. We have something called test item next. So what's in test item? Test item is the subset of your test object or the item that you're performing test on. So this is the object that we are performing test on, which is sort. Like I said, under sort we have multiple options. So these are nothing but test items here. So let's perform a test on this price high to low. So let me write it as subset of test object. So what are the item that we are checking here on? Price from high to low. The next thing is test condition. So under test items, like I said, it's a subset, right? You can have any number of items or subsets for an object. For example, like we said here, we have what's new, popularity, and also let's say if I want to select two options or two objects or items that I want to check here, which is price high to low and price low to high, I can add both of them here, high to low, comma, low to high. So the test condition is the one thing which you're testing of these items. So let's say we want to check the sorting feature by price high to low. So you get the point, right? Basically the condition on which you're performing testing. And then you have test case. Test case are just parameters that you can relate to when you're actually performing testings. For example, you have test data that you're checking on, then you have preconditions if you do have any, or you can say assumptions, and then you have expected results, actual results of testing and all that. So guys, if you want to know more about test cases, there's a separate video by Edureka on test case. It's in the software testing YouTube playlist. Go ahead and refer to that. So yeah, I don't have to give you an example, right? So I'm just leaving it blank. And lastly, you have test suite. Test suite is nothing but a combination or collection of test results that come under test suite. So I can write it as set of test cases. So these are certain terms which you should be aware of when performing a testing or writing a test case or when you're creating a regression testing plan or anything. So the first thing is test objective, is your goal or thing what you want to do. For example, here we are trying to check the functionality of a feature. Then you have something called object or the feature on which you're performing test on, sort feature. Under sort object, you have multiple options. Those come under your test item. And the test condition is based on what condition you're trying to check your test object under which a test item comes. So basically, we're trying to test out the sort feature based on price and high to low. So in test condition, you have three things. You have your test objects, which is sorting, by the item, which is price, and an item which is high to low. And then you have test cases. These are like certain parameters which are associated when you're performing a test, like test data, preconditions if you have any, expected results, actual results, or any other comments, status, and all that comes under your test cases. And lastly, you have something called set of test suite, which is set of test cases which come under the same category, you can say. So what are we trying to test here? Testing project name. Let's give it a name, which is Myntra release 1, let's say. So for this first release 1, let's write something called traceability matrix. This traceability matrix basically helps you keep track of how you're performing testing on and what are the results. So here we have traceability matrix. Let's say for release 1, LEAC release 1. Traceability matrix. The first one is feature, or you can just call it test item. Then you have requirement ID. then the test suite, and then comes the test cases. So we go, let's write the first element here. So that would be, this is the website that we're testing for, and what are we testing? The sort feature, that's the object, and the item is price. Price, and what is that we're testing for? Let's take high to low first. Then requirement ID, some number you can give. So we're testing sort feature, so let me give SF and 077. Test suite 20. Then the test case ID, that would be Myntra sort price, which comes under the requirement SF077, and the test case ID would be test C01. Let me give this capitals, test case 01. So yeah, just like that, I can create multiple test cases, 2, 3. So here we go. We're done with the first traceability matrix, the first element. Similarly, you can write one more for low to high as well. I'm not going to write it. It's the same. So this is how we write a traceability matrix for the release one. So let's say you have performed testing by considering the filter option, which is high to low, and the testing worked properly without any errors. And these are the test cases which you have checked for high to low, and everything is working properly. And for now, it's good. Now we'll move on and perform testing for another feature. Let's say another item actually. We did perform for high to low. Now let's go for better discount. You can see the better discount option here, right? So I'm going to perform test for that, or write a test plan for that. So it's the same thing again. So testing release. This is example as well. It's the same. So I'm trying to still check the functionality of the feature. So my objective is same. And what is the feature that I'm trying to check on? Sort feature, it again, it's the same. And what is the thing I'm trying to check on? It's not price now, it's discount, better discount. And you do not have any multiple options here, so it's just better discount. So there we go. Again, we have test cases, multiple test cases under that, and multiple test suites under that. So let's write a traceability matrix for that as well. SF076 and test suite 32. That would be sort, discount, and the test requirement ID, which is SF076 in this case. And then comes the test case ID 01. Just like that. But here I have 4 test cases. So that's how you write your traceability matrix. Till now, we're still dealing with the normal testing process. Let's move on to regression testing now. What happens is, when I tried to test on this feature, it's working properly. Then when I tried discount option, it's working properly. But after I added this discount option, when I tried to check for price again, I want the sorting being done from high to low, but based on discounts. Then this option, which is high to low, is not working properly. So again here, I have a testing release, which is still due. I'm just gonna drag it from here. Let me increase the size of this. I'm still in 2. It's just that after introducing the new feature or the new functionality, the previous functionality stopped working or I've got an error. So it's still example. For what is regression testing? What are we trying to do here? Trying to check the functionality, but we're performing regression testing. So that's our objective. So what's the feature? That's sort again. We're still checking out the sort feature. What is the thing that's not working? Price. High to low and low to high. So I'm sure you're understanding, right? This is my only feature which was there in the sort. Consider I tested it, it's working properly. This also is working properly, the second one, which is based on discount. But I'm trying to combine this and see how the high to low is working based on the discount. The high to low thing is not working. That's when I want to perform regression testing and check out what are the test cases which are not working and what are the bugs. So that's how I perform. For that, I'll be writing another traceability matrix. This would be for the release 2. This is again for the release 2 itself, but for the regression testing. Here we go. The first thing that happened was the defect that we found. So the first option would be, or the parameter would be defect ID. And let's say the defect was some number 245E. So what was the test case on which the defect occurred? That was Myntra sort discount. So we're performing the test suite. Give it a number, let's say test suite 34. So the requirement ID next. Myntra sort. When we try to combine the price and discount, we got that error. So that's it. Myntra sort price discount and the requirement ID, something we should give, right? Let's say SF098. So then comes the test item or the feature. Now you might be a little confused because the format which I've used in the first and the one which I've used now is totally different and it seems a little weird. Let me go through it again. So here you have something called regression test cases and regression test suite. So basically guys, these matrix, we call it a bidirectional traceability matrix. So the first one, let me just go through it again. The first one, we have your item on which we're sorting, the requirement ID, the test suite which the test case belong to, and these are the test cases which come under this test suite. Now what we did is we performed testing for both the features, and when we tried to check if combining these features or the functionality of high to low is working after the discount feature is added, it's not working. We are getting an error or a defect, and that defect as a ID, that defect ID we're representing here. So, but when did we get that here? So what is the test case that we did test for here? When we tried to sort first based on the price and then apply the discount, the thing is not working. So that's the test case ID. And which test case does this test case ID belong to? This particular test suite. And what is the requirement of this particular test case? Sort based on price and then on discount. And this is the requirement ID. So what is the item or basically the feature or the object that we're checking here on sort? So from the defect, we're tracing back and coming back to a feature which we're testing on. You got my point, right? Here we started with our feature or item and then we traced back to test case. But here we started with the defect and then we came back to a feature. So defect, which is the test case ID that we're checking on, the suite which test case belongs to and what is the requirement of the test case, and then the item on which it's being tested. So this is bidirectional traceability matrix. Well, this is just a small part of, you can say, millionth small part of what you can perform in testing. The very simple example like that, you can perform multiple traceability matrices, multiple releases, and in one release, only multiple tests. So basically what I'm trying to say here is that this point, this item is dependent on other features. Like the discount option is dependent on high to low and low to high. So whenever you're trying to make any changes to discount option, your high to low or low to high options are not working, or either they're working or not working. From that you can tell these two things or the two items are related to each other or dependent on each other. For that you have, or you can add another parameter called dependent features. So what are the features which are dependent on our discount? It's price, high to low. Similarly, Myntra sort price. And what are the test cases which are dependent on this defect ID or the test case? That also you can represent here. Maybe this test case is not dependent on it and this test case is dependent. So what you can do is, I'm going to copy it and paste it here. So this is the one test case which is dependent on the discount thing. So that's how you write a traceability matrix. I hope the thing is clear for you guys. So we just started with the basic testing as in one feature. Everything worked well. We have certain test cases under test suite and proper. Then you have another feature which is better discount. Based on that you perform test. It's working well. Now you try to arrange everything from high to low and then apply discount. Then you're getting a defect. Based on that defect, we created a traceability matrix. We traced it back to our feature which is sort. And the sort feature is our other features are dependent or interrelated to each other. So that's how they're affecting each other. So for that, we need to perform testing from the beginning again, check out what are the errors and find out the defects and fix them. So that's what regression testing is all about, guys. So any changes that are added or made, it could be adding new feature, updating the existing feature. You should check if it's affecting the already existing functionality of your application or software. That's what regression testing is all about. So that's all with the demo. Let's move on to the next part. So regression testing is easy to define and understand, but baffling when it comes to performing regression testing of a software product. One reason is the dynamic nature of software product. It keeps changing. You need to understand the challenges well before you can craft a counter strategy for these challenges. So let's have a look at common challenges of regression testing. So the first thing, Regression testing is often considered as a drain of resources and manpower to test again and again something which has already been developed, tested, and deployed at early stages. So when testers are told to perform regression testing, they're tempted to perform exhaustive testing of the software product. Quality assurance manager needs to make sure, or he needs to devise an intelligent methodology for regression testing to assure that every required test case has been executed within the limited span of time and the amount of money that he is assigned with. So basically, the first challenge that you'll encounter is it's time consuming and expensive. So as a QA analyst or manager, you need to devise an intelligent methodology for regression testing. Next is it's complex and challenging. As new features and changes are implemented in software product, more test cases are added to regression test suite. As the product functionalities expand, testers are overwhelmed by the regression test cases and they fall victim to lose track of test cases. And when they lose track of the test cases, they overlook the important test cases as well, right? So regression testing is a complex process. This can be prevented by regularly monitoring the regression test suite and deleting the obsolete test cases. It is also important to avoid any duplication of test cases else they'll add to unnecessary effort and frustration for testers. Lastly, it's the communicating business value in regression testing is usually tough. Regression testing, as you know, ensures existing product features are still in working order. Communicating the value of regression testing to non-technical leaders of your company within your business can be a difficult task. Executors most of the time want to see the product move forward, making a considerable investment in regression testing to ensure existing functionality is working can be a hard task. So these are certain challenges that you'll come across when you're performing regression testing. So regardless of the method of implementation that we discussed earlier, that is retest all, select, and prioritization, there are a handful of general best practices that you can follow while implementing regression testing. That way you can overcome the challenges which we discussed earlier. So the first thing is you need to maintain a schedule. Choose a schedule of testing you can maintain throughout the software development lifecycle. So testing is never placed on back burner. Secondly, use a test management tool. In order to properly keep track of all the tests that are being performed on a regular basis and have the records of their performance over time, it's better to use a simple kind of test management tool that does all the tasks for you instead of you spending long amount of time and efforts on keeping track of all these test cases. You can break down and categorize your tests. Tests are often considered to be easy to understand and evaluate if they are broken down into smaller pieces. It's not just with testing anyway, right? If the thing is huge and complex, it's difficult to understand. But if it's broken down into pieces and then you try to understand, it's easy. So try to refactor your test cases as often as necessary. Then categorize them such that the categories of smaller tests can be prioritized over the others. So this makes sorting and execution much easier in future for you. You can also consider customer risk. Not also, you must and should consider customer risk. Basically, the product is made for customer, right? So when developing and prioritizing regression tests, keep track about considering the effects the test cases will have on the customer or the business as a whole. So try to design such test cases that they cover as many test cases as possible. And lastly, evaluate test prioritization. So when using any form of prioritization to order your regression test, try to find a sensible way to order them. Such way, you know what you're actually doing. Don't mess it up. So well, these are certain things that you can follow to achieve better regression testing results. So failure to perform effective regression testing can cause a lot of needless suffering. It might happen that everything required in the new sprint is working fine, but the previously implemented features and functionalities got messed up. If this happens, the client would not appreciate you for the new functionality. He would become angry, irritated, and can be real trouble to handle. So guys, regression testing is really important. Testing is broadly classified as manual testing and automated testing. So manual testing, it's pretty self-explanatory, right? Testing of a web application is done manually by human action. That's what we call manual testing. This means that someone actually goes on a device to evaluate numerous components including design, functionality, and performance of software. So they click through multiple elements or units of web application without any support from tool or script. Thorough testing is crucial to the success of a software product. If your software doesn't work properly, chances are strong that most people won't buy it or even use it, at least not for long, even if they buy it. But testing to find defects or some sort of bugs is very time consuming, expensive, often repetitive, and subjective to human error if you are using manual testing. So this is where automation testing comes into picture. automation testing? Well, it's automated. The buzzword automation focuses on replacing manual human activity with systems or devices that enhance efficiency of software. Test automation, or usually referred as automation testing, uses different kind of tools, scripts, and software to perform test cases by repeating predefined actions. So by automating your software testing activities, you will definitely get a competitive edge in the market. So let me give you some examples. Amazon is testing delivery drones that pick up warehouse orders sorted by robots. Google is testing self-driving cars. Starbucks is testing cashier-free stores dedicated to mobile ordering and payment. Facebook is testing a brain-computer interface that may one day translate thoughts into digital text. Fascinating, right? There are mundane versions of automation technology behind all this testing. Software automation testing. Companies use automation technology to create the software responsible for the products and services, causing all this hype about automation testing. When you actually begin testing, one of the primary decisions that you'll have to make is if to choose manual testing or automated testing. While neither of these options are technically better or worse when compared to each other, factors like size, budget, time allowance of the project will certainly be factors that affect which method will work best in the situation. So you should be aware of distinct differences between manual testing and automated testing. So here we go. The first difference, obviously the definition, which we discussed earlier. In manual testing, test cases are executed by human tester and software, whereas automation testing uses different kind of automation tools and scripts to execute test cases. So let's get started with other factors. The first is reliability. For a testing phase where duration is very long, there are high chances of an undetected error when testing is performed manually. Every time a small defect is fixed, the entire application needs to be tested to ensure that any other breakage is not occurring. Well, the process is tiring and boring, so testers often miss out critical defects while performing repeated testing. It's a common human behavior, right? Therefore, the accuracy and reliability of manual testing is very low. Automated testing, on the other hand, is more reliable. Tools or the scripts that you use form the automated test. If the script is properly written, there is no chance of missing a defect when the test is executed over and over again. And obviously, it's not boring as well for the machine, right? When it comes to reliability, automated testing is highly reliable. Then comes the time required to perform the testing. Manual testing is obviously time consuming, it takes up human resources. But when it comes to automated testing, it's executed by software tools and different kind of scripts. So it is significantly faster when compared to manual testing. Next, we have when to use which kind of testing. Manual testing is suitable when the test cases are run once or twice. Therefore, there's no frequent repetition of test cases in manual testing. So to name, manual testing is suitable for exploratory or usability and ad hoc testing. Automated testing is suitable when the test cases need to be run repeatedly for a long duration of time. Automation testing is suited for regression testing, performance testing, load testing, or highly repeatable functional test cases. And next we have performance and batch testing, which is not possible in manual testing. You can batch multiple test scripts in automated testing. Performance tests like load testing, stress testing, spike testing, etc. have to be tested by an automation tool compulsorily in software testing process. Then we have investment costs. The cost of manual testing is usually dependent upon the human resources deployed in the testing during the initial stages of testing. The initial investment in manual testing is comparatively lower, but the return of investment is very low when compared to automation testing. When I say return of investment, I mean the money that you earn as a revenue at the end of the software testing or after selling the product is actually low when compared to automation testing. In long run, that is. But the cost of automated testing is dependent upon testing tools deployed for performing the tests. But the initial investment in automation testing is usually higher, though the return of investment is better in long run. So when it comes to investment cost, initial investment, manual testing is much preferable. But if you want to perform testing for longer run, then automation testing is much preferable. As the last criteria, we have human element. Manual testing allows human observation, right? So you're getting exact kind of feedback a person would give you, and that can be invaluable. Being able to predict what your users will or won't like things that a computer can't give feedback on ahead of time can influence your design and make it much better from the bottom up. It improves the customer's experience. But when it comes to automated testing, as there is no human observation involved, there is no guarantee of positive customer experience. So when it comes to human element, manual testing is much better because you get to have a nice experience since the humans are the ones who are checking the software. So guys, these are some differences that you should be aware of between manual testing and automation testing. So to summarize what we've learned till now, automation testing has a lot of advantages over manual testing. First of all, it saves a lot of time and money. It improves test accuracy. It increases the test coverage, as in you can perform tests repetitively on different kind of devices. Complex tests and boring tasks are made very easy and comfortable. It increases efficiency and team morale. You no longer have to do the boring and repetitive tasks. There'll be no human errors, obviously. It reduces maintenance cost of testing. It increases speed of executing tests and many more advantages. So in short, while manual testing is effective in projects with multiple operating environments and hardware configurations, automation testing is absolutely essential today to successfully deliver large-scale products that need execution of repetitive and complex test cases. But it's impossible to automate all testing. So it is important to determine what test cases should be automated first. So guys, let's go ahead and take a look at use cases where automation testing have to be applied. Because like I said, you can't apply automation everywhere. First of all, as you guys know, repetitive tasks are primary candidates for automation. Take an e-commerce site for an example. It may be testing entering in user credentials multiple times. Consider the tasks that you hate doing. Not only are these tasks boring to you, but they're often the ones where mistakes are made very commonly. So automate them and do something more fun. Next, capturing and sharing results is obviously a critical part of a successful test strategy. Rather than manually exporting your data, crunching the numbers, and making petty graphs, invest in a tool or automation strategy that will do this for you. Thereby, you can save time and a lot of effort on your part. And obviously, tests that require multiple data sets. Rather than manually typing in information into forms or fields, automate this process to read in information from a data source and automatically type into the respective forms. This way, you will have better handle on your data variability, and it also decreases the chances of making mistakes repetitively again. And suppose if you're waiting for an on-screen response, it can be automated, so you do not have to waste time staring at a screen and watching for a response, right? You have other better things to do. Put that time to better use and use automated controls like wait until in your program code. Then you have non-functional testing. A good example of automating non-functional testing types is automating load testing. Think about having to see if your application can handle a load of 10,000 users. Automate this testing so you do not have to worry about manually spinning up 10,000 users hitting your application all at once. Tests that run on several different hardware or software platforms and configurations. So as the number of device users interact with increases, automating your setup or tearing down your setup environment will continue to be critical. Additionally, these are scripts that you will use over and over again in multiple testing frameworks, right? It's better to automate than to do them manually. So basically, the cases where you have to automate is when you have repetitive and boring tasks, or if you have to capture some results and share the results, or if you have to repetitively enter the data tasks, as in data entry tasks, or some sort of timing or screening responsiveness, and especially in load testing. And suppose if you want to set up or tear down your environment setup, then you can use automation. So guys, it's always better to know when to use or when to apply automation in software testing. So guys, success in test automation process requires careful planning and design work. Start out by creating an automative plan. This allows you to identify the initial set of tests which to automate and serve as a guide for future tests as well. There are a lot of helpful tools to write automation scripts. Before using those tools, it's better to identify the process which can be used to automate the testing or the procedure that you have to follow to start automation. So as next part of the session, we'll discuss the steps that you need to follow when you're performing automation testing. So like I said earlier, success in test automation requires careful planning and design work. So start out by creating an automation plan. First of all, you should define your goal for automated testing and determine which type of test to automate. Once you're sure of what kind of test are you performing, you need to select the tool. So the first step here is test tool selection. There are several kinds of testing tools available. However, choosing the right tool, keeping in mind the nature of test involved, is very important for your automation to be successful. So whether it's a code-driven testing process or graphical user interface-based testing, you must select the appropriate tool to automate the testing. So the first step is selecting the proper tool required for automation of your application or testing. Next comes defining scope of automation. As in, you need to select which test cases to automate. Here you can follow certain pointers like the features that are important for business, scenarios which have large amount of data, or those which has common functionalities across different platforms and applications, technical feasibility, the extent to which business components are reused, the complexity of test cases, etc. So by keeping these pointers in mind, you can define the scope of automation. And the third step is planning, design, and development. After determining your goal and which type of test to automate, you should decide what actions your automated test will perform. Planning, design, and development. Develop test cases. Don't just create test steps that test various aspects of application's behavior at one time. It becomes overwhelming. Large, complex automated tests are difficult to edit and debug as well. So it'll be a problem for you later on. So it is best to divide your tests into several logical smaller tests. So once you've developed your test cases or you have written your test scripts, next step is to develop test suites. Test suites are developed to ensure that the automated tests which you have written run one after the other without any manual intervention. This is done by creating a test suite that has multiple test cases, a library, and a command line tool that runs the best suite. So guys, the next step is test execution. Once you're done with writing your scripts and placing them in suitable test suites, the next step is to start executing them. Automation scripts are executed during this test execution phase. So execution can be performed using automation tool directly or through the test management tool, which will invoke the automation tool which you have chosen. To get the most out of your automated testing, testing should be started as early as possible and as often as needed as well. The earlier testers get involved in the life cycle of the project, the better. And more you test, the more bugs you can find, right? So yeah, your scripts are executed in this phase. Once executed, the next step obviously is to create report formats so that individual test logs with details of action performed during test are recorded properly for references. So you define the type of test report format to be created, screenshots, messages, etc. So all such things you include in your report. As new functionalities are added to system under test with successive cycles, automation scripts need to be added, reviewed, and maintained for each release cycle, right? So maintenance becomes necessary to improve the effectiveness of automation scripts. So what I mean here is that you do not entirely finish a product and start testing. Suppose if you have found some bug, you add additional features and again start your testing from the beginning. So maintenance plays a very important role and it becomes necessary step to improve the effectiveness of your automation scripts. So you need to follow these steps when performing automation testing to get the best results and efficient results. Next comes the automation tools. There are several innovative automation testing tools, but before we discuss that, we need to understand there are different kind of approaches to automation. The first one is we have code-driven approach. This approach uses testing frameworks like JUnit framework, etc. The focus here is mainly on test case execution to find out if various sections of code are performing as per our expectations under different conditions or not. So code-driven testing approach is a popular method used in agile software development. Then we have graphical user interface. Applications that have GUIs or graphical user interface may be tested using this approach. It allows the testers to record user actions and analyze them any number of times. So this is one way of going at automation. For example, if you want to test a website, you can use automated testing tools like Selenium that provides a record and playback tool for authoring tests without any knowledge on test scripting language. So you do not basically have to know the scripting language here. You do have record and playback tool using which you can start executing your test. Test cases can be written in any number of programming languages like C#, you have Java, Perl, Python, Ruby, and many other options. So the next approach is using automation framework. So basically, a test automation framework is a set of guidelines which are used to produce beneficial results of automation testing activity. This framework brings together function libraries, test data sources, object details, and other reusable modules. It lays down the general rules of automation and it simplifies the effort required to bring the efficient results and lower your maintenance cost as well. So basically, you can say you're setting down a set of rules that you need to follow while performing your automation testing. Let's consider an example. Suppose if there is any change in a test case, then only that particular test case file needs to be updated without having to make any change to the driver or the startup script. So now you have multiple approaches when it comes to frameworks. Frameworks could be linear scripting framework, recording and replaying test scripts in sequential or you can say a linear fashion. You have data-driven framework. A constant source of test criteria specifies the test scripts which you have to run here. Then you have keyword-driven framework. Here, the tables on a spreadsheet actually specify the action of a test scripts that need to be performed based on the library of functions for an assigned keyword. Then you have modular testing framework. Modules of an application under test are divided and then tested with individual test scripts, and then they can be combined for larger test scripts. Then you have hybrid testing framework. Obviously, it's a combination of frameworks to leverage the strengths of each of the ones which we discussed earlier. When you've decided to perform automation testing, you can opt for any of these approaches. You can go for code-driven testing. You can also go for graphical user interface if you're testing graphical user interface. Then you can go for a framework approach, and you have multiple framework options here as well, like linear, which performs testing in a linear fashion. Then you have data-driven, keyword-driven, modular testing, and hybrid testing, which is a combination of all the other framework types. So yeah, guys, basically there are ways you can implement automation while software testing. So now moving on to test automation tools. Selecting an automated testing tool is essential for test automation. Well, there are a lot of automated testing tools in market, and it is important to choose the automated testing tool that best suits your requirement. So basically, when you're trying to test or select an automation tool, please do follow the key points which I'll mention now. First of all, check if the tool is compatible with platforms and the different kind of technology that you're using. Ask yourself, do you need support for mobile automation testing or different other kinds of testing? Are you testing .NET, C#, or other applications? If yes, and then on what operating systems? So next, flexibility of the testers also plays a very important role. That is, what kind of skills your tester have also plays a very important role. For example, can your QA department write automated test scripts, or is there a need for keyword testing? Thirdly, does the automated testing tool support record and playback test creation as well as manual creation of automated tests? So basically, you need to consider these sort of questions or situations before you go ahead and select a tool. You can also look if the tool includes features for implementing checkpoints to verify values, databases, or key functionality of your application. You need to create automated tests that are reusable, maintainable, resistant to changes in the application UI, right? So ask yourself, will my automated test break if my UI changes? So based on that, choose a tool. Make sure that the application is stable enough. To automate the early development cycle, unless or otherwise it is an agile environment, it not be a good idea. And finally, the cost and the effort that you need to put in is also a very valuable concept that you should consider when you're choosing an automation tool for your testing. Well, these are certain categories or scenarios or key points that you should take care of when you're actually choosing an automation tool. Now, to name few popular automation testing tools, we have Selenium. Selenium is a popular testing framework to perform web application testing across multiple browsers and platforms like Windows, Mac, Linux. Then we have Water. WATIR, basically, it's pronounced as Water, is an open source testing tool made up of Ruby libraries to automate web application testing. Then you have something called Ranorex. It is a flexible all-in-one GUI testing tool. So using Ranorex, you can execute automated tests flawlessly throughout all environments and browsers and devices. Then you have APM, it's a mobile testing tool. It is an open source mobile test automation software. Obviously, it's free and supported by a high active community of developers and experts. So apart from this, you also have Zypher, Tosca for end-to-end testing, then HPE or Unified Functional Testing, which was formerly known as HP Quick Test Professional or QTP. And I can just keep going. There are plenty of automation testing tools. So tool selection is one of the biggest challenges that need to be tackled before you actually start with your automation. So first, identify the requirements. Explore various tools, get to know them and their capabilities, set the expectations from the tool, and go for a proof of concept. So that's how you choose a tool of your choice. So guys, in some situations, automation testing is very important. But as much it is comfortable, that much it is risky too. So if you decide to do automation testing, then think of following scenarios first. Starting cost for an automation is very high. Automation tool purchasing cost, training and maintenance of test script, all these costs are very high. Because of this reason, some companies are worried to take decision to automate their work. Secondly, automation is not 100%. Automation testing cannot be 100%, and don't think of that. There are areas like user interface, documentation, installation, compatibility, and recovery where testing should be done manually. You can't do all this using tools. You need to have a person involved in this. And another risk that you might encounter is when you have unrealistic expectations from the automation testing tool. So like I said earlier, know the requirement, study different kind of tools, get to know their capabilities and choose the tool. And then comes the incompatibility of automation testing tools with the test environment and other software testing tools in test environment. Then you have vendor issues like inability to provide technical support, inability to update the automation testing tools with changes in software testing platform and all that. And one more point, do not automate unfixed user interface. Be careful before automating user interface. If user interface is changing always, cost associated with script maintenance will be very high. So basic user interface automation is enough in such cases. By mentioning all these points, what I wanted to tell you is automation is not possible every time. And these are some cases where you might have to start looking twice before you actually implement automation here. So guys, there's no silver bullet for testing during the development process. Despite the wide variety of techniques and tools, we cannot rely on a single approach. Automated and manual testing each have their strengths and weaknesses. What we want to stress here is that no matter how great automated tests are, you cannot automate everything. Manual tests play an important role in software development as well, and they come handy when you cannot automate the process. So guys, we have reached the end of the session. And by now, I'm sure you know what automation testing is and benefits of using automation testing, when to use it, and which test cases need to be automated, and how different it is from manual testing. So make sure to consider all these points when you go ahead with automation next time.
Now, performance testing is basically defined as a type of software testing to ensure software applications will perform well under their expected workload. Now, features and functionalities supported by a software system is not the only concern. A software application's performance, like its response time, reliability, resource usage, and scalability, do matter. Now, the goal of performance testing is not to find bugs, but to eliminate performance bottlenecks. Now, performance testing is done to provide stakeholders with information about the application regarding speed, stability, and scalability. Now, more importantly, performance testing uncovers what needs to be improved before the product goes to the market. Without performance testing, software is likely to suffer from issues such as running slow while several users use it simultaneously. Now, the main focus of performance testing is checking a software program's speed. So basically, it determines whether the application responds quickly. Then the scalability. It determines maximum user load the software application can handle. Then we have the stability. Now this determines if the application is stable under varying loads. So performance testing will basically determine whether their software meets speed, scalability, and stability requirements under expected workloads. Applications sent to market with poor performance metrics due to non-existence or poor performance testing are likely to gain a bad reputation and fail to meet expected sales goals. Now let's move on and have a look at the different advantages of performance testing. So the first one is validate the fundamental features of the software. Now, having a solid software foundation is a key principle of generating software success. Measuring performance of basic software functions allows business leaders to make key decisions around the setup of the software. Now, Apple and Samsung are two great examples of nailing the fundamentals of their software. With a strong software foundation, they have been able to plan their business strategy and make key decisions about how their devices will operate. Next up, we have measure the speed, accuracy, and stability of software. Now, measuring performance, speed, accuracy, and stability is a vital aspect of software performance testing. It allows you to monitor the crucial components of your software under duress and can give you vital information on how the software will be able to handle scalability. Next, performance testing allows you to keep your users happy. Now, your first impression to prospective customers is absolutely crucial. Research has shown that nearly half of users expect web and mobile-based applications to load within 2 seconds. Now, this is a small time frame to make a good impression before users will switch off. That time is likely to decrease further as connection speed and network capacity increases. Now, measuring application performance allows you to observe how your customers are responding to your software. The advantage is that you can pinpoint critical issues before your customers. The next advantage is it identifies discrepancies and resolves issues. So, measuring performance provides a buffer for developers before release. Any issues are likely to be magnified once they are released. Now, performance testing allows any issues to be ironed out. It is important that performance testing is monitored across business sectors. Now, business leaders must have open communication channels with IT to ensure that the performance of the software can match the business strategy. Now, the final advantage is improved optimization and load capability. Now, another benefit of performance testing is the ability to improve optimization and load capacity. Measuring performance can help your organization deal with volume so your software can cope when you hit high levels of users. So, whether your organization can manage scalability is one of the most important unknowns that must be answered as early as possible. Now, the benefits of performance testing your software are far reaching for your organization. Measuring performance can help you understand the speed, stability, and accuracy of your software. Now, let's have a look at the different types of performance testing. So, first we have the load testing. Now, this testing checks the application's ability to perform under anticipated user loads. The objective is to identify performance bottlenecks before the software application goes live. Then we have the endurance testing. Now, this is done to make sure that the software can handle the expected load over a long period of time. Next up is the volume testing. Now, under volume testing, large number of data is populated in a database and the overall software system's behavior is monitored. The objective is to check software applications' performance under varying database volumes. Next is the scalability testing. Now, the objective of scalability testing is to determine the software application's effectiveness in scaling up to support an increase in user load. So, it basically helps plan capacity addition to your software system. Then we have the spike testing. Now, this tests the software's reaction to sudden large spikes in the load generated by users. And finally, we have the stress testing. Now, this involves testing an application under extreme workloads to see how it handles high traffic or data processing. The objective is to identify the breaking point of an application. Now, there are various performance testing tools available in the market. Some of the topmost performance testing tools include the Apache JMeter, LoadView, LoadRunner, WebLoad, NeoLoad, the Grinder, LoadNinja, BlazeMeter, LoadComplete, and a lot more. Now, there is no best tool in the market. You need to find the best tool for your performance project goals. So don't slog to choose the right tool. Get smart and consider factors like your desired protocol support, license cost, customer or client preference of load tool, cost involved, hardware or software requirements, and tool vendor support in order to decide on your performance testing tool. So let's have a look at the top 10 performance testing tools. First, we have LoadNinja. Now, LoadNinja by SmartBear allows you to quickly create scriptless, sophisticated load tests, reduce testing time by 50%, replace load emulators with real browsers, and get actionable browser-based metrics all at ninja speed. Now, you can easily capture client-side interactions, debug in real time, and identify performance problems immediately. LoadNinja empowers teams to increase their test coverage without sacrificing quality by removing the tedious efforts of dynamic correlation, script translation, and script scrubbing with LoadNinja engineers, testers, and product teams that can focus more on building apps that scale and less on building load testing scripts. Now, some of the features of LoadNinja are scriptless load test creation and playback with InstaPlay Recorder, real browser load test execution at scale, VU Debugger debug tests in real time, and the VU Inspector manage virtual user activity in real time. It's hosted on the cloud, so no server machine and upkeep is required. There's sophisticated browser-based metrics with analytics and reporting features. Also, some of the protocols include the HTTP, HTTPS, the SAP GUI Web, WebSocket, Java-based protocol, the Google Web Toolkit, and the Oracle Forms. Now next up we have the Apache JMeter. Now JMeter is an open source tool that can be used for performance and load testing for analyzing and measuring the performance of a variety of services. Now this tool is mainly used for web and web service applications. So let's have a look at some of the features of Apache JMeter. Now this tool doesn't demand state-of-the-art infrastructure for load testing and supports multiple load injectors managed by a single controller. It's highly portable and supports 100% all the Java-based apps. There's less scripting efforts as compared to other tools because of its user-friendly GUI. Here, simple charts and graphs are sufficient for analyzing key load-related statistics and resource usage monitors. It also supports integrated real-time Tomcat collectors for monitoring. Some of the protocols include the HTTP, HTTPS, web services such as XML, SOAP, etc., Java-based protocols, FTP. On third, we have the WebLoad. Now, WebLoad is an enterprise-scale load testing tool which features a comprehensive IDE, load generation console, and a sophisticated analytics dashboard. The WebLoad has built-in flexibility, allowing the QA and DevOps team to create complex load testing scenarios, thanks to native Java scripting. It supports hundreds of technologies from web protocols to enterprise applications to network and server technologies. Some of the features of WebLoad are flexible test scenario creation. It supports every major web technology. There's powerful correlation engine, automatic bottleneck detection, generate load on-premise or in the cloud, native JavaScript scripting, and there are many more such as the UI wizards to enhance the script, supports many technologies, and also easy to reach customer support. And some of the protocols are the HTTP, HTTPS, XML, enterprise applications, network technology, and server technologies. Next up, we have the Load UI Pro. Now, Load UI Pro by SmartBear allows you to quickly create scriptless, sophisticated load tests, distribute them on cloud using load agents, and monitor performance of your servers as you increase load on them. Now you can access detailed reports and quickly automate your load tests on Jenkins, Bamboo, TFS, and other automation frameworks. Now if you're using SOAP UI already, you can convert the test cases into load tests with just 3 clicks, all without writing a single line of script. Some of the features include scriptless load test creation, pre-configured load test templates like spike, baseline, stress, smoke. Drag and drop load tests on distribution agents on cloud. There's sophisticated analytics and statistics features for reporting. Quick conversion of functional tests from SOAP UI as load tests. And some of the protocols supported are the HTTP, REST, SOAP, JSON, JMS, Swagger, RAML, IO docs. There's API blueprint, JSON schema, XML schema, MQTT, and many more. Now next up is the load view. Now with LoadView by .com Monitor, you can show actual performance of your applications under load, just as your users experience it. Now LoadView utilizes real browser-based load testing for websites, web applications, and APIs. It easily creates multi-step scripts that simulate users interacting with your website or application using the Every Step web recorder, or even manually edit the script using your own C# code. Now some of the features are the cloud-based load testing in real browsers. It quickly and easily builds test scripts without touching a line of code. The test compatibility on 40+ desktop or mobile browsers and devices. Also, 13+ worldwide cloud locations using Amazon Web Services and Google Cloud Platform. It also identifies bottlenecks and ensures scalability. Performance metrics and reports that can be shared with various internal stakeholders for capacity planning. Now, some of the protocols include the Flash, Silverlight, Java, HTML5, PHP, Ruby, and many more. Now, on number 6, we have the NeoLoad. Now, NeoLoad is an innovative performance testing platform designed to automate test design, maintenance, and analysis for Agile and DevOps teams. NeoLoad integrates with continuous delivery pipelines to support performance testing across the lifecycle, from component to the full system-wide load tests. Some of the features include the automated test design enabling 10 times faster test creation and update than traditional solutions, integration with CI servers for automated test runtime, collaboration that is shared test scripts and reports in real time and after test completion through an on-premise web interface. Also, hybrid on-premise and cloud load generation from over 70 global localizations. The protocols supported are the HTTP, HTTPS, SOAP, REST, Flex Push, and AJAX Push. Next up, we have the Load Runner. Now, this is an enterprise performing testing version of Load Runner and a platform enabled both global standardization and formation performance COE. So, it is basically a software testing tool from Micro Focus, which is used to test applications measuring system behavior and performance under load. Some of the features include it lowers the cost of distributed load testing, scale from single projects to a full-scale testing center of excellence that consolidates hardware, standardizes best practices, and leverages global testing resources. It also reduces the risk of deploying systems that do not meet performance requirements through the use of effective enterprise load testing. It also lowers hardware and software costs by accurately predicting system capacity. It pinpoints the root cause of application performance problems quickly and accurately. Effective tool utilization tracking is also available. Now, the browser-based access to global test resources and optimal usage of load generator farm is also present. Now, in this case, all protocols are supported by the load runner. This is just another added advantage of this tool. Next up, we have the Silk Performer. Now, Silk Performer tool is an enterprise class load and stress testing tool and has the ability to test multiple application environments with the thousands of concurrent users. It also supports the widest range of protocols. Now, there are good features in Silk Performer, such as it requires minimum hardware resources for virtual user simulation. It simulates modifiable virtual users, supports integrated server monitoring, and customer-friendly licensing. The correlation and parameterization is also user-friendly. There's no license requirement for controllers or individual protocols. It also handles load test and project approach. Not just that, it also generates reports with tables and graphs, supports 6 models of workloads, provides agent health control, server-side diagnostics, and many more. The protocols supported by this include the HTTP, HTML, HTTPS, Flash, Email, FTP, TCP/IP, LDAP, XML, SOAP, .NET, and many more. Now, on number 9, we have the App Loader tool. Now, App Loader is a load testing solution designed for business applications. It allows you to test any application by reproducing the same user experience from all your access points, thin, fat clients, and web portals. Now, some of the features of App Loader are it allows you to test the entire business flow, including all third-party apps without adding plugins or writing a single line of code. Now, the App Loader replicates the user's interactions with your application and gives you valuable metrics about the end user's experience, including screenshots of failures. Now, scripts are created automatically when you use your application and can be easily edited without coding. They can then be seamlessly applied to regression testing and application monitoring modules available. Now, let's have a look at the protocols. Now, App Loader is compatible with all versions of Citrix, XenApp, and XenDesktop, cloud-based and hybrid infrastructures, EHR systems, as well as custom applications. Now, last but not the least, on number 10, we have the SmartMeter.io. Now, SmartMeter.io is an alternative to JMeter and aims to fix its drawbacks. It allows for easy scriptless test scenario creation using the so-called recorder, yet lets you make advanced edits of the test. It also excels in test reporting and makes use of functions such as automatic test criteria evaluation, test runs comparison, and trend analysis. It fully supports CI or CD integration. It is also available for Windows, Mac OS, and Linux. Now, some of the features include scriptless test scenario creation, comprehensive reporting with automatic evaluation and test runs comparison, GUI test run with real-time results, state-of-the-art response body extractor, CI or CD ready. Now, the protocols supported include the HTTP, JDBC, LDAP, SOAP, JMS, and FTP. So these were some of the performance testing tools that I have listed in my top 10 list. Do let me know if you know about any other tool that would serve the purpose. Now, what is a JMeter? So the Apache JMeter is a Java open source software that is used as a load testing tool for analyzing and measuring the performance of a variety of services. Now, usually we tend to follow the trends in testing and forget to pay importance to verifying whether the product meets expected or required performance. Now, unfortunately, we figure out this pitfall post delivery of the product. Nowadays, performance is an inevitable factor, especially for web and mobile applications, as the user strength is very huge for each application, even if it is not to be expected all the time. Now, in order to cope up with such situations of load, we need a handy tool, and that's exactly where the Apache JMeter comes into play. Now, before we get to know more about the JMeter tool, we first need to understand what is performance testing. Now, it is very important to verify whether the product meets expected or required performance. Now, performance testing is defined as a type of software testing to ensure software applications that will perform well under their expected workload. Now, it focuses on certain factors of a software program, such as the speed, scalability, and stability. Now, performance testing is checking whether the application under test satisfies required benchmarks on both load and stress. Now, load testing is testing to see whether the system or application under test is able to handle the required number of concurrent user accesses on web server without any failure. And the stress testing is testing to see how the web server copes up with high load and limited resources, that is, under constrained conditions. Here we just determine what the maximum load is that the web server can handle. Now, performance testing has much significance in real time, particularly from a point of view of customer satisfaction and ROI. Now, we have come across several performance testing tools in our testing experience and have found HP, LoadRunner, OpenSDA, Load Impact, and many more popular ones. But JMeter is one of the much preferred one among testers worldwide. Now, let's have a look at the advantages that makes JMeter the most preferable one. JMeter is open source and built in Java platform. It is highly extensible and platform independent. Also, it is very user friendly. Now, JMeter has a comprehensive GUI which helps to create test plan and configure the elements. Now, adding elements is easy on JMeter. Just right click on the tree scenario and add what you need to do. Now, the newest version allows user to change look and feel. JMeter supports scripting, but it is not necessary because you can run a complete load test without knowing a bit of code. JMeter stores its test plans in XML format. It means you can generate a test plan using a text editor. Next advantage is the support. Now, basically, it is designed for performance testing, but also supports other non-functional tests such as stress testing, distributed testing, web service testing by creating test plans. Also, it provides supports for protocols such as the HTTP, JDBC, SOAP, JMS, and FTP. Now, JMeter has a wide range of users, so there is open source community there to help others. Next up is the comprehensive documentation. Now, this is one of the most important things to be highlighted. Because of its robust documentation, user can have a clear idea on each and every step, starting from scratch, including installation and configuration of the test settings and generating final report. The next advantage is the recording. Now, JMeter allows user to record HTTP or HTTPS to create test plan using recording facility. Now, we use proxy server that allows JMeter to watch and record your actions. while you browse your web application with your normal browser. And the final one is reporting. Now, JMeter supports dashboard report generation. A host of reports are generated through JMeter, which helps the user to understand performance test execution results. So now that you know what is JMeter and what are the advantages, let's begin with the installation process. Now, before installing JMeter, you must ensure that you already have Java installed in your system. So in order to check if Java is already there in your system, you can just open the command prompt and check for the Java version. So here you can see I already have the Java version 10.0.2 installed here. So now we are all set to download the JMeter. So now in order to install JMeter, we go to the official website, that is the jmeter.apache.org. Now here you have the binaries, so you can download any of these TGP or zip file from the Apache JMeter website. Now, JMeter is pure Java desktop application and it requires a fully compliant JVM 6 or higher. So you first have to check if you have the Java SE development kit installed or not. And here you can see that the latest version of JMeter available is the 5.1. So you can download any of these binaries. Now, installation of JMeter is extremely easy and simple. So you can simply unzip the zip or the tar file into the directory where you want the JMeter to be installed. There is no tedious installation screen to deal with. Now, once the download is complete, you can go into your downloads and find that the Apache JMeter file is already there. And inside bin, you will get to see all these files of JMeter. Now, if you are using Windows, you just have to run the file the jmeter.bat to start the JMeter in the GUI mode. So I have already installed the JMeter in my system and I have also created a shortcut in the desktop. So let's open this and show you how it actually looks. Now you can see that our Apache JMeter is getting started. So this is exactly how it looks. So this is our final Apache JMeter GUI. Now using this we can perform the testing for any website or any software program. Now, before starting any performance testing, let's discuss some of the important elements that are present in the JMeter. Now, there are 4 important elements that are the thread group, samplers, listeners, and configurations. Now, first we create a test plan. So, it is a container which describes what to and how to test. Here you can see how it looks like, just how I have shown you that how the GUI of the Apache JMeter exactly looks like. Now, a complete test plan consists of one or more elements such as the thread groups, logic controllers, sample generating controllers, etc. It describes the behavior of the element. Now, once we configure the element, we just save it. Then we run the test plan and analyze the test result from various graphical formats such as tree, table, and graph. Now, it is quite difficult for humans to execute performance testing manually. So it is inevitable that we depend on a performance testing tool to do the job. When we go for simply the best solution in all aspects of software development, why not in the matter of performance testing too? Now, JMeter is the final words in this department to be used for ensuring quality deliveries in time. So the first element is the thread group. Now, thread groups is a collection of threads. Each thread represents one user using the application under test. Basically, each thread simulates one real user request to the server. And the controls for a thread group allow you to set the number of threads for each group. For example, if you set the number of threads as 100, JMeter will create and simulate 100 user requests to the server under test. The next element is the samplers. Now, as we know already that JMeter supports testing HTTP, FTP, JDBC, and many other protocols. We know that thread groups simulate user requests to the server. But how does a thread group know which type of request it needs to make? The answer is samplers. The user request could be FTP request, HTTP request, JDBC request, etc. Now for the FTP request, let's imagine that you want to perform test on the FTP server. Now you can use an FTP request sampler in JMeter to do this task. This controller lets you send an FTP download file or upload file request to an FTP server. Now the HTTP request lets you send an HTTP or HTTPS request to a web server. JMeter sends an HTTP request to Google website and retrieve HTML files or image from this website. Next is the JDBC request. Now this sampler lets you execute database performance testing. It basically sends a JDBC request to a database. And then we have the BSF sampler. Now this sampler allows you to write a sampler using a BSF scripting language. The access log sampler allows you to read access logs and generate HTTP requests. The log could be image, HTML, CSS, etc. Then we have the SMTP sampler. Now if you want to test a mail server, you can use the SMTP sampler. This sampler is used to send email messages using the SMTP protocol. Now moving on, the next element is the listeners. Now listeners show the results of the test execution. They can show results in a different format such as a tree, table, graph or log file. Now the graph result listeners display the server response times on a graph. View result tree show results of the user request in basic HTML format. And the table result shows summary of a test result in table format. And the log shows summary of a test results in the text file. Now the final important element is the configuration element. Now it basically sets up default and variables for later use by the samplers. Now for the CSV dataset config, suppose you want to test a website for 100 users signing in with different credentials. You do not need to record the script 100 times. You can parameterize the script to enter different login credentials. This login information could be stored in a text file. Now JMeter has an element that allows you to read different parameters from that text file. It is the CSV dataset config, which is used to read lines from a file and split them into variables. Then we have the HTTP cookie manager. Now HTTP cookie manager has the same feature as a web browser. Now if you have an HTTP request and the response contains a cookie, the cookie manager automatically stores that cookie and will use it for all future requests to that particular website. We also have the HTTP request default. Now this element lets you set default values that your HTTP request controllers use. For example, you're sending 100 HTTP requests to the server google.com. You would have to manually enter server name equal to google.com for all these 100 requests. Instead, you could add a single HTTP request defaults with the server name or IP field that is equal to google.com. Then we have the login config element. The login config element lets you add or override username and password settings in samplers. For example, if you want to simulate one user login to website facebook.com with user and password, you can use the login config element to add this user and password setting in a user request. So this is all about the different elements of JMeter. Now we will see how all of these elements work actually. So all we have to do is run the jmeter.bat and then finally we will get our JMeter tool running here. Now this is based on a Java application, so you need not worry about the operating system because it will be working the same in all the operating systems. So this is our home window and you can see two sections here. The left side frame will consist of all the elements of JMeter and the right side of the frame will consist of the configurations that we are going to change. So here we can see the configuration of the test plan window. Now test plan is basically like a container that will contain all your test plans that you will need to perform. So any kind of graph, results, samplers, listeners, anything will come under the test plan. So let's just give it a name as Edureka. So here I've changed the name and as soon as you click here, you can see the name here is also changed to Edureka. Now when I right click here, and go to add, so you can see a lot of elements that we can add here. So one of the most important ones is the threads. So we have discussed about the thread group. So we know that the thread group is basically a collection of threads and each thread represents one user using the application under test. So here first we will be adding one thread group. Now let's rename this thread group as users. So here we have action to be taken after a sampler error. So what it basically means is that it's asking what should the thread do if there's an error that has occurred while performing the test. So here we have options like we can continue with our test or start next thread loop, stop thread or stop the test. So here we will be continuing with our test even if there's a sampler error. Now thread properties is one of the most important part here. We have number of threads, ramp up period in seconds, and the loop count, like if you want to count it forever or for some particular number of loops. So as of now all the values are 1, so we have one thread, one ramp up period and one loop count. Now let's go back and add a sampler now. So we already know that JMeter supports testing HTTP, FTP and all that. And the sampler is another important element of the JMeter. So here let's add another HTTP request. So the HTTP request will let you send an HTTP or HTTPS request to a web server. So we will be running a web application here. So I'll be renaming this one as homepage. So here we are giving the server of the website that we are going to perform the testing on. So let me take the Edureka blog website. So this is our Edureka blog page on which I'm going to perform the testing. So let me copy the URL here. So in the server name or IP, I'm going to paste the URL. But you have to remember here we are not going to use the HTTPS : and the /. So we would just be using the www.edureka.co/blog. Also, this last slash also indicates the path. So here we won't be writing this path. The path will be specified in this section. So here we have used the server name, that is the edureka.co/blog, and we have specified our path here. So for the root page, I'm just giving a / here. So now our HTTP request is ready. So we are going to perform our testing on this particular page, that is our Edureka blog page, and the path is also set. Now how do we get to know that what is the result of this testing? Now in order to view the result, we have to add a few more testing elements. So here we will be adding another element, that is the listener, and inside listener we have view results tree, we have view results in table. So we can select any of these as in how we want our result to be viewed. So we can view it in a graph, in tree or a table. So here first I'll be selecting view results in table. So here the result would be shown in the form of a table. Whenever I perform the testing, the result will be up here in the form of a table. So we just have to go inside the listeners because it shows the results of the test execution, and add the particular view we want. So I have selected view results in table. So now once we have done this, in order to run this test, first we have to save it. So I'm saving it in the desktop in the folder named as JMeter, and I'm naming it as Edureka test plan and saving it. So you must always save it if you want to reuse your test plan. Okay, so now that it's all done, let's finally run this and see how the performance testing works. So here we'll be starting our test. So you can see that the test is going on here. It shows the seconds that are taking. So this is the report that has been generated. So we have just performed one sample, one thread, because in our thread group section, we have given just one thread, one ramp up period and one loop count. So here you can see the result. So we have one sample, you can see the start time, at what time we have started the test, and then we have users 101. That is the thread name because we have just one thread and one user. And we have our label as homepage because we have named it as homepage, and it shows the sample time that has been taken. So we have a sample time in milliseconds, that is 4467. You can also see the status as green, which means it's performing well. And then here we have our bytes, sent bytes, latency, and the connection time. So you can see the connection time, that is the server request took 398 milliseconds. So now this was just a very basic test that we have performed. We have just taken one thread and we have shown the result in the form of a table. So now let's see what else we can do using our JMeter. So now let's go back to the users and let's increase the number of threads and see how it changes our values. So here I'll be using number of threads as 5. Let's increase our loop count as well. Let the loop count be 3 here. So now we have 5 threads, that is 5 users and 1 ramp-up period, and loop count as 3. Now let's go back to our home page and we have the same website in our server and the path is also specified. Now let's go back here. And before that, if you want to clear your previous results, then all you can do is just clear the history and see it's gone. So now again, first let's just save it and see what happens now that we have increased the number of threads and users. So let's run this. So now you can see that we have 5 threads and 3 loops. So you can see that we have user 1 of 1, 1 of 2, 1 of 3, 1 of 4, and 1 of 5. So what happens basically here is we have 5 users, that is 5 threads, and we have our loop count as 3. So all the 5 threads will be inside the loop count 3. So you can see all of these have been executed 3 times, all the 5 threads. So here also you can see the status is green, it's performing well, the testing is all fine, and we have the status as green. And we have our bytes, sent bytes, the latency, and the connection time as well. So now let's see how we can view our results in some other view. So let's go to add and listener, and inside this we also have view results tree and we also have graph. So let's go for view results tree and run the test again because we have the same values, and let's see how it works in the tree. So here you can see that in just a tree format, it shows you that our home page status has been performed these many times and it's performing well because the status here is green. Now let's check out how a graph will work. So for this we have to select the graph results. So you can see that here we have graphs to display as our data will be shown, the average, median, deviation, and the throughput. So now let's run this and see how it works. So you can see that here the number of samples are increasing and our latest sample throughput time, everything is increasing, and here you can see the graph. So we had 5 threads and we had 3 loops. So we had total number of samples as 15. So the graph doesn't show a huge deviation, but in our table we can see a proper result where you can see all the bytes, sent bytes, latency, connected time values clearly, and also get to know about the status. So you can always view your result in a table, tree, graph, or a log format. So now you have already learned about the thread group, the listeners, the samplers. Let's see how the configuration element works. So this is how basically a JMeter works. Now you know all the important elements that you can use inside the JMeter. That is, you have the thread group. First, you have the test plan where you get to configure your elements. Then inside that, you have your thread group, listeners, samplers, and how you want to view your result. You can view it in table, tree, graph, or in the form of a log. Now you know what is a thread group and how you can change the number of threads and the loop counts and how it affects your testing. Also, you can go inside that and create your HTTP request and also view your result in the way you want it to. So now this was just the beginning and this was the very basic of how you can perform your test plan. But these are the most important things that you need to keep in mind before performing any testing on any web page or any website. So I hope now you have understood how it actually works. So from the installation process to finally performing your first test plan, this is how JMeter will help you.
What is JUnit? JUnit is an open source unit testing framework for Java. It is important in development of test-driven frameworks and is also considered as an instance of XUnit architecture. As the name suggests, it is used for testing a small chunk of code or a unit. Now you might ask a question. What is JUnit? JUnit is used to verify a small chunk of code by creating a path, function, or a method. The term unit existed even before the object-oriented era was created. It is basically a natural abstraction of an object-oriented system, that is the Java class,
or object. JUnit basically promotes the idea of test first, code later. So this is about JUnit. Now let's take a quick look at the advantages of JUnit. JUnit is one of the best testing frameworks that can be selected for an efficient testing process. More application developer IDEs include JUnit. It also provides an AWT and swing-based graphical test reporting mechanism. It also provides a text-based command line. The open source community has extended JUnit by implementing a JUnit Enterprise Edition test framework that enables it to test within the application service container. JUnit is widely adopted by many organizations around the world for performing unit testing in Java programming language. JUnit has also become a benchmark for testing in Java and is supported by almost all the IDEs. So this is about what is JUnit and what are its advantages. Now let's move ahead and take a look at the features of JUnit. JUnit tests allows you to write codes faster, which increases quality. It is elegantly simple as it is less complex and takes less time to test an application. It provides annotations to identify the test methods. It provides test runners for running the tests. These tests can be run automatically on JUnit and they will check with their own results and provide immediate feedback. The test cases can be run automatically on JUnit and they check their own results by providing immediate feedback. There is really no need to manually comb through a report of the test results. Okay, so this is one of the major features of JUnit. JUnit tests can also be organized into test suites containing all the test cases. This also helps in showing test progress in a bar that is green if the test is running smoothly and it turns red when the test case fails. Okay, so these are some of the major notable features of JUnit. Now let's move ahead and take a look at the JUnit framework. JUnit is a regression testing framework which is used to implement unit testing in Java to accelerate programming speed and increase the quality of code. This framework also allows quick and easy generation of test data and test cases. Now let's discuss the major features of this JUnit test framework. They are namely test fixtures, test suites, test runners, and JUnit classes. Now let's get to know them in detail. A fixture is a fixed state of a set of objects which is used as a baseline for running the test cases. The major purpose of a test fixture is to ensure that there is a well-known and fixed environment in which the tests are run so that the results are repeatable. There are basically two methods under this test fixture. They are namely setup method and teardown method. Setup method is run before the test invocation. The annotation at before is used in this case. And in this case, we use the annotation at after. Let's understand test fixtures with an example. In case you write a code without annotations, the code is not readable, it is not easy to maintain, and when the test suite is complex, the code might contain some logical errors. So these are the issues that you'll be facing if you don't use annotations while testing an application. But when you compare the same code using JUnit, the code is far more readable and maintainable, and the code structure is way too simple and easy to understand. Okay, so this is how test fixtures play a major role in testing an application using JUnit. Now let's move ahead and understand test suites. If you want to execute multiple test cases in a specific order, it can be done by combining all the test cases in a single origin. This origin is called the test suites. A test suite bundles a few unit test cases and then runs them together. To run the test suite, you need to annotate a class using these annotations, that is at run with, at suite classes, or at suite.suite classes. Okay, so these are the annotations that you have to do when you want to test a suite. Now let's talk about a test runner. The test runner is used for executing the test cases. JUnit provides a tool for the execution of the test cases. JUnit core class is used in order to execute the tests. Another important method called run classes is provided by JUnit runner.JUnit core which is used to run one or several test cases. The return type of this method is the result object that is used to access information about the test cases. You can get this result object in the following link. So this is about the test runner. Now let's talk about JUnit classes. JUnit classes are used in writing and testing JUnits. Some of the important classes are assert, test case, test result. Okay. Now let's talk about assert. It contains a set of assert methods. We'll discuss what are these assert methods in a coming section. Test case. It contains the test case that defines the fixture to run multiple test cases. Test result. It contains methods in order to collect the result of executing a test case. Okay, so this is everything you need to know about the JUnit framework. Now let's move ahead to our next topic and understand how to set up JUnit on your system. Like I mentioned earlier, JUnit framework is used to test Java-based application. So before installing JUnit, you need to configure and verify Java Development Kit, that is JDK, in your system. So the first thing you need to do is have the Java libraries in your system. If you don't have the Java libraries, follow these steps to complete your Java installation. Go to the Java downloads page and click on the option for Java platform, that is JDK. In the next page, do select the Accept License Agreement radio button, accept it and click the download link against your matching system configuration. Now to cross-check the installation, just run the following command in the command prompt. It should display the installed version of Java in your system. As I already have Java installed in my system, I'm just going to verify if it exists or not. So I'm going to go to command prompt, type Java space hyphen version. So the version that I have in my system is 1.8. You can also download any version of your choice. The latest version is 12, and this command can vary from one OS to another. For Windows, we use this command, that is java-version. For Linux, you use $java-version. For Mac, you just have to click on tilde $Java version. Okay. You can run the installer once the download is completed and do follow this correct instructions. So first go to System and go to Advanced System Settings. Yeah. So it pops up environment variables here. Just click on the environment variables and click on New and add this command. So I've already added the command here. So the specific location of this JUnit will be stored in my C drive. And the variable name that I'm going to provide is JUnit_home. This is a must when you're working on JUnit. Click on OK. And do note, you need to add the class path accordingly. So I'll again click on New. So the variable value will be percentage class path provided by the percentage as well. That is a closing thing. And JUnit home and slash the JUnit that you're working on, that is version 4. Okay. And the variable name would be class path. Click on OK, click on OK, and click on OK. So this is how you set up JUnit on your system. It is just like how you set up Java on your system for the first time. Now, once you understood how to set up JUnit on your system, we need an IDE in order to perform the actions. I'll be considering working on the Eclipse IDE because it is user-friendly and all the available jar files can be easily downloaded in Eclipse. And preferably, if you're working on Java projects, I would recommend you to use Eclipse IDE. If you're new to JUnit and you don't know how to set up Eclipse on your system, I'll be putting up a link in the description below. Just click on it and understand how to install Eclipse on your system. As I already have Eclipse IDE here, I'm just going to open it. Yeah, so this is the Eclipse workspace. Now, in order to work on JUnit, first thing you need to do is create a new project. So I'm going to go to New and go to Project. And I'm going to name this JUnit project. And click on Finish. Yeah, you can see that a folder is being created under which the Java libraries reside and a source field where we'll write our code. Okay. So the next thing you need to do after you create a project is to add the libraries, that is JUnit libraries. So I'm going to right click on my project, go to Build Path and go to Configure Build Path.
Here you have to add the external JUnit jar files that you have to download. So I already have the JUnit jar file, so I'm going to just go to add external jars. I'm going to search for JUnit. Yeah. So I'm just going to add this, and then I'm going to add a library, that is JUnit library, to my program. How do you get this thing? One way which you can get this is you can go to the Eclipse market space and search for JUnit. You can install an external plugin from there. Okay, click on next and click on finish. You can see that JUnit library is added here. So I'm just going to click on apply and close. Yeah. So the JUnit jar files are added to your system. So these are the following steps you need to follow in order to set up JUnit on your system. Now that you've understood how to set up JUnit on your system, let's move ahead and learn how to write a simple JUnit program. So in order to write a simple program, I'm going to right click on the source field, go to new and create a new package. I'm going to name this as code.edureka and click on finish. I'm going to be writing my entire program under this package. So I'm going to create a new class in order to write it. I'm going to name it as JUnit class and click on finish. Yeah. You can see that a class of the name provided, that is JUnit class, is created here. And the first thing I'm going to do after creating the class is add the annotation test. And then I'm going to be creating a new method here, that is public void setup, under which I'm going to print a string. A string I'm going to be considering as str, and I'll print this is my first JUnit program. Okay. And then I'm going to be using the assert method in order to compare if the two sentences are equal or not. So assert equals, and I'm going to be writing the exact same thing, that is, this is my first JUnit program, comma, specify the string. So first I'll be importing the packages. This is, okay, this assert equals. Yeah. Once this is imported, I'm just going to run this. So I'll just click on run here. And you can verify that JUnit was set up in 0 seconds. Okay. So this is how you verify if your JUnit program is successfully installed in your system or your project or not. Now, next up, I'll create another class to execute this test. So I'm going to right click on my project and go to new class. I'm going to name this as demo class, add the main function and finish. Here, I'm going to be writing the corresponding code in order to access the JUnit class. Okay, so first I'll create the result and create an object of result that is equal to JUnit core dot run classes, where I'll be storing in the form of a result. You can already find it. Just click on this, and the class name is the previous name of the class, that is the JUnit class. Okay, I hope you're clear with this. It'll ask us to import. Yeah. So you have 3 options here for import. Check which one is suitable. We're using JUnit runner, so I'll be importing the JUnit runner packages. So here as well, let's see what it throws an error here. Okay, it is asking us to create a new class or interface. Okay, let me see what mistake I've done here. Yeah, so the name is JUnit, and I've used uppercase for U. JUnit is case sensitive and class. Okay, and I'm going to be checking for a condition for failure, creating an object of the same failure, and check the result of get failures. Okay, so it returns the results in the form of a list. Okay, so I'll just import this failure packages. Yeah, done. And I'm going to be writing the corresponding code inside this. So I'm going to consider printing it first, system.out.println. 。. .
In this, I'm going to be printing failure dot toString. Okay. So this basically helps in printing the results which are failed. And after this, I'm going to print another statement, that is system.out.println, where I'm going to be writing result is equal to, and specify the result location, that is result dot was successful. Okay, so this prints the test case which was successful. Now let's try running this program. Save it and run. Yeah, so it prints the result is true. Now, how is the result true? It checks for the condition for failure. The result is get failures. And if this condition satisfies, it is going to print the failure string, that is the failed string. In case if it is true, it prints this particular command, that is result is equal to. So this is how you test an application or test a program using JUnit. Now that you've learned how to write a simple JUnit program, let's understand the TestNG annotations. JUnit framework is built on annotations. An annotation is a special form of syntactic metadata that can be added to a Java source code for better code readability. These annotations provide the information regarding the methods that are going to be run before and after the test methods, the methods that are run before and after all the methods are completed, the methods or classes that will be ignored during the test execution. Okay, so these are the following list of annotations that we have. That is test, before, after class, after class, and ignore. Okay, now let's understand them in detail. Annotations start with the letter at. Okay, so this test annotation tells JUnit that the public void method can be run as a test case. Now let's talk about before. This helps in annotating a public void method with annotation before, which causes the method to be run before each test method. Okay, so this method is called before you execute any test case. What about after? If you allocate external resources in a before method, you need to release them after the test runs. So one way to do that is annotate the method with at after, which causes that method to be run after the execution of the test method. Talking about before class, this method helps in annotating a public static void main with at before class, which causes it to be run once before any of the test methods in the classes are run. Talking about after class, this will perform the method after all the test cases are run. This is used to perform cleanup activities as well. Talking about the ignore annotation. This annotation is used to ignore the test that will not be executed. This is also used in order to skip the test cases. Okay, so these are the annotations that you need to be perfect when you're working with JUnit. Now let's move ahead and understand what are the assert statements that are available in JUnit. Assert is a method which is used in determining pass or fail status of a test case. In JUnit, all the assertions are in the assert class. So this class basically provides a set of assertion methods which are useful for writing the test cases. Do note that only failed assertions are recorded. So there are different methods under this assert command. We have 8 assert statements in total. Let's take a look at them one by one. The first method is void assert equals, which is of the form boolean expected and boolean actual. So this basically checks if the two primitives or objects are equal. Okay. Next we have void assert true, which takes in the condition boolean true or false. So this basically checks whether the condition is true. Next we have assert false, which also takes in the boolean condition and it checks whether the condition is false. Next we have assert not null, which checks whether an object isn't null. Void assert null, which checks whether an object is null. Okay. Do note that not null is used to check whether an object isn't null. To check whether an object is null, you use assert null. Okay, which takes in the object. Next up we have assert same, which compares two of the references. So this assert same method tests if two object references point to the same object. Assert not same checks whether the two object references do not point to the same object or not. Last we have assert array equal. So this is similar to assert equals, just that you'll check two arrays instead of two objects. Okay. So this assert array equals method will test whether two arrays are equal to each other or not. Let's take a quick look at the example for this. So I'll create another class under this package. Assert. Click on finish. Yeah. Under this, I'm going to be writing the corresponding commands. The first thing I'll do is create an annotation of test and add public void test assertion. Yeah. Under which I'm going to test the data. So the first one will be of the form string str equals. So I'm going to create a new string and give this a text. I'm going to be giving Edureka or edu. Yeah, this is fine. I'm going to provide another string and name it str1 so that you can differentiate the two strings. I'm going to create another string, give this as the same edu. Now, once you've provided the input for the first two strings, let's consider the next strings. So the next string which I would like to write would be, so I'm going to instantiate the string command to null. Okay. And then I'm going to create another string and instantiate it to the value that is specified here, that is edu. Okay. So two of them have the same values, but one string would be considered as null. I'm going to create another string str4. Even this will be edu. And the next thing I'll do is provide two integer numbers in order to create an array. So I'm going to be writing int value is equal to 5. I'm going to be giving it as 5. Next, I'll give another value 1 or 2. I'm going to be naming it as 1, 6. After you input the values, which is of the form integer, I'm going to be creating an array of the form string. So string array, and I'm going to create an object of this, that is expected array is equal to, in the flower braces, I'm going to be writing 1, 2, 3. Okay. So this is the expected array which I want to compare it with. And the result array would be the same. Okay. So I'm just going to copy this thing and paste it over here. Okay. So that the expected array and the result array are the same. Now let's check if the two objects are equal. So I'm going to be using the assert method in this case. So I'm going to write assert equals string and string1. Yeah. And it throws up an error. It says create a method. Let me just fix this first. Import the testng libraries. Yeah. And assert equals, it'll state and static import JUnit methods. Done. And once you've done checking if the two objects are equal, let's check for another condition, for the true condition. So check for true. And I'm going to be writing assert true. And I'm going to be providing value less than value 1. So this basically checks whether the condition is true or not. So I'm going to import the static true. And after you've done checking for the true condition, let's try to check the false condition as well. Check for false, that is assert false. And I'm going to provide the same condition, that is value less than value 1. I'll import this as well. Now, once you're done checking if the condition is true or false and also if it is equal or not, let's check for the null condition. Check for null. So assert not null will have the first string. Now let's check if it is null. So assert null. I'm going to be taking the second string which I've mentioned here as null, We can see that I've declared this as null. So I'm going to be considering writing string2 and import this as well. So once you've done this, let's also check if two object references point to the same object. Okay, so we've already come across this assert statement, that is assert same. So I'm going to write a comment here, that is check if the reference is to the same object. Okay, and I'm going to write assert same, and I'm going to be comparing string 3 and string 4. I'm going to import the assert same packages. Done. So now let's try to run this program. So it says the assertion took place in 0.20 seconds. Okay. Now let's try writing the main function in order to run this. So I'm going to create a new class and call it main class. Include the public static void main and finish. I'm going to be writing the code here. So now I've called this class as main class, and I'm going to be writing result, create an object of the same, is equal to JUnit core dot class. That is the name of the class that we want to search for. That is run classes. So the name of the class that we had before was assert class. So assert dot class. Done. So we need to import the result packages. Do note that you import JUnit runner packages. And after this, I'm going to be considering the same for loop here for the condition failure. Create an object of it, that is failure is the result of get failures, which returns it in the form of a list. I'm going to be importing the failure functions. I'm going to create this and print failure dot toString. So this helps in printing the failed string, or I'm going to be printing the result dot was successful. So this will print the test case which was successfully executed. Okay, save this and run this program. So the output of this is the test assertion dot assert is null. Okay, now let's take a look at our assert program here. When we've provided this particular command, it says assert null string2. So this condition is true, so it will be printing null. Now let's run this program. It says test assertions co.edureka.assert is null and the result is false. So it is printing that the test case has failed. So or else it would have printed that the test result was successful and it would have printed that the result is true. Now let's take a look at our assert program. So we've provided the first and the second string to be equal. So first thing it checks for equal command is string and string1. So this basically checks between the two strings, that is string and string1, if they are equal or not. They're equal, you can see that it is equal. And it also checks for assert true function where we've provided two values and checks if the condition is true. So the value is 5. 5 is less than 6, so it is true. For false, value is less than value 1. So this does not print false because value is less than value 1. That is 5 is less than 6. So this is true. Okay, so this will not print false. Now talking about not null. String, we've provided the value of the string which has the string edu. This is not null, so this will return true. Talking about assert null, it has a value of string2 which we've provided to be null. So even this will return true. At the same time, we are going to be comparing the same function, that was assert same, between the two strings 3 and 4, wherein they possess the same string which is edu. Now talking about the main class, you can see that there is printing false. Okay, so that means your test case has failed. So let's analyze how you can solve this problem. Let's go to our assert function and take off all these static equals method. Okay, the import methods that we've had, which is of the form static, let's take all of them out and import the package which says JUnit assert. This is actually way too simple because you have all the assert statement commands inside this. So I'm going to just import this, done, and then add a few commands here. So I'll be writing another command to check if it is not same or not. So assert not same string1, that is string comma string1. So this basically checks if string and string1 are same or not. Next we have to check the array. So assert array equals. So we were basically checking for the arrays here. So the name we provided here was expected array and the result array. So the expected array would be expected array and the result array. Okay, so this is done. So I'm just going to save this and run my main class. Now you'll see if the result is true or false. It says false again. Now it is printing false again. This is because that a condition that is specified here for false is not true. Okay, so this says value is less than value 1, which means it is true. So we have to provide a condition which says it is not true. So it is greater than value 1. That is 5 greater than 6 will throw up an error which says false. Now let's save it and run the main function. It will print true. So this is how assert statements in JUnit works. Now let's move ahead and understand what are the exceptions that occur during the execution of a program. JUnit provides an option of tracing the exceptions that occur in the code. You can test whether the code throws the desired exception or not. And the expected parameter is used along with the test annotation. Okay. So while testing for an exception, you need to ensure that the exception class that you're providing in that optional parameter of the test annotation is the same. This is because you are expecting an exception from the method that you're testing. Otherwise, the JUnit test would fail. Okay. For example, at test expected illegal argument exception.class. So this is an exception. So by using the expected parameter, you can specify the exception name that your test may throw. So you will get this illegal argument exception, which will be thrown by the test case if a developer tries to use an argument which is not permitted. Okay. So this is one of the notable exceptions that occur during the execution of a process in JUnit. Now let's take a look at the parameterized test in JUnit. JUnit 4 has introduced a new feature called parameterized test. This test allows the developer to run the same test over and over again using different values. So we have a few steps in order to create the parameterized test. Let's take a look at how it is done. So you need to first annotate the test with run with. This mainly specifies that it is a parameterized test. Then create a public static method annotated with parameters that returns a collection of objects in the form of an array as test data set. Moving ahead, create a public constructor that takes in what is equivalent to one row of the test data. Create an instance variable for each and every column of test data. And also create your test cases using the instance variable as the source of the test data. Okay, so that's it about parameterized test. Now let's take a look at the final topic, that is JUnit versus TestNG. TestNG and JUnit both are well-known terminologies when you talk about software testing frameworks. TestNG is almost similar to JUnit except for certain functionalities. So I'll be comparing JUnit and TestNG based on their features. So the major features I'll be considering to compare JUnit and TestNG are the suit test, annotation support, ignore test, execution before all the test cases in a suit, dependency test, and parameterized tests. So let's compare them based on the suit test. JUnit and TestNG both consists of the suit test, that is the annotation suit, okay? And it also possesses the annotation support through both JUnit and TestNG. Ignore test in the case of JUnit is specified using the command @ignore, whereas in TestNG you use a command called @test enable false. Okay, so in TestNG you'll specify if the enable is true or false. Okay, now talking about the execution before and after all the test cases in the suit, JUnit does not execute before and after the suit.
Whereas TestNG provides commands like before suit, after suit, before test, and after test. Talking about the dependency test, JUnit does not support dependency test, whereas using TestNG you can perform dependency tests. Now talking about the parameterized test. Parameterized test in JUnit can be done using the annotation run with and parameter, whereas in TestNG the parameterized tests can be carried out using the annotation data provider. Okay, so this is everything you need to know about JUnit if you are a beginner.
Automation is everywhere. Amazon is testing delivery drones that pick up warehouse orders sorted by robots. Google is testing self-driving cars. Starbucks is testing cashier-free stores dedicated to mobile ordering and payment. And Facebook is testing a brain-computer interface that may one day translate your thoughts into digital text. Fascinating, right? But why are these companies so hyped up about automating the software testing process? That's because test automation offers a lot of benefits. Manual testing can be mundane, error-prone, time-consuming, and even boring. But test automation enables testers to focus more on challenging and rewarding work, and in turn increases the accuracy of the results. Test automation saves a lot of time and effort. It even offers better test coverage. And increased test coverage leads to testing more features and a higher quality of application. So it provides cross-browser and cross-device testing as well. Test automation makes it possible to execute test cases during off-peak hours and to distribute them in parallel across multiple physical or virtual servers. It also reduces business expenses. I do agree that initial investment may be higher, but return of investment, or ROI as we refer to it, is also high in longer run. Also, test automation reduces manual intervention. And since you are using automation tools, less number of people will be required for a project and they can be utilized for other projects. So guys, these are some advantages of using test automation. Automation testing is absolutely essential today to successfully deliver large-scale products that need execution of repetitive and complex test cases. That sounds good, but it is impossible to automate all testing. So it is important to determine which test cases should be automated first. When it comes to figuring out where to start automating, there are some top candidates that will help you recognize the maximum return on investment. So these are some test cases, guys. Firstly, repetitive tasks are primary candidates. Not only are those tasks boring to you, but they are often the ones where you actually make mistakes. Because when you do a task repeatedly, we as humans often make mistakes. Automate them and do something more fun. Capturing and sharing results is a critical part to a successful test strategy. So rather than manually exporting your data, crunching numbers, and making complex graphs, invest in a tool or automation strategy that will do this task for you. You can also automate tests that require multiple data sets. And instead of waiting for on-screen response, automate the task. That way you do not have to waste time staring at the screen and waiting for a response. Another case where you can automate is load testing. Well, think about having to see if your application can handle a load of 10,000 users. Automate this testing so that you do not have to worry about manually spinning up 10,000 users hitting your application all at the same time. You can also automate test cases that run on several different hardware or software platforms and configurations. Because testing software with multiple configurations on different platforms manually takes a lot of time and effort on your part. So guys, these are some cases where you can actually apply test automation. Now once the decision has been made to use test automation, the next issue is, how are we actually going to do this? What's the plan? One of the most common mistakes with automation testing is going for immediate benefits and forgetting about the bigger picture. Many teams abandon their automation efforts after a sprint or two and go back to manual testing. Now, why do you think that happens? Most of the time, most of these companies use automation just because others are using it. They're not sure of the right way to implement the test automation. They do not have the right automated testing methods in place. They do not know when to implement test automation and when not to. They're not aware of the right set of tools that meet their requirements. So what I'm trying to say here is that success in test automation requires careful planning and design work. To achieve high quality software within a short period of time is one of the objectives of every software company, and I'm sure you guys know that. To achieve that, they either can save few days of planning and instead spend weeks testing or programming, or they can spend a little time developing a proper test automation strategy to keep pace with the market. So to build a cost-effective automation testing strategy with a result-oriented approach is always a key to success in automation testing. Well, you can build a good test automation strategy once you understand automation test lifecycle. So let's explore that. Automation test lifecycle has following phases. The first one is automation feasibility analysis. So basically in this step, you check the feasibility of automation. As in, you shortlist the test cases which you want to automate. You select the right tool that fits your requirement and all that. Next step is test strategy. In test strategy, you select the test automation framework. Well, you have multiple options to choose from here. Like you have linear test automation framework, you have data-driven framework, you have keyword-driven framework, modular framework, and hybrid as well. If you guys want to know more about these test automation frameworks, you can actually refer to the previous live session in the playlist listed below in the description. Well, moving on. In this phase, you can create a test place, test plan, and test automation suite in your test management tool. So the next step is environment setup. In this phase, you set up the testing environment and acquire the required hardware and software tools to execute the automated test cases. That's pretty simple. And the next step is script development. In this phase, you start creating the automation test scripts according to your requirements. But make sure that your scripts are reusable, well structured, and well documented. This will help you in long term if you're automating. Obviously, the next step would be case execution. In this phase, you execute your test cases. And finally, we have result generation and analysis. This is the last phase of test automation lifecycle. In this phase, you analyze the output of test cases and share the reports with stakeholders. So now that we are aware of the automation test lifecycle, let's have a look at the building block of test automation strategy. It consists of 8 items for you to consider as you head out on your automation journey. And those would be scope of automation, test automation approach, automation test environment, risk analysis, execution plan, review and failure analysis, automation maturity model. So let's explore each of them a little deeper. Oh guys, before you start, I just wanted to say that these blocks are not listed in any particular order. Okay, let's get started now. So the first thing is scope of automation. Defining a project scope for an automation perspective includes outlining timelines, milestones for each sprint in the project. So the 2 most important things that you do here in the scope of automation is shortlisting the test cases which you want to automate and selecting the right test automation tool. Guys, you can't automate everything. So you should be smart about your priorities if you are focusing on high return of investment. One of the best model that can help you with that task is Mike Cohen's test automation pyramid. Using this, you can decide which test cases to automate. The pyramid shows that in general, you should try to push tests down to the lowest level possible. Unit test or unit test are the quick to write. They have the highest return of investment and should ideally form the backbone of your automation testing strategy. Developers, can write unit tests to check the smallest pieces of their code and find bugs on their own. After unit test, we have regression test. It should be our next priority as the written investment after each successful build. Next, you need to check functionality and other quality characteristics such as accessibility and security across large piece of application with functional testing. So what I mean is that after unit testing and regression testing, it's functional testing. Then comes user interface test. Although pretty common, automating at graphical user interface level is highly impractical. That's because user interface requirements keep changing, which makes automation more complex. And user interface tests are expensive, they require heavy maintenance, and they're written high number of false positive or you can say negative cases. So these are how you shortlist the test cases. So no matter how skilled you are in automation, how many Selenium commands you know, or what testing frameworks you use, some things simply cannot be automated. Like user interface test. They have ever-changing requirements and they're difficult to automate. So automation there is not suggested. Similarly, when you have exhaustive document, even then automation is not suggested. And suppose if you have tests that you're going to execute only once, why do you need automation when you can do that using manual testing in short amount of time and without much effort? And you also have tests which are based on visual perception. You have anti-automation features like CAPTCHA, I'm sure you've come across it. And you also have ad hoc and exploratory testing where you can check system based on your knowledge of its internal workings and experience. So manual touch is definitely needed there. So automation is not possible in ad hoc and exploratory testing. So this is how you shortlist cases that you want to automate. So once you've decided on which test cases to automate and which not, next step is to collect the appropriate testing tools that suit your requirement. Selecting the right tool is the key factor that guarantees the success of your test automation strategy. You need to select one out of several test automation tools that are available in the market. Well, that can be a difficult task because there are a lot of and tons of automation tools in the market. So in order to select the tool that fits best for your project, first you need to understand your project requirements thoroughly. And then you need to identify the testing scenarios that you want to automate. Based on these two, you need to shortlist your tools that support your project's requirement. Then you need to identify your budget for the automation tool. Once you have an idea of the budget, you can further shortlist the tools based on your budget. After that, you can shortlist tools based on certain parameters like licensing cost of tool, maintenance cost, training and support, tool extensibility, tool performance, and stability. So you can follow these 3 simple tests before you actually select a proper automation tool. There are plenty of cost-effective tools available in the market for automating different kind of applications like Windows application, web application, websites, mobile web applications, native mobile applications, and many more. And some of the popular automation tools that you can use to automate any kind of application are Selenium, then you have Microsoft coded UI framework, then you have HPQTP and many others. So that's the first block. Moving on to next one, it is test automation approach. When choosing a test automation approach, guys, there are 3 areas which you have to consider: process, technology, and rules. Well, we've already discussed about process and technology in the previous block, which is how to actually shortlist your test cases and how to select a tool and all that. But anyway, let's go through it again. So first, process. Test automation rollout must be a well-defined and structured process. So make sure to cover the following in your plan. Like, when during the sprint should automate test cases to be developed? As in when you actually should develop your automated test cases, during what time? What are the features which are ready for automated testing? Which features should be tested manually? Who take care of the maintenance? How do you analyze results? So all these questions you need to include in your plan. So after process, it's technology. Identify the applications which you have to automate. Figure out which technology they are based on and whether or not your test automation platform supports those technologies. Then you have roles. Here you define the roles for automation in the test automation team, as in your test automation team. Make sure that all members know who is responsible for which part of automation project. Guys, all members of a test team, including domain specialists, technical testers, and test management, they play a very important role in making test automation actually work. For example, you have automation lead or engineer. He is responsible for coordinating and managing all activities regarding automation in the project. And when it comes to test case, you have test case designer, one who designs the test case, and reviewer. Once the test case designer designs them, to have a second look, we have reviewer. So this way you have different roles. So remember that success with automation is dependent on a team's collective knowledge. Adopt a test automation platform that all testers can work with, so that automation becomes a natural part of daily work of all your team members. Other thing that you can focus here are reusability of automation scripts. Your test automation strategy must include the reusability of test scripts. This will help you reduce scripting development efforts. There are many general functionalities which are common in applications. You come across them, especially if you're a company who is taking projects which is related to a single domain. For example, let's say if your company develops web applications, you can create a process to reuse testing scripts for login and validation test cases. So instead of writing same test cases again and again, you can store them in a file and reuse them again. Then you should make sure to include manual testing. Automation testing isn't a replacement for manual testing. It's just an extension of manual testing. So no matter how great automated tests are, you cannot automate everything. We even discussed some cases where you can actually not automate, right? So manual tests play a very important role in software development, and they come in handy whenever you cannot automate the process. So don't try to automate everything. And the next point is we have something called release control. In any release pipeline, regardless of its complexity and maturity, there's a point where a team should decide whether to release a build or not. Part of this decision making can be automated, while other parts still require human touch. In any case, make sure that the results from the test automation are part of the release decision. So final decision regarding release will often be based on a combination of algorithm results and manual inspection. Moving on to next one, we have something called risk analysis. Risk analysis, as you guys know, is an essential part of project planning in general. But it is important to consider this specifically in automation as well. So you can create a risk plan with parameters like description, which describes what's the risk all about. Then you have risk level or severity. What will happen if the risk becomes reality? How hard will it hit the project? Then you have something called probability. What is the likeliness that it can occur? Then you have mitigation. What can be done to minimize the risk? And then you have cost estimate in the end. What is the cost of mitigating the risk? What is the cost of not doing it? Well, these are just basic parameters. You can consider several more. Let's consider a simple example. As you can see, the first risk, it says we do not have enough trained resources to create test automation. And what will that lead to? This will lead to lower test coverage as more manual regression testing must be performed before release. This in turn might delay the release. So what will happen if the test becomes reality? How hard will it hit the project? Very high. And what's the probability that this risk might turn into reality? Well, it's medium. And what do you do if it has actually occurred? You can contract partners or you can contract training providers. Alternatively, you can educate the workers in your office so that they can handle more load. And what about the estimate cost? It says TBD. It means time-based decision. Similarly, next risk, it says test servers will not be able to keep up with the load from the automated regression test, which will lead to high number of false failures in the reporting. And what's the risk level? Medium. And the probability is medium. And what you could do, you can contact operations and make sure that the servers are configured to cope with expected load. Now, what about the cost? It's about $10,000. So this way, you can create a risk document. But one more important thing is that risk plan is a dynamic document, as in it keeps changing, it's not fixed. So risk will be added and removed to the list as the project evolves. So next one in the test is test automation environment. Setting up your test environment is another building block of test automation strategy, guys. You can establish your automation testing environment by following certain steps. First of all, by identifying the requirements of test environment, then by acquiring the required tools with their licenses. And you can also consider the data which is part of test cases, like where do you have to store the data which belongs to test case? Should the data be masked or not masked? Do we need to have backup for the data? What happens to the data after testing? What should be done with it? So you can ask these questions. You can consider the test data requirements as well. Test automation is a deterministic game. Known inputs will produce predictable outputs. This means that stable and predictable test environment is a prerequisite for successful test automation. After that, we have execution and management of test cases. Your test automation strategy should also define the process of execution and management of test cases. An execution plan actually outlines two things, which is the day-to-day tasks that you do and the procedures which are related to automation. There are certain practices that you can follow when you're writing test scripts and when you're executing them. For example, first of all, pick the test cases which you want to automate, like I told you in the first step. After that, before you add any automated test cases to your regression suite, run and verify them multiple times to ensure that they run as expected. Next, you need to define a set of best practices that make test cases resistant to changes in system which is being automated. So your test cases should be written in such a way that even when the requirements of your system which you're automating is changing, they shouldn't be affected. Next, you can actually run your tests in parallel. This means that use pipeline orchestrator like Jenkins, TFS, Bamboo, many other things, or a scheduling tool to execute test cases in parallel. This way, feedback from the test is sent to developers at very fast rate. So guys, you can never test too much, and the combination of test automation, reliable test cases, and scheduled or controlled execution will always give you a positive effect at the end of your automation. One more thing, after executing a test case, assign a status, either pass or fail with it. In automated testing, this status is assigned to the test cases automatically according to your success criteria. If it's a fail, you have to perform failure analysis, which is actually our next step. Failure analysis and reporting results. So having a plan for how to actually analyze the failed test cases and how to resolve them is a critical part of test automation strategy. Often, time taken to notify the failure, analyze it, and resolve it is much longer than you actually anticipate. So having a well-defined process for this can save a lot of time and frustration in development team. So what you can do is you can outline how different errors should be handled and by whom. For example, let's say you have some issues related to environment, the test environment. You can raise a ticket with DevOps team. And suppose if you have a bug with automation scripts, you can create a task for testing team. Similarly, if you have a bug in the application on which you're performing automation or you're testing, you can actually flag a bug for development team. This way you can outline different errors, who should handle and how they should. So once your error handling is done, next thing, all the things that you've done till now, including the methods that you adopted to implement automation, test results, pros and cons of the test automation strategy that you have used here should be captured and documented for future reference. Then you need to continuously improve your test automation strategy by learning from those lessons. So the last thing is to revamp your test automation strategy. You can't directly develop a perfect test automation strategy very first time. You make it perfect by improving it every time you find a fault with it. Automation maturity model is a way you can use to revamp automation test strategy. Automation maturity model is divided into multiple phases. For example, you have something called initial phase. So guys, basically before explaining the phases, all you do in this revamp is you actually go through everything that you did in your previous strategy and find the errors and replace them, as in resolve them. So where were we? Initial phase. Here, prerequisites of automation should be completed. Then you have something called manage phase. Automation is achieved without any central infrastructure in this phase, as in there's no dependency. Then you have define phase. Central automated process across the application lifecycle should be built here. Then you have something called measured phase. Your collected and analyzed metrics of automated process should be compared against your business goals here. And finally, you have optimize phase. Here, things like self-service automation or learning about automation by looking at the analysis results, which we call self-learning using analytics, and self-remediation should be addressed here, or actually addressed in this phase. So using automation maturity model, you can revamp your test automation strategy until you find it fit for your organization. So guys, this way you find a strategy that's best for you. It's very much necessary to come up with an intelligent test automation strategy to fully enjoy the benefits of automation testing and achieve the desired level of success. A successful test automation strategy can lead to big things. It's true. A successful testing strategy and framework can positively impact your business and organization in a number of ways. First of all, it provides you more comprehensive testing. The most complex test automation tasks are completed easily when you have a strategy, and your products become more robust as a result. It also promotes the reuse of critical components. By reusing the critical components, it increases employee productivity since the time they would have spent on manual tests is saved by the reuse of components. So what I'm trying to say is, instead of them manually doing each thing again and again, they can use the reusability scripts. They can invest their time into other critical areas of their work and business. It also reduces maintenance cost. You can change and update your testing methodologies more easily. Because you have taken time to plan and design your solution, your employees adopt these changes quickly and very easily, and they have very less maintenance work to do when it comes to automated test solution. It also creates the testing standard for your organization. Your strategy will become the standard that's used across your organization because it's complete and robust. And finally, if your strategy is based on result-oriented approach, it will give quick confidence about your product to stakeholders as well. So guys, these are some key benefits of developing a test automation strategy. I hope the above strategies help you as you head out on your automation journey. Let's see how to build a data-driven framework using Selenium. So now you might be wondering, why Selenium, right? Demand for web development and testing is literally huge. As of January 2019, there were over 1.3 billion websites on internet serving and 3.8 plus billion internet users worldwide. So as a result, the tooling market is now more competitive than ever. But so far, no one has outshone the Selenium in terms of popularity and adoption. So when it comes to Selenium, the biggest sweet spot of Selenium is that it's open source. In other words, it's completely free to download and use. It provides an API called WebDriver, which enables testers to craft their tests in many programming languages, which includes Java, C#, Python, Ruby, and many other languages. Besides web browsers, you can also automate mobile devices like Android and iOS via APM as well. So that's why I've chosen Selenium in this demo. Moving forward, let's take a look at general steps that you need to follow when you create an automation framework using Selenium. So first of all, you need to choose a programming language. In Selenium world, you have wide range of programming languages that you can choose from. Like I said earlier, you have Java, C#, Ruby, Python, and many others. In my opinion, Java is a good choice because it's widely adopted and it's cross-platform. So in this demo, we'll be using Java, no doubt. So once you're done choosing your programming language, next you have to choose a test framework. Now you might be wondering, why do you need a test framework, right? A test framework or a unit test framework helps you to mark a class or a method as part of testing using annotations. You can execute tests in parallel, you can generate logs, you can perform the assertion, verification and all that. So once you're done choosing your programming language and selecting a unit test framework, you need to design the framework as architecture. So make sure you come up with a sustainable, maintainable and scalable architecture. So now based on your architecture, you start building your test modules. So next, choose a reporting mechanism. Reading the test results will be difficult if you do not have a good reporting mechanism. Let's say when you receive a test failure, how do you invest the failed test quickly to determine whether it's what kind of error it is? If it is a AUT bug or it's an intentional functional change or the automation mistake or whatever it is, how do you figure out? For that, you can use a reporting mechanism. Well, the framework, unit test framework like TestNG does offer you a reporting mechanism, but the results are not in human readable format, as in you won't understand it. For that, you can use some third party error reporting mechanism. And last step is, if you want to, you can integrate your framework with other tools as well. For example, you have TestRail. It's a test case management system that proves useful when your project has large number of tests. Apart from that, you also have Jira integration and many others. So yeah, these are the basic steps that you follow when you're creating a framework. So guys, I forgot to tell you a point. It's that when you're choosing a unit test framework, in this demo, we'll be using a framework called TestNG. It's similar to JUnit, but it's much more powerful than that, especially in terms of testing integrated classes. It eliminates most of the limitations of older framework and gives testers the ability to write more flexible and powerful tests. So let's quickly go through the steps again. First, you need to choose a programming language of your choice. Then you need to choose a unit test framework. After that, you design your framework architecture. Based on that, you start executing your scripts and creating them. After that, you need to choose a reporting mechanism so that you will find out the errors and the reason for those errors much easily. And lastly, if you want, you can integrate your framework with other tools as well. So guys, let's get started with our demo then. For that, I need to open my Eclipse. Before that, I want you to install some extra jar files. For example, let's say since we're using Selenium here, you'll have to install Selenium jar files. And there's something called Apache POI. Well, I'll let you know what is that for later. So go ahead and download Selenium jar files and Apache POI. Let's say Selenium download. Sorry about the spelling mistake, guys. You can go for downloads here. And you can download the version here, and you can also download this one, as in the language for which you want to use Selenium. So yeah, after that, you need to install something else as well, Apache POI. Here, there's a link which says download release artifacts. Under that, you have the latest stable release. Click on that. It'll take you for the binary distribution and source distribution. Go ahead and download the zip file. And if you're using Mac and all, you can download the tar file as well. So once you've downloaded all the files, unzip them, extract them, and store all the jar files in separate folder. Well, I have stored them here in my C folder. I have a folder called Selenium, and I have all my executable jar files here. So we're ready to start a demo. So the first step you need to do is download Selenium jar files as well as Apache POI. Don't worry about Apache POI for now. Okay then, let me open my Eclipse. It's on my desktop. Here it is. Sorry about the delay, guys. Give me a minute. It should load up. Launch. So sorry about the delay, guys. Anyway, here we are on our Eclipse. Well, on my Eclipse. So I have a project which is named as Framework Demo. So before we actually get in, like I said, we have installed our Selenium jar files as well as Apache POI. Let me tell you what Apache POI is for. So guys, basically just a WebDriver doesn't directly support reading of Excel files or any kind of external data files. For that, you need to use some sort of third-party device or a program called Apache POI. So we can use Apache POI for reading, writing any Microsoft document into your program here. So we've already downloaded the jar files. I've stored them in a separate file called Selenium under my C folder. All you have to do is go for your source file, right click on it, and there's an option called build path here. Well, I've already added the libraries to my project. For you guys to do, you can go ahead for this build path and you have an option called configure build path. Click on that. So once the dialog box opens, you have something called libraries here. Go for that and click on add external jars and go ahead and add all the jar files which you've just downloaded and stored it in the folder. Well, I have done it already, so I'm not doing it again. And click on open, and once they're added, it's cool. You guys are ready to go. But before that, you need to install TestNG plugin as well. It's available in the Eclipse Marketplace. All you have to do is go for help here and you have Eclipse Marketplace. Okay, it's taking time to load. Well, I've already installed, so let me not waste time here. All you have to do is go for Eclipse Marketplace. Once it's loaded, in the search tab, you can search for TestNG. And as soon as it's done, it'll show you the plugin. Click on that and click on install. It should be done. Once you've done that, all you have to do is go for Windows here and show view. And you can go for others. Okay, Marketplace is open. Since it's open, let me just show you guys. Okay. Sorry about that, guys. Here we go. And under Java, you should have TestNG installed. So if you have installed plugin properly, you will see TestNG here. That's all about it. Cancel. Okay. All you have to do is type TestNG and click on OK. So anyway, guys, all you have to do is find that in the search tab. You'll find it and click on install button. I'm not going to waste time here. Okay, here we are. Okay, here it is, TestNG for Eclipse. You can just click on install. It's already says install because I already installed it. Okay, back to our program. I've set up everything here because it takes time to write the code, right? So I do not want you guys to wait for this. So I've already written. I'll explain you the program. Don't worry about it. And under the source, I have a package called Edureka, and under that I have two classes, which is my main function and another class called read Excel file. So basically, main function, what it does is it checks the login functionality of a flight booking application. So that's my main testing function. And we have another file called read Excel file. And I've written this file so that it can read the data from the external source. And as for the external source that I am using in this demo, it's an Excel sheet. I have an Excel sheet called login credentials. I have that stored in my Selenium folder. It should be in Selenium folder. Let me open the file. Here it goes. I have a file called credentials and I have two fields in that. One is username and one is password. As you can see, I have username and password and 4 entries. So getting back to Eclipse, two functions. One is my main function, which chunks the functionality of a flight booking application. Another one, which reads the data from an external file. So we're good to go. Let's start exploring the functions here. Let's start with the main function. First of all, I've imported a lot of packages here, as in different libraries here. I have Chrome driver, I have annotations, which is after method, data provider, and test. So guys, first of all, annotations are very easy to understand. Annotations in TestNG are basically lines of code that can control how the method below them will be executed. So to use those annotations, you need to import the libraries attached to them. So I have used 3 kind of annotations here. One is after method, data provider, and test. So yeah, the library that's related to annotations is this one. Apart from that, I also have something called assert. As we progress through, we'll get to know what that is. And then there's Chrome driver. So let's get started. This is my main class, the main function. The name of my class is main function. And here I have a Chrome driver object. I've created an object called driver of type Chrome driver. As you can see, I've created it globally because I do not want it to include in the annotations, because all the functions which are written under these annotations will apply to that Chrome driver as well. So I do not want that. So I've written it globally outside my annotations. Anyway, then I have an annotation which says at test, and data provider is the name of the method is equal to test data. Let's move on to the next part of the code, which is demo project. So under this annotation, Like I said earlier, an annotation is line of code that can control how the method below it works. So my method here is demo project. So basically to this method, I'm providing a username, password, and login to keep checking. And how am I doing that? I'm using a command called find element. So driver.find element by name username, and the send keys is the username where it accepts the input. Then you have same for the password and login as well. For login, we do not accept anything because it's just a click button, right? So I have a function which says click. Apart from that, I'm also giving a link to the website in which I have to check the login functionality. That's the flight booking website. If you want, I can open it and show it to you guys. Let me copy it. Here we go to the browser and paste. So while it's loading, let's just get back to our Eclipse as in the program. Apart from giving the link and find element, I also have used something called set property here. As in I'm telling the program to automatically open the web browser. For that, I am using a Chrome driver here. So that's all about it. Now, here under annotation, I have something called data provider is equal to test data. What I actually mean by that is, here I'm giving username, password, and login. From where does all this data coming from? I'm saying extract the data from the method data provider. So obviously I should have another method which is called data provider, right? Here we go. I have another annotation which says data provider and the name is test data. Here under this annotation, I have an object called config, which is of type read Excel file. Read Excel file is nothing but another class or another file which I have created to read external data. So like going back to that function, this is where Apache POI comes into picture. Like I said, WebDriver directly cannot read from the external data. For that, I'll be using an Apache POI libraries. One is workbook, another one is sheet. So in this read Excel file class, I have a method. Well, it's not a method, it's a constructor because it starts with the same name as that of method, right? So yeah, it's a constructor. And the constructor, I'm giving a link to my Excel part. For you guys to understand this, let's just go back. So here we go. We're calling the config method as in the config object of type read Excel file dot Excel file, right? So here I'm giving the link as in the path where I've stored my credentials or the external data file. So whenever you call this object, the control goes here as an object of type read Excel file is created. So Excel path is the input which is taken here. As you can see, this is the input which I am calling the object with. So this will be stored in the Excel path and a new sheet will be created, as in the new sheet will be accessed. So getting back, I have some other functions here, sort of for the functions. Before that, let's go back here. As you can see, I've placed my entire code in a try catch exception block. Well, if everything works well, it shouldn't throw an exception. Well, if it does, then it's caught here and the error is handled. So this is just the basic before we actually start with the main function in this read Excel file. So the main function here is one is to get the string data as in the get data, and the one is to get the row count. Now you might be wondering, why do you need row count? Here we have automated the test and we want the application login functionality to be checked for different values, for multiple values, right? So we need for how many login and the details or the username password pair do we want the application to be checked, the number of times you want to check your application. For that, we need a function called getRow. Basically what it is doing is that it's taking the index of a sheet here as an input. For example, if I take you back to the sheet, it says here sheet 1, right? So 1 is the index of the sheet. So that's taking the index of that sheet. It goes to that sheet and there it's calling WB, which we just defined in the upper part web page. This WB already knows the path of where the sheet is. So using the get sheet at, it will receive the sheet and it will get the last row's number. Suppose, for example, in this sheet, I have 4 rows. So the last number should be 3. Because if you remember, the index starts from 0, right? So the value of row becomes 3. But again, 3 is not right value because there are 4 rows for us to understand. So I'm adding 1 more to the row. So it becomes 4. Now the value of row becomes 4. Basically what I'm saying is go to the sheet and count the number of values or the number of username and password pairs that are. So we have counted and the row value is now 4. Now here, other method is get data. So basically what we're doing in this get data is going back to our main function. Here I have a demo project method which is taking data from this data provider, and that data provider is calling for a get function. As you can see here, it's calling the get data function here. So I'm creating an object called credentials which has countable number of rows but 2 columns. As you can see, we have 2 columns which is login username and password, but the number of rows actually depends on how much data there is. As for here, we have 4 rows. So I hope now you understand why we actually counted the number of rows here, right? So here we call the rows and we have called the row count method, which will be 4. So this will be 4 and 2. So I've created an object of type array here, which we have 2 values. So it's 2-dimensional array. So now to get the data, I'm calling get data method and I'm passing 3 parameters as you can see. The first one is going back to the method. The first is a sheet number. Then you have the row and the column. So as soon as this method gets the parameter, which is sheet number, row and column, first of all, using sheet number, it goes to that particular sheet using WB. And once it has gone to that sheet, it goes to that particular row, particular column, and gets the value and stores that value in the data. And I'm returning this data back to the method which called this method, which will be in my main function. So the value is which is extracted by this method or which is written by this method is stored in this credential. Similarly, here again. So this way we are fetching data. And once the data is stored, I'm saying written credentials, which will go back to this demo project because in the annotations, I have said extract data from this method, which is data provider. So from data provider, all the data which we just extracted will go here and will be assigned in the username, password. Once data is extracted, it will be clicked on login. So I hope you've understood, right? I hope it's not confusing. Let me just summarize quickly. So if you have not understood, you will understand it at least this time. So basically I have a Chrome driver which is defined outside because I do not want it to be included in the annotations which have different other functions. So the first method I have is demo project. Here I'm defining a set property as in I'm saying open the browser by default here. And I'm giving the link as to which application needs to be checked. And I am giving 2 inputs which is username and password and click on login. I also have a method which checks if the login was successful or not. If it's how am I doing that? I'm using assert function here. It checks if the title is Find a Flight Mercury Tours. If after logging in, if it's the title, if it finds, it means that a login was successful. Otherwise, it'll just print you invalid credentials. So I have another annotation called after method. This is basically executed after all the methods in this program are executed. So basically in the end, it quits or it ends the program. And then I have a method called data provider. As you can see in the annotations, I have a data provider. How does the data goes in to this demo project from this data provider method? In data provider method, I have an object config which is of type read Excel file, which is another file of mine where I've created a class called read Excel file. Under that, I have a function which is placed in between try and catch exception where it takes to the Excel path. Now, getting back to main function, we need to extract the input and put it in the username password here. For that, I'm counting number of rows because I have to repeat the testing of application for different inputs. For that, I need to know how many inputs are actually there. So for that, I've called a get row count here. That method basically what it does, it takes the sheet index, it goes to that particular sheet and it gets the last row's number. Once it does that, I'm adding one more because in human language, the index doesn't start from 0, it starts from 1. After that, I'm returning the value, which literally goes back here in rows. So the row value in this demo will be 4 and 4 will be stored here. Now, based on that, I'm creating another object of type array, 2-dimensional array. And then I'm calling get data method to fetch the details, one for the password and one for the username. How am I doing that? I'm calling a get data method where I'm passing parameters, sheet number, row, and the column. Here we go. Once the function is called, it goes to that particular sheet number by using the path which is stored in WB. After that, it goes to that particular row, particular column and stores the value and returns back the value which will be stored here. Similarly here. So this way, login ID, the username and the password are fetched. Then I'm returning this credentials back to my demo project. using username and password here, strings, which will be stored in this username and password, and the application will be checked for that particular value. So guys, I hope you've understood the functionality of the program, right? Now let's just run and check if it's working. So I'm going to click on this run function here, run button. As you can see, it has started running. So basically, as you can see, I have 4 values in my Excel sheet, right? So it will check if the application is logging in properly or not for all the 4 values. So it has checked for the first value. It says login successful because I created an account for that credentials. And it's checking for the next, which is company, and the password is also company. It's going to take a while. So guys, the login was successful for the second value as well. And it's checking for the third value, which is admin. It says it didn't work. So it's going for the next value. Here we go again. It's entering the username and the password. And again, the login was unsuccessful because the 2 users in my Excel sheet are not registered users. So it says the test was run 4 times and 2 times it failed because only 2 were the actual registered users and it skipped 0 values. So that's how you do it, guys. So now you know how to actually create a data-driven framework using Selenium. Go ahead and explore for other functionalities. Try to create hybrid framework, which is combination of keyword or any other mixture of any other frameworks. I have categorized the interview questions into basic, intermediate, and advanced level. So let's begin with the basic questions. So here goes our first question. What do you mean by term automation testing? Well, we've already discussed this. Anyway, automation focuses on replacing manual human activity with systems or devices that enhance the efficiency of our work. The process of using special software tools or some sort of scripts to perform testing tasks such as entering data, or it could be executing the test steps or comparing the results with the expected results is known as automation testing. So basically in automation testing, you're trying to replace the human who is performing the testing. Moving on to our next question. What are different types of automation testing? Guys, automation testing is basically divided into 4 to 5 categories, but the most popular ones are unit test, graphical user interface test, and functional test. So unit test, these are usually done at the development phase and they help reduce the bugs in the initial stage of development of software itself. Then we have graphical user interface test. These tests are usually done at testing level, and these tests are mainly written to focus if the test interface or the interface of an application or the software that you're testing on is working properly under certain conditions or not. Then we have functional test. Just like graphical user interface tests, these are also done at testing level. They simulate the functional scenarios to test if the application works properly or not for the provided input at different conditions. So basically here we are checking the functionality of an application or software or any item that you're performing testing on. Apart from these 3, we also have something called web service testing. Web service testing is testing of web services and its protocols like SOAP protocol, REST protocol, and all that. So automation testing is divided into about 4 to 5 categories, but the most important ones are unit test, graphical user interface test, and functional test. So guys, now moving on to our third question. What is an automated test script? An automated test script is basically a short program which is actually written in some sort of programming language to perform a set of instructions on the software or the application that you're testing on. So when you run this program, it gives the test results as pass or fail depending on if the application is working as per your expectations or not. So basically, whatever test you want to perform on the application or the software, you're writing it as a program or in form of program in the test script. And that's what we call automated test script. Next question. What are good coding practices that you should follow while writing test cases for automation? So guys, before you actually go ahead and write code for your testing, you need to follow certain coding standards. For example, you need to use comments at regular paces. You need to maintain separate file if you have functions that you want to reuse. And there are certain coding conventions that you have to follow, like colon and all that. And most importantly, you should regularly run your scripts to make sure that you do not make any error or there are no bugs in the code that you've written. So these are certain coding practices that you need to follow when you're writing code for your automation. This way, you will be sure that if you get an error, it's not because of your code. It will be because of the bugs which are in the application. Next question. Guys, this is most frequently asked question. Every interview, every test automation interview, this is a must or definite question, guys, which is, what is a test automation framework? A test automation framework is a set of guidelines used to produce beneficial results of automation testing activity. So basically, in simple terms, it's a set of guidelines or rules that every tester follows universally. The framework brings together function libraries, test data sources, object details, and other reusable modules, functions, and methods. So once you've adopted any kind of test framework, you can even extend the framework. For example, the guidelines which are set in any framework would be rules for writing test cases, coding guidelines for creating test handlers, or it could be input test data templates, or object repository management, log configuration, test result, and reporting usage. All of these are the guidelines which are listed in any framework. So make sure you get to know more about automation framework before you attend any testing interview. Next question. Why use automated frameworks? What are the benefits that they offer? First of all, guys, they established a universal standard for testers to achieve the specific goals of automated tests. They maintain consistency of testing. So basically, these are the rules which are followed by every tester all around the world. This way, they maintain consistency of testing. You are also provided with commonly used methods. This way, it improves the efficiency of automated tasks in framework. And even with the limited knowledge of how the test case is set up, a tester can easily depend on the framework to refer to simple statements and implement the test cases. You can easily reuse the test scripts for future purposes. So with a proper framework, the code is easier to maintain and often reusable. So technically, automation framework, when designed and implemented correctly, they deliver frequent and stable automated test code. So basically, in simple terms, is automation frameworks make the life of a tester much more easier, guys. One more question about automation framework. What are different types of automation frameworks that are available right now? So first we have linear scripting framework. Linear scripting framework is basic level test automation framework, which is basically in the form of record and playback in a linear fashion. This framework is also known as record and playback framework. This type of framework is used to test small size applications. In this type, creation and execution of test script are done individually for every test case. So this is the basic level test automation framework. Then there is data-driven framework. Data-driven test automation framework is focused on separating your test scripts that you have written from the test data that you want to test on. So it allows us to create test automation scripts by passing different set of data types. The test data set is kept in external files or resources such as Excel sheets, or it could be access tables or SQL database or XML files, etc. Then you have keyword-driven framework. This keyword-driven framework is also known as table-driven or action word-based testing. In keyword-driven testing, we use a table format to define some sort of keyword or action word for each method that we could execute in your code. Now, based on the keywords or action words which are specified in the Excel sheet, test scripting is done and tests are executed. By using this framework, since we are using keyword and action words, programmer need not know much about the scripting language here. Then we have modular testing framework. Here, tester divides the application into multiple modules and creates test scripts individually for each module. These individual test scripts which are written for each module are then combined to make larger test scripts by using a master script. This master script is used to invoke the individual modules to run end-to-end test scenarios. So basically, you divide applications into multiple modules. Then for each module, you write down a test case and then combine this test case according to your requirements using a master test script. And the last one is hybrid testing framework. Hybrid test automation framework is literally a combination of two or more frameworks that we just discussed. It attempts to leverage the strength and benefit of other framework for particular test environment it can manage. Apart from these five, you also have others, but these five are the most popular ones. Next question. What are prerequisites to start automation testing? So guys, before you actually start automation, you need to be aware of certain things. For example, you should make sure that the build for your framework is stable. You should make sure to filter the test cases which you need to automate. As in, you should be sure as to which test cases you want to automate and which not. You need to separate the functions which you will use repeatedly. And if you have certain functions which you want to use repeatedly, make sure you're storing in separate files. Make sure you have your application modules in such a way that their requirements do not change frequently. In such cases, automation becomes difficult. And the most important one, make sure you have skilled and experienced resources. This makes your automation much more easier. So these are certain points that you should keep in mind before you actually start automation. Moving on to our next question. What are the factors that determine the effectiveness of automation testing? There are certain key factors which help you decide if your automation was successful or not. First of all, obviously, the amount of time saved. Then you have the number of defects or bugs found after automation. The test coverage, as in literally one test covers how much data or how many cases, like that. Then you have maintenance time that you've spent on maintaining the automation software. Then the installment cost, the amount of money that you spend before actually starting your automation. Then the test case reusability, as in, is your test cases reusable or they're just not reusable as such. And lastly, the quality of the software that you're actually performing tests on. These determine if your automation was successful or not. And here we go, the most common question. What are the main differences between automation testing and manual testing? So when you begin testing, one of the primary decisions that you'll have to make is when you're going to test manually or use automated testing. So you have to be aware of distinct differences between manual testing and automation testing. The first point is obviously reliability. For a testing phase which is very long, let's say it's very long, there are high chances of an undetected error when testing is performed manually. So when you perform testing manually, you have to do tests repeatedly again and again. The task becomes boring and it's quite possible that you might overlook some errors. So in such cases, reliability is really less. Whereas in automated testing, you use different kind of tools and scripting to perform the test and find the bugs. So there's no chance of making any errors. So the reliability in automation testing is literally high. And again, in manual testing, it's humans who are performing the testing. And obviously, humans are a little slower when compared to machines, right? So the processing time is more in manual testing while compared to automation testing. And the important point is you cannot use manual testing in automation testing everywhere. There are certain cases where manual testing is suitable, and there are certain cases where automation testing is suitable. For example, manual testing is suitable for one-time task or exploratory or usability and ad hoc testing, whereas automated testing is suited if you want to perform tests repeatedly for long run or for regression testing or performance testing, etc. Apart from that, initial investment cost in manual testing is low, but the return of investment, as in the amount you get as a return after you perform your automation, is also less in manual testing. But when it comes to automation testing, initial investment cost is high and the return of investment is also high in longer run. So these are some basic differences between automation testing and manual testing. Let's move on to our next question. So is it possible to achieve 100% automation? 100% automation is definitely not possible, guys. There are certain test cases that cannot easily be automated. For example, checking the background color of a window or a dialog box. Well, why would you do that, right? It's a very simple task. Why do you need to automate or use machines here to perform the task, right? It's a waste of time and effort. Just like that, while we were discussing the differences, we also discussed certain cases where you actually cannot use automation testing. So 100% automation is definitely not possible. Next question. What are some conditions where we cannot consider automation testing? So just before discussing this question, we discussed a question where I said 100% automation is not a possible thing. It means that there are certain cases where you cannot apply automation. So what are those? So if you have a situation where the requirements of your software or an application keeps changing, in such cases automation becomes difficult because every time requirement change, you need to change your test scripts as well, right? So it becomes difficult. In such cases, it's suggested not to use automation testing. Similarly, if you have exhaustive documentation or if you have a requirement where you can apply only continuous integration or continuous delivery concept, then it's slightly difficult to apply automation testing. The another case is when you have one-time test cases, as in you need to test these test cases only once. So what is the point of using automation? Because it doesn't require much effort to test a test case only once, right? In such cases, manual testing is much more preferred. Apart from that, we also have ad hoc testing, exploratory testing, and user interface testing. So don't worry about them for now. We'll discuss what those three are as we progress. There's another question based on that. So for now, I'm just going to list them and leave them like that. Here we go. Our next question. How many test cases can you actually automate in a day? Guys, it totally depends on test case scenario complexity and the design and the length. So generally speaking, given the standard complexity of test cases, it's usually possible to automate a minimum of 6 test cases in a single day. Well, this is for me. So when I perform testing, I realized that I could test 6 test cases in a day depending on their complexity. But again, it depends on you. It depends on individual. If you are asked this question, you just have to talk based on your experience. And the next question, what are some modern applications of automation testing? So guys, like I said in the beginning, automation is literally everywhere. Every company is implementing automation in one or the other way. For example, Amazon is testing delivery drones that pick up warehouse orders which are sorted by robots, whereas Google is testing self-driving cars. Then you have Starbucks, which is testing cashier-free stores dedicated to mobile ordering and payment. And Facebook is testing a brain-computer interface that may one day translate your thoughts into digital text. Well, these are some mundane versions of automation technology. Apart from this, there are other innovative ideas that are coming up regarding automation. Fascinating, right? So let's move on to our next question. Is documentation actually necessary in automation testing? Guys, documentation plays a critical role in test automation. So whatever the practices that you follow while automation should be documented so that they are repeatable, as in you can refer to them later on if they are documented somewhere. Like specifications, designs, configuration, code changes, automation plan, test cases, bug reports, user manuals, all should be documented so that later on you have somewhere where you can refer to if you have forgotten or if you have made any mistake. This way, documentation plays a very important role in automation testing. So here goes one more tricky question that you might be asked, guys. Can automation testing replace manual testing? Well, according to me, automation testing isn't a replacement for manual testing. It's just a continuation of manual testing. So no matter how great automated tests are, you cannot automate everything, right? We even discussed the cases where you cannot apply automation. Manual tests play an important role in software development and come in handy whenever you cannot automate test cases. Automated and manual testing, each of them have their strengths and weaknesses. Manual testing helps us understand the entire problem and explore other angles of test with more flexibility when compared to automation. But automation testing helps save time in long run by accomplishing a large number of surface level tests in very short period of time. So what I want to stress here is that automation testing is actually not replacing manual testing. Moving on to our next question. What are some popular automation testing tools that are used worldwide? So in the definition itself, we have automation testing is process where it uses assistance of tools and scripts to perform testing. So obviously there are a whole lot of tools that can be used in automation for different purposes. Some of the most popular ones include Selenium. It's a popular testing framework to perform web application testing across multiple browsers and platforms like Windows, Mac, Linux, you name it. Then you have Water, which is pronounced as water. It's an open source testing tool made up of Ruby libraries to automate web application testing. Well, don't get confused with the spelling, it's WATIR, but still it's pronounced as water. Then you have Ranorex. It is flexible all-in-one GUI testing tool, which you can execute automated tests flawlessly throughout all environments and devices. Then you also have Appium. It's an open source mobile testing automation software. It's free and it supported highly active community of developers and experts. Well, these are just the scrape, or I can say very few of the tools which I've listed here. There are multiple other tools that are popular for different purposes. Our next question, when should you prefer manual testing over automation testing? Well, earlier we discussed when you cannot use automation testing. Now let's discuss when can you actually prefer manual testing over automation testing. First of all, when you have short-term projects, even though automated tests are aimed at saving a lot of time and resources, it still takes a lot of time and resources to design and maintain an automation test case or any such automation. So in some cases, such as building a small promotional website, it can be much more efficient to rely on manual testing rather than automation testing. It saves a lot of effort and time on your part. Other one is user testing. This is an area in which you need to measure how user-friendly, efficient, and convenient the software or the product is for end users. So basically, here you're representing an end user. Well, it's not possible by machines, right? Human observation is the most important factor, so manual approach is much preferable in such cases. Then you have ad hoc testing. In this scenario, there's no specific approach. It's totally unplanned method of testing where the understanding and the insight of the tester is the important factor. So again, manual testing is much more preferable in ad hoc testing. Apart from that, we also have exploratory test. This type of testing requires testers' knowledge, experience, analytical, logical skills, creativity, and intuition and all that, which is definitely not possible by a machine. So yeah, even here, manual testing is preferred. So we are done with the first set of questions, which are the basic questions that you might come across in the interviews. Now let's move on to the next level of questions, which I call it intermediate level. Here we go. So when is automation testing useful? Which test cases to automate? So guys, like I said earlier, it's impossible to automate all testing. So it's important to determine which test cases should you actually automate. When it comes to figuring out where to start automation, there are some top candidates. Like first of all, repetitive tasks are primary candidates for automation. Because if you're implementing manual testing here, it takes a lot of time and the task becomes boring because when you do the same task again and again, it definitely becomes boring and you will make mistakes. So in repetitive tasks, automation is much better. Then you have certain cases where you might have to capture results and share it with other people. So rather than manually exporting your data, crunching the numbers and making such pretty complex graphs, you can invest in a tool or automation strategy that will do this task for you. You can also use automation in the tasks that require multiple data sets. So rather than manually typing in information into forms or fields or automate this process to read in information from a data source and automatically type into the respective forms. This way your time is saved. Then you have certain cases where you have to screen the response as in how the interface is performing, or such cases you do not have to just sit and stare at the screen as in how the interface is behaving. You can just automate and look for the bugs later. Another example where you can apply automation is your non-functional testing types. For example, load testing. Suppose let's say you're testing a software and you are testing it for some 10 cases, then manually it's preferable. But suppose if you have to test for 10,000 cases, then it's better you use automation. And you can also use automations for the test cases that run on several different hardware or software platforms and configurations. So guys, these are certain test cases that you should consider for automation. Another important question, guys, how do you actually implement automation and what would be the steps that you need to follow? First of all, you should define your goal for automation testing and define which types of test cases are you going to automate. So once you're sure of what kind of test are you actually performing, you need to select the right appropriate tool according to your requirements. Next, you define the scope of automation as in you decide which test cases to automate, which not to automate, separate repetitive functions and all that. So after determining your goal, defining the scope of automation and selecting the type of tool according to your requirements, you should start planning, designing and development, as in you should start writing your test scripts. So you create your test scripts and develop test suites to hold your test scripts. Next step is execution. You can execute the tests that you have written using an automation tool directly or through test management tool, which will in turn evoke the automation tool. So this way you can execute the test cases which you have written. The other important thing is once you have done with your automation, the case doesn't end there. As you keep adding new features to your application or software, automation scripts also need to be added, reviewed and maintained for each release cycle. So maintenance also plays a very important role. It becomes necessary to improve the effectiveness of your automation scripts. So these are the basic steps that you follow while implementing automation. So you need to know why you're actually performing automation. Then you select the right tool. Then you decide on which test cases to actually automate. Based on all this requirement tool and which test cases, you need to develop a test script. Once your script is ready, you need to execute the test scripts, note down the results, and as soon as your application keeps changing, you can keep updating your automation scripts as well. So these are the steps that you follow. So guys, here's another important question. What are different approaches that you can take to test automation? You have something called code-driven approach. Here the focus is mainly on test case execution to find out if various sections of the code that you've written are performing as per expectations under different conditions or not. So basically here you're checking if the application or the code that you've written to test the application is performing right or not under different conditions. Then you have graphical user interface testing, or GUI testing as we call it. So applications that have graphical user interface may be tested using this approach. It allows the testers to record user actions and analyze them any number of times. For example, let's say you want to test a website. You can use framework like Selenium that provides you with a record and playback tool using which you can authorize your test without having any knowledge of scripting language. So test cases here in graphical testing can be written in a number of programming languages like C#, Java, Perl, Python, and many others. And then you have test automation framework. We already discussed this, but anyway, framework is a set of guidelines which are used to produce beneficial results of automated testing activity. The framework brings together function libraries, test data sources, object details, and other reusable modules. Basically, it sets up a universal standard that all testers can actually follow. Moving on to next question, what are the points that are covered in the planning phase of automation? So earlier we discussed different set of steps that you need to follow while performing automation, right? And there's one phase called planning phase. And the points that you have to keep track of in this phase include deciding on the right automation tool, deciding if you want to actually use automation framework as the approach to automation or not, defining the scope of your automation, configuring your test environment details, developing test cases, developing test suites, and identifying test deliverables. So all these are the points that you should consider in the planning phase of automation. The next question, how to decide the tool that one should use for automation testing in their projects? So guys, the first step in automation testing is to select a proper tool that suits your requirements. But how do you actually go ahead and select a tool? Based on what criteria? First, you need to understand your project requirements thoroughly, and then you need to identify the testing scenarios that you actually want to automate. Based on these requirements, you make a list of tools. Once you've made the list, for each tool, identify the budget and select the tools which are within your budget. After that, compare the tools which are remaining in the list using some criteria like is it easy to develop and maintain the script for that tool or not? Does it work on platforms like web, mobile, desktop, and other platforms? Is it based on your project requirements? Does the tool have a test reporting functionality? How many different testing types can this tool support? How many other languages does the tool support? So once you've compared different tools based on these criteria, select the tool which is within your budget and supports your project requirements and gives you more advantage based on your key requirements. So that's how actually you select a tool which suits your requirement, guys. Now, what are the primary features of a good automation tool? First thing you need to consider is if or not the tool is easy to use. Because if you choose a tool which is difficult to use, then there's no point in using automation. Automation is implemented to make our task much easy so that we don't spend much effort on our part, right? So you need to select a tool which is easy to use and understand. And you need to check if the tool is compatible with platforms and technology that you're using. It should also include features like implementing checkpoints to verify values, databases, or key functionalities of your application at definite points. And also check if the tool does have record and playback support. Apart from these, you can also check if the tool has good debugging facility, robust object identification, object and image testing, and all that. One more point, you can also see if the tool that you're using supports automation framework or not. So these are certain features that very good automation tool has. Moving on to next question. On what basis you can map the success of automation? So on what basis can you actually decide if the automation is successful or not? We did discuss few points earlier, but let me just repeat them. The main points are the defect detection ratio, or you can say the number of defects that you have found out after your automation. Second, the amount of time that you've taken to execute the automation. And finally, the amount of reduction in the labor cost. These are the three key points or strategies or criteria that you should consider while evaluating the success of your automation. Now, what are the scripting standards that you should follow while performing automation testing? Just like you have certain coding standards that you should follow, there are something called scripting standard that you should follow while writing your scripts. For example, you need to maintain uniformity naming convention, commenting the functionality whenever and wherever it's necessary, adequate indentation. Indentation is really very important concept. It changes the meaning of your code entirely if you have done it in the wrong way. Robust error handling, and ability to recover, use of frameworks, and all this. What are the differences between open source tools, vendor tools, and in-house tools in automation testing? Very simple, guys. Open source tools are free to use frameworks and applications. Engineers build these tools and have the source code available for free on the internet for other engineers to use. So such tools, we call them open source tools. Then we have vendor tools. These are developed by companies that come with license to use. So they cost money very often. And because they're developed by an outside source, technical support is often available if you have employed the tool. Better examples for vendor tools include Windrunner, Silk Test, Rational Robot, QA Director, QTP, RPT, and many others. And as for in-house tool, it is a tool that a company builds for their own use. Rather than purchasing vendor tools or using open source tools, a company builds a tool for its own purpose. Those tools we call in-house tools. So open source tools are free and available on internet. You can go ahead and use the source code. As for vendor tools, you need to have license to use and you often have to pay a lot of money. Then you have in-house tools where companies build those tools for themselves for their use. Moving on to next question. What are the advantages of using an automation framework? So here we go, guys. Another important question about automation frameworks. So what are the advantages of using framework? First of all, they save you a lot of time. You can reuse the code any number of times and they offer you maximum test case coverage. Automation framework, they come with a proper recovery scenario and debugging facilities, and obviously minimal manual intervention as well. And they also provide you with easy reporting features. As in, once you're done with automation, you can easily create reports and share it with other people in your company. So these are some advantages of using automation framework. Next question. What are the important modules of test automation framework? Every test automation framework has some important modules. For example, you have test assertion tool. This tool will provide assert statements for testing the expected values in application which is under test. An example for test assertion tool, you have TestNG, JUnit, and many others. Then you have something called data setup. So whenever you've written a test script, the test script works on some sort of data, right? And you need to actually take the data or you need to have a source of data. So each test case needs to take the user data either from the database or from a file or embedded in a test script. To manage all this, we have a module called data setup. Then comes build management tool. Using this tool, you can actually manage how to build your framework according to your requirement. This way, you can easily write your test scripts and manage them. Then you have continuous integration tool or CI/CD tool. These tools are required for integrating and deploying the changes which are done in framework at every iteration. Then you have reporting tool. A reporting tool is required to generate readable report after the test cases are executed. This way you get better view of the steps, results, and the failures of your automation. And lastly, we have something called logging tool. The logging tool in framework actually helps in better debugging of error and bugs. So if you have the log of whatever you have done throughout the course of your automation, it will be easier for you to find out the bugs and debug them. Here comes our next question. What are some popular automation testing frameworks available? So let me list out a few popular framework testing frameworks. Well, to name the most important ones, I have Apache JMeter, Selenium, Appium, Google or Gray. Apart from this, you also have TestNG, Cucumber, Water, Robot Framework, and many others. Make sure you go ahead and refer to other lists on internet so that you will remember many names as possible. So guys, what I meant to say is there are other popular frameworks as well apart from the just ones which I just listed now. Moving on to our next question. What do you think are the use cases where implementing automation is actually not suggested? Well, we already discussed this, but let's go a little deeper. One of the key testing principles is that 100% test automation is definitely not possible. We discussed this as well. So manual testing is still necessary. Let's see which test cases cannot be automated, or I could say would take too much effort to actually automate. We did discuss about test cases which you need to execute only once, when you have exhaustive level of documentation and all that. Apart from this, I listed out 3 other cases if you remember, which is ad hoc, exploratory, and user interface testing. Let me explain these 3 concepts to you guys. So first of all, you have ad hoc testing. Here, testing is done without actual preparation and you do not have any written test cases. So during ad hoc testing, a specialist randomly tests the functionality of system. Basically, his goal or his aim is to be creative and break the system and discover flaws, which might be not possible when you're actually using a machine. I mean, in case of automation. So in such cases, it's better to use manual testing rather than automation testing. Then we have something called exploratory testing. During exploratory testing, a specialist or a tester tests a product like an explorer, as in he relies on his personal experience. After getting the full picture of product's functionality, he designs test cases which he seems right. So in exploratory testing, you have to rely on your personal experience and design test cases. So it's definitely not suggested you to use automation testing here. Then comes user interface testing. One problem with user interfaces is that the requirements for user interface keep changing. Well, like I said earlier, it's not suggested to use automation when the user requirements keep changing because you might have to change your automation script again and again, which will be a hard task. So although we could automate basically everything, manual testing still provides an effective and quality check of bugs and inappropriates in some situations. Now, what are the advantages and disadvantages of using automation testing? Well, after listening so much about automation testing, I'm sure you guys can list it out. So automation tests, they simplify the test case execution. They save a lot of time and money on your part. They improve the accuracy and reliability of your software test. They increase the amount of test coverage, also the speed of test execution as well. They reduce the maintenance cost, and they give you high return of invest in case of long run. Talking about disadvantages, maintaining developing test cases is a little difficult. Initial investment is high. You need to have skilled resources. This way, they can actually make proper use of the automation tool that you're implementing. Your environment setup is a little complex while automation. Debugging test scripts is also an issue sometimes. So these are certain advantages and the disadvantages of using automation testing. So guys, here we're done with the intermediate level questions. And then we have advanced level questions. When I say advanced, doesn't mean they have very long answer or something like that. It's just that they're a little tricky and you need to have proper knowledge to answer these questions or in-depth knowledge to answer these questions. So let's continue. So the first question in advanced level is automation testing a black box testing or a white box testing? Before I go ahead and answer this question, let me explain you what black box testing is and white box testing is. First, about black box testing. Here in black box testing, internal structure, design, implementation of any software product or an application or user interface that you're testing on, the user will not know any of these details prior to testing in black box testing. But when it comes to white box testing, details like structure, design, implementation, and all this, the user will know about. So basically, black box testing, you are actually performing tests without any prior knowledge. Whereas in white box testing, you do have certain idea of what actually you're performing tests on. So now, is automation testing a black box or a white box testing? Guys, automation testing is mostly a black box testing as we just program the steps that a manual tester usually does without any prior knowledge of application. But sometimes automated test scripts need access to database details as well, which are used in the application. In that case, it again becomes a white box testing. So automation testing can be both black box or white box depending on the scenarios in which automation is actually performed. Moving on to our next question. What are the attributes of a good test automation framework? A test automation framework which is considered to be good should be modular, as in it should be adaptable to change. Testers should be able to modify the script as per the requirements. Next, it should be reusable. Suppose if you have any methods or functions which you want to reuse, make sure you put them in a separate file so that you can access them later. And your framework should support this feature. Next important feature is it should be consistent. The suite that you're developing for your framework should be written in a consistent format by following all the coding practices and the scripting practices which we discussed earlier. Then obviously independent. The test script should be written in such a way that they are independent of each other. So in case of one test fails, it should not hold back the remaining test cases. Then you have a logging feature, as in your automation framework should have a login and reporting feature. Like I said earlier, logging feature helps you to find the bugs in the earlier stage itself and easily debug those bugs. For example, let's say if the script fails at any point of time, having the log file will help you detect the location along with the type of error that you're actually encountering here. Similarly, it should also have a reporting feature. It's good to have a reporting feature. So once the scripting is done, we can have the results and reports sent via email. Lastly, it should also support integration. Automation framework should be in such a way that it's easy to integrate with other applications like CI/CD. So these are some features that a good test automation framework must and should have. Moving on to next question. What are test automation framework development challenges? Obviously, while developing a framework, you will come across certain challenges. First of all, setting the scope of automation might be a difficult task. That is, you need to know properly which test cases to actually automate and where to use automation framework, if or not you should use your automation framework for such test cases. So deciding on that part is a little difficult. Then, identifying the requirements of your test case is also a difficult part because since your application or software keeps changing, you need to be aware of your requirements. Lastly, selecting the tool. There are plethora of tools out there, so choosing a tool out of them which suits your requirement will be difficult. So in such cases, you can follow the rules which we discussed earlier or the steps to select a proper appropriate tool which suits your requirement. Moving on to our next question. What is data-driven testing? If you remember, this is a type of automation framework we discussed. So major use of automation testing is to simplify the testing process which involves complex and huge data sets by documenting the same details. As in data-driven tests is used when you have large or huge amount of data sets that you have to deal with while testing. So in data-driven testing framework, the test data includes input files, output files, and the result field. And these fields are included in files like CSV, Excel sheets, XML files, etc. So once you have all the test data in these files are fed to an automation tool for execution, which in turn compares the expected and the actual data. Then it documents the result of each test data into the resulting field in those files. So that's what data-driven testing is all about. As you can see, you have a data file and you have an expected output which is compared to actual output. But before that, you have test data and all your input and all that. That's fed into your driver script or the automation script which you write. And the script is implemented on your application. This way you get the results and then you compare the expected output with your actual output. This is how data-driven testing is done. Next question, what is TestNG? Let's list out some of its prominent features. So guys, if you remember, while listing out some of the most important test frameworks, I listed TestNG as well. So basically, TestNG is an open source automation testing framework where NG actually means next generation. It is inspired by another kind of framework called JUnit and NUnit. It is designed to be better than JUnit actually, especially when it comes to testing with integrated classes. The creator of TestNG is Cedric Bust. TestNG gives the developer the ability to write tests more flexibly and more powerfully. And some of the most prominent features of TestNG include it supports annotations. Annotations play a very important role. It also supports Java and OOPS concepts. It supports testing integrated classes. For example, by default, you do not have to create a new test class instance for every test method that you use. It also has flexible runtime configuration. It introduces a concept called test groups. So once you have compiled your test, you can just ask TestNG to run your front-end test or fast or slow or database test based on the way you have listed them. It also supports dependent test methods, parallel testing, load testing, and partial failure. Apart from this, it offers plugin API and supports multi-threading as well. Cool, right? It has a lot of features. So what are the features or the advantages TestNG has over JUnit? First of all, the most important feature is annotation. Annotation in TestNG are very easier to understand. They are just lines of code that can control how the method below them will be executed. For example, as you can see, I have an image there on the screen. You can see I have two annotations here. First one is with priority 0 and next one is priority 1. So basically using these annotations and priorities, I'm saying that execute this method before you actually go ahead and execute other method. Apart from annotations, other features include test groups can be grouped very easily. Like I said, you can just go ahead and ask TestNG to run your front-end test, fast or slow or database test based on the way you have listed them. And it supports parallel testing, which is not there in JUnit. Moving on to the next question. In what conditions we cannot use automation testing for Agile method? Guys, the titans of information technology like Google, Amazon, Facebook, they develop software at very rapid pace. So to meet the demand for their products and services, they mostly use Agile practices. Test automation is fundamental part of Agile, but there are certain times where automation testing in Agile is useless. For example, when you have exhaustive level of documentation, when the requirements of your application of the software you're testing keeps changing, in such cases, automation is definitely not suggested. Also, if you have one-time task and exploratory test edge cases, automation should not be implemented. So these are certain cases where automation testing becomes useless in agile methods. Our next question, what are some best practices that you should follow while automation testing? So guys, to actually get maximum return of investment, you need to keep track of certain points while actually performing automation testing. For example, the scope of automation needs to be determined in detail before the start of automation. So this way you actually know what you're actually automating and what you're expecting from the automation. Next off, you should select the appropriate tool that meets your requirement. A tool must not be selected solely based on its popularity. You need to select it only because it fits your requirement. You need to decide if you want to use framework in your automation or not. So apart from selecting framework, tool, and defining the scope of automation, you need to follow certain scripting standards. Standards have to be followed while writing the scripts for automation. We discussed them earlier, the standards, like regularly including comments, proper indentation, adequate exceptional handling, etc. Next, you need to check if the automation that you performed is successful or not. To check that, you can use criteria like the number of defects found, the number of time taken to actually perform the automation, and the time required for automation testing for each and every release cycle, customer satisfaction index, productivity improvement, all these features you can consider. So these are certain points that you should keep in mind when you're actually performing automation. So the last question, what are the risks associated in automation testing? So guys, just like manual testing, automation testing also involves risk. First of all, you need to ask yourself if or not you have skilled resources. Automation testing demands resources with some proper knowledge about programming. So if the people that you're actually automating or writing test script doesn't have any knowledge of programming, then definitely there will be some sort of error in your test cases, right? So you need to make sure that you have skilled resources when you're actually starting your automation. And you should also ask yourself, are the resources which you have hired capable to adapt easily to new technologies or not? And the second risk is the initial cost for automation is literally high because you have to buy a lot of tools and a lot of other things. So make sure that the amount of money you spend compensates the testing results. And it's suggested not to use automation if you are using it for user interface, because like I said earlier, when you are testing in user interface, the requirements keep changing and it's difficult to keep updating your automation scripts based on the changes. So if your UI is not fixed, do not use automation. And next, make sure that the application you're testing is stable enough. Else you might encounter a lot of errors while automation testing, and it will take a lot of time and effort to debug those errors. And lastly, stop automating the tests which run only once, because it does not worth the time and the effort on your part, because you're running those tests only for once. So what is the point of applying automation here? So avoid automating such test modules. So these are certain risks which you might encounter when you're performing automation.
And with this, we come to an end with this automation testing full course. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. Do look up for more videos and playlists and subscribe to the Edureka's YouTube channel to learn more. Thank you for watching and happy learning.